Hello there, welcome to dApp Mentors. This is Darlington Gospel. I'm really glad to come up here today and to share with you a tutorial that I've been working on. Today is going to be awesome, and it's based on the previous knowledge that you've gathered on Rust and Solana development and also Anchor development in the Solana ecosystem. So today's project will be building a crowdfunding system. You see, the last time that we worked on a smart contract and a full decentralized application, we focused mostly on familiarizing ourselves with the Anchor framework and how to build programs with it, which is cool. And we built a cool smart contract, interacted with it, and even hosted it online. The thing is that in that smart contract, we did not learn we didn't gain the knowledge of movement of money, transfer, management of fund, and making sure that fund splitting is a deal. So in this particular tutorial, we're going to be doing just that. We're going to have a full smart contract built, and we're going to build it from a perspective of code splitting, code chunking. We're not going to build everything in one piece of file. We're going to be putting them in multiple files and import them into the program to make it much more cleaner, much more manageable, and much more precise. That is what we're going to be doing, and we're going to learn how to move money from one account to the other, how to cut out certain percentage from the money and all those things. Like the platform that we're building is a crowdfunding system, so where we have creators create a campaign, and once donation comes in, donation gets stored somewhere in the PDA of that particular campaign, and the authorized user, which is the creator, can access that fund, and during the access of that fund, if 5% or whatever amount that we set is shared with us as the platform, we get that 5%, and the creator get to keep a 95% of the fund. So these are the ideas that we're going to be putting. We're going to do some really cool and amazing stuff, and we're going to build the entire dApp. So we'll start with smart contract, we'll test everything, and then we'll integrate it on with a browser interface, which is basically Next.js, and you have everything working fluently. This is a really exciting project. I am very excited to work on this project with you. And please, if you have not hit that like and subscribe button and notification bell, please do so that you will not miss out anything we'll be dishing out on this platform, on this channel. It's very important that you do. Show some love and do that for us, and that will make you blessed. So with that said, let's jump into the tutorial. I'll start with a demo right now. So why don't I show you what we built? This is what we built: a crowdfunding system, really sleek. My account is connected, and this is one of the campaign that I created. Let's look at it. So I'm the owner of this campaign. We can also change account. I'm going to disconnect here. You see everything is happening. I have Redux added to this. You can see withdrawal history. You can see donation history as well. You can see if the campaign is active or it's not, and if you can see if it has reached its goal or not. You can see number of donations, number of withdrawal, who this person is and who is not. And if you click on this, it literally takes you to where the account is on the chain. You can see that this is basically where it is on the block explorer. So everything is just all great. That is an example of it. I'm going to actually just create everything from scratch. Let me make sure that I am signed into, let's say, this account number 1. So I'm going to get into the account, connected. I'll come here to create a campaign. Here you can check if you have any campaign record, and this enables you. I'm going to get to these places. This will enable you as the owner of the platform to set whatever percentage that will be charged for every single withdrawals that happen on this platform. So I'm going to come here to create a campaign. You can also create a campaign right from here. And what kind of campaign do we want to create? So let's look for a dummy campaign online to help us get this thing together. I think I found one. Okay, so we have one that look like, I'm getting this, from GoFound, that is GoFundMe, okay, just for demonstration purposes. So basically, this is a title that I'm getting. I'm getting this peer storm damage repair, and we can see something like London. I'll see London storm damage. Okay, so I'm gonna get an image. All right, so I'll copy image address, paste here. So this is an image, and I'm gonna grab a simple, statement. Okay, so here we go. Okay, so I guess this is the name of the person, so I'm gonna just put it here. Okay, so there we have, and then you can then specify the amount of the amount that should be donated in Solana token. So I'm gonna say 45.78. You can't go more than this. This is the maximum decimal place. So you can click on create, and this, because I'm on localhost, so it doesn't have access to the information about my account. So I'm going to click approve, and make sure that you have, some, of course, when you're in localhost connection, you can always have access to a gazillion, bunch of data. Okay, so I also want to do this. So I'm going to look at this. Whenever this is created, any transaction is completed, we often log out the transaction record for that. And with this, you can come here and paste. You can paste this transaction record, and you'll be able to see information. Try again. Okay, I think it's having some problem. Okay, I'm on the wrong network. It should be in this, sorry. So I'm going to paste this. So you can see this is a record. You can see these are all the things that happen, the accounts that were involved in the creation of this. This is the data. Okay, and you can see that this is an instruction for creating a campaign. So I've been able to create this campaign. If you come here, this should be the campaign right here. Okay, and you can view the campaign, and people can make donation. Okay, so I could change my wallet address to this dev2, and you see I'm connected right now, but it doesn't allow me to edit, nor delete, so which is cool. So this is how many Solana token that is remaining for this account to be completed, so like to reach its goal. So I would say something like I want to donate 15.5 Solana token. So I'm going to donate that. So click on confirm, and just watch. There is no record of donation yet, and just look at all this will be updated instantly in front of you, and that is because of the use of Redux under the hood, which is really great. Okay, so you can see donation has been added. Number of donation is 1. You can see this amount right here. So I'm going to now when you come here, when you check on the console, you'll be able to see this transaction record as well, and we can check out this transaction record here, and you can see that this is an instruction for donation. Okay, and you can see the accounts that were involved. Okay, so this is the 5 Solana token, 15.5 Solana token that was sent to this campaign. This is the campaign record. So the campaigner has 15 point something Solana tokens, okay, which is really, really cool. And this is the donation that happened. This is the creation of the account. Okay. This is not the same day. This is a different day. So that is it right there. And let's disconnect at this moment, and let's connect back with that creator account. And within this creator account, I can see, and I can donate like let's say 9.3 Solana token. I can also donate as the creator, all right, and confirm. I just want to make sure that you can see even how this progress bar, or funding progress is going up. It's just increasing, which is really, really cool. Yeah, I guess the only thing you can see that happened like right in front of us. You can see the number of donations, and each person that donates, you can actually track their record on the chain. You can see how it's happening. This is how much this person has their balance on the chain. So you can have all those things happening. I spent quite a lot of time packaging this, in this format, and this is really responsive as well, because if I put this on the right side of this Docker, and let's look at an iPhone 12. Okay, so yeah, I can shift this a little bit. iPhone 12. Okay, so you can see how responsive this is. Just very responsive, good looking, and all that. So I made sure that is a thing here. Put that back at the bottom. And so at this point, we can edit, we can delete, if you want to delete, you have this thing, but we want to delete it, you can pay out. Okay, so look at this amount. This is amount that is actually available. Okay, this is what is available. So let's say we want to withdraw like 5 Solana tokens on this one. Take note here that we already have one withdrawal here, so this is going to be like 2 withdrawals. Okay, I want to show you how the money is distributed, between the 2 accounts. Let me open this. Okay, so I'm going to copy this address. Come here, check it out on the Solana Explorer. Okay, now look at this. This is the account of the creator. I withdrawed. It was 5 Solana tokens that I withdraw, and when you remove 7% out of it, okay, when you remove 7%, this is what you get. So this is what the creator gets, 5, and it's going to the creator's account. And this is the platform fee. This is what 7% looks like. 7% of what's it called, a Solana token. Okay, so this is what 7% looks like. This is the account of the platform, the address of the platform. Okay, where the money is the 7% is going to. This is where it is, and this is the balance from that particular campaign that we're withdrawing from. This is the campaign we're withdrawing from. So these are the various things, and you see everyone is receiving the money and everything is good, everyone is happy. Okay, so this is basically the program in total. All right, I think I may have to just do one more step here. I'm going to disconnect here, and let's reconnect with this account. Okay, so as I've connected to this account, you can see this is the current 7%. I want to take it like back to 5% now. I can do that by here, because this is the deployer's account. This is the main payment address and all that, so it has access to update the service fee on our platform. All right, so this is basically all that you need to know at this point. You can see this has been updated, and you can see that 5% straight up. So we have quite a lot of work, and that is how our program is running. This is how our project works, and I think it's pretty fantastic, and I can't wait to start crushing it with you. So in the next part of this video, I want to show you some diagrams, some architectural flow of this program, so that you can understand what we're doing under the hood here. So I'll see you in the next part of this video. Okay, so this is the diagram in a nutshell, okay, that makes up our program, which is basically called Fundus. I think it's called Fundus Crowd. Check it out here. sorry. So Founders Crowd. Okay, that's the name of the program. Okay, so when you come here, what happens is these are the state variables that makes up this particular program. We have different things. Okay, so but don't keep your eyes too much on this. Let's focus on this. What we have is two major things that you need to take note of. We have a campaign and then we have a transaction. Just know that a transaction belongs to a campaign. A transaction can either be a donation or a withdrawal, just like you've seen from that program. I think I should just come here, localhost. Okay, let's see, just as you've seen here. Okay, so this is a campaign, and a campaign has transaction. A transaction can either be, a donation or a withdrawal. And how do we differentiate that? There is this thing called credited, which is a Boolean key that I use to determine if that particular transaction is a credit transaction. If it's a credit transaction, that means it is a donation. But if it's not a credit transaction, that means it's a withdrawal. All right, so that is the difference there. And a transaction is, what's it called? Each one of these transaction belongs to a campaign. We have campaign ID, CID here. You can see the campaign ID here, so they are linked together on that particular basis. All right, and a campaign has an owner, which is this creator. So this creator is the same as, okay, this is the creator, and this is the owner is the one that make the payment. Okay, whether it's the one withdrawing or the one donating, so it's different from this creator. Okay, we have the amount that was carried out from that transaction, the timestamp, and this other one. Okay, this is basically going to be like an ID for the PDA. Okay, so this is the PDA, so the program derived address. And the same, each campaign has a program derived address, each transaction have a program derived address, and a campaign has an ID, which is the program derived address. It has a CID, which is the assigned ID that we're giving to that campaign. The creator, which is the one that is creating that campaign. A campaign has a title, a description, an image URL, like you can see from the form that we filled up. A goal, this is like how much are we aiming to generate from this campaign. A campaign has an amount raised, so basically this is the amount that was generated, the revenue from that particular campaign. The timestamp, which is the time that that campaign was created. The donors, which how many number of donors, people that made donation to this campaign. Withdrawals, how many times that have we made withdrawals from this campaign. So the campaign is really rich with intricate and useful information. Balance, this is the amount of money that is left after withdrawal, is left after donations. Okay, so this is different from donors and withdrawals, and this balance here will be correlating with the amount that is in the balance of the PDA, the program derived address. When you check it out on the on the Solana Explorer, it should correlate with this balance here. So the correlation must be done there. And active is a Boolean key determining if this campaign is deleted or not. Okay, since we can't just delete something, we don't want to mess up with our program. Okay, because if I close that PDA on the chain, then it's going to have some issues when I'm reading all those things online. This is like the best way to handle a deletion, okay, on the program. All right, so, and this is called program state. A program state is basically an account that has information about some vital information on our platform, such as if these some certain variables on our platform have been initialized or not. Okay, so initialization is there, and the campaign count. This holds record of how many number of campaigns do we have on this platform. So this keeps count of it, and the platform fee. So each time that we need to make platform charges, this record takes note of that. And then this platform address, this is the address that money will be sent to each time 5% is deducted. So those are some vital information about this particular program. And we also have more information here, diagram, and we can see here that whenever a campaign is created, this is a create function, is going to initialize the campaign and then store it in the campaign database, basically the campaign record on the blockchain right there. Okay, so store it on the campaign account. Okay, a campaign has series of accounts, so one of the accounts will become a campaign. All right, so when you want to make donation, so you say you make a donation, you can also read information from the database, so you can read, fetch, and Solana kind of has all those things. I mean, Anchor has those things figured out for us, so we don't have to even write a get, query or get function. So when you want to donate, you can see donation, it goes into the transaction record, and you can also fetch, from that same transaction record. Withdrawal also goes into this same transaction record. All right, and each time we withdraw, it updates the balance, on the campaign. Okay, you can see how it's going, and each time we donation happens, the amount of the amount of money raised will be increased, and even the balance will be updated as well. So there's a lot of that happening, and each time that we update the platform settings, such as the platform fee, it gets saved in this program state, and when we initialize the program, it also saves some record on the program state. So these are just some basic diagram that will help you to understand what we are doing, what we are trying to achieve by this program. So with that said, we don't need too much talk now. We're going to get into the installation part and set up our platform so that we can start coding and getting stuff done. All right, so I'll see you in the next part of this video. So the drill, how we get things done here. Okay, it's very simple. We don't want too much explanation. You see, in this particular video, I'm not going to go through the process of installing Anchor, Solana, and all of those things. If you want to watch that, please check out the very first smart contract development course for Solana here, which I'm going to put at the description section so that you can refer to it. In that video, I went through the whole process of setting up your computer, your machine, making sure that you have Node.js, you have VS Code, you have Solana installed, you have Rust installed, you have Anchor installed. I can't go through all those processes in this particular video. I don't want to elongate the whole thing. So you should go and watch that video and have Rust installed and all that. You can always confirm that you have all those things installed. Okay, by just simply running. You want to get git install, git dash version. You want to have that installed. Okay, so you can see I have git right here. All right, so you want to also have Node.js installed. Node. You can see I have Node.js installed. So you need to install all these things that I'm mentioning. You also check out, make sure that you have, Rust installed. Rust is installed. And Rust installation comes with cargo, installation as well, because we need that to do anything here. You need to make sure that you have Solana, installed as well. You can see that you need to make sure that you have Anchor, okay, installed. You can see I have all these things installed on my computer, so I am good to go. Okay, so once you get that, move to your project folder. So mine is sites. Okay, so this is where I have all my projects installed. And when you get here, what I want you to do is quite simple. You can come here, copy this, this URL. This is where it is. Okay, I want you to copy this project and install this stuff according to how I've already done it, because if you do it on your own, sometimes the packages are different. There are changes that happen in the package and it may not respond properly anymore because of differences in packages. So I will need you to make sure that you have my own package flow. You can see my package.json, and I've already have a starter branch which you can start up like fresh thing. You're going to follow me in all these things. So I'm going to copy this and come to that same URL and say git, I want to clone this URL and I want to call it crowd YT. Okay, so I can just get that cloned, and once it is cloned, I will make sure that I do code which is with VS Code and say / this crowd, open it in VS Code. Yeah, right. So now it is open. I want to end my existing one. This is the project before, so I'm going to close all this and end it because I want to do stuff with you. So I'm going to end my blockchain, my terminal, and end everything. Okay, so just going to close from this and I will enlarge this. You can see right now that Rust is just running under the hood because I have that. And please make sure that you have all this extension installed. You can see I have one extension that helps me a lot. Just watch the previous videos, okay, on this Solana, this Solana process, okay, this Solana playlist, and you find out that I have quite a lot of things. You just follow what I've done before, because what I've done before is not different. I've already set up the platform, everything on my computer, so I'm just using that same settings that I've already had. So you can check for Rust. So you can see that I have this Rust extension pack. You need to install this Rust extension pack. All right, that has all these Rust analyzer, this crate and orthodox string, all those things. So I see that I've already installed that will help you to work with me on this code. Now at this point, this is the package.json. These are the things that you're supposed to install. Okay, so I am going to run that installation. Now you can see all these things. These are the things that we'll be using on this platform. You don't need to do any changes, but every single thing is ready. So I will just open my terminal and run npm install, short form for I, and the process will take place. It's going to take a while, so I'm going to come back once this is done so that we can continue working. So the program, the entire thing is fully installed. Now at this point, this main program already has all the codes that you're going to be needing. It's already here, so you won't even have issues with it because you can easily reference back to what I have already done. But I want you to head to this particular branch called starter branch. So I'm going to check out git checkout starter. Okay, so I've switched to the starter branch, and let's do yarn or whatever npm run dev. Okay, so let's run the development server. So it is starting now, and please, I'm using Firefox for developing with Solana, because I've noticed some things personally, that whenever I use if I should use Chrome or Brave browser, because they are basically the same thing in a way, this localhost connection does not work out. Okay, it only works out when I'm using Mozilla Firefox. All right, so that's the problem that I faced, and I explained this in detail when I was doing all the installation in the previous course. So please refer back to that, watch all those series, and you get in touch with what I'm talking about. So at this point, you can see that this is what I had before, but let me refresh. This should give me some dummy stuff, because so these are all this information, all these details are just dummy stuff. I had just done it to just generate some fake data. Okay, so there is nothing here. This is just a fake interface. Everything is just fake here. Okay, nothing is done. So this is the interface now. Our project is set. The next thing that we want to jump in is to start the development. And how you start the development, every development is going to be happening in this place called Anchor program. Inside these programs, you have these fundus, and these fundus, this is the program. This is what it is. I've just put a dummy stuff here, which is just a simple stuff to generate this thing for you. One of the things that I want to do is, I want you to cd into this Anchor folder, right? So I'm going to cd into Anchor, and I want you to do Anchor build. Okay, so we have that. I just want to set up all these things so that as we're moving forward, we won't have to go through this problem anymore. So this process the first time always take a while, so just hold on, let's come back to it. Okay, so after a long wait, this has been fully installed. This is built. Okay, this is great. But the moment of truth is when I'm creating a new terminal. Okay, so a new terminal, I need to use this to run Solana test validator. Let's see -- reset. Okay, I'm making a mistake again. Reset. So I'm initializing the Solana blockchain on local development, and I want to deploy this contract. So say Anchor deploy. So I'm going to deploy this contract. Very important at this phase. Okay, so you can see this address, that is program address that is generated. This is very important. I want you to come to Anchor here and make sure you replace it with this, and also come to this program here and make sure you replace it with this. All right, so with that done, I need you to rebuild this program again, and after you rebuild it, you deploy, and everything should stay the same now. Great, so everything is all set, and this is beautiful. Okay, so I just think I should run you through some basic things. So you already know that this is the main entry file for your Anchor program, and this is where most of the works are going to be done. In the next part of this video, we're going to be jumping into development purposes. Okay, so you want to make sure that these things are the same. This is we have this is local development. This is for development. You don't need much things. Whenever I have to come to these files, I'm going to refer you to it. But just know that this is the Anchor version that we're using. Just make sure that is in line with whatever one that you have on your terminal. Okay, so I would recommend this version because that's the same version that I'm using. All right, so everything is already set, to go. All right, I will not need this on this starter branch. I'm deleting this script folder because we're going to write it ourselves when the time comes for that. So at this point, we are good. Just know that this is where we write our Anchor program, and then we will get going in the next part of this video. I'll see you then. So there's one more thing that I wanted to do now. In this part, I want to split this program. Okay, I want to split this project into multiple folders for easy coding. All right, so these are the things I want to do. I want you to come into this src here, create a new file, but this is how you're going to create it. Okay, you're going to say this VS Code. I don't know why this is happening, but VS Code, they need to look into this issue. that has been around. Whenever you right click, you want to create a new file, you just keep disappearing until like the third attempt or so. So I want a folder called constant, okay, and then we say mod.rs. Mod is short form for module, okay. So we have a module there. Now inside this file, this is where we're going to put all our constant variables, things that are going to be constant, unchanging on our platform. We're going to put it here, okay. Please make sure that you follow this pattern so that you won't have to have issues, okay. Rust is unforgiving, but if you follow this process, you will not have to violate Rust. All right, so we need to create another file, or we need to create another folder and file for, we'll call this errors, say mod.rs. So errors are going to be going into this place, all the error codes or error situations that we're going to be utilizing or facing on this platform. This is where it's going to go. And we're going to also need another file. This is going to be called instructions, and then you have module. This module is going to export every instructions that we're going to have on this platform, okay. Instructions are basically like function. It carries out certain code. They are just functions that perform certain responsibilities, okay. So those are instructions that are going to be happening. And then we also need another file and folder called state, okay, states, and then you have mod.ros. Boom. Okay, so these are all the stuff that we're going to need for now. And now I want you to come to this place, okay. Inside this lib file is more like the bundling place where everything is bundled. I want you to import all those various modules into this place so that we can use it. All right, so we want to import say public mod. All right, you want to import constant, you want to import errors, you want to import instructions, you want to import states. All right, and once you got those, okay, we're going to use instructions, okay. We won't say use instructions, and we want everything that is in instruction, we want to make sure that it will be available on our project, our main function right here. I want to make sure that everything in the states is also available right here, okay. So those are the two stuff that we're going to be needing, but for now, we don't have any use for them, so we're going to come back to work on each one of them. So at this point, you want to remove all this and you want to remove all this, okay. So this is basically the program. All right, I'm going to start exactly from this place. In the next part of this video, we'll start working on each one of those code, and we'll be moving around these various parts. Just understand that we're bundling them together, okay, and we'll be good to go. So I'll see you in the next part of this video. So the first thing we want to create, we'll always start with a state, okay. This state is more like an account bearer on the system. So we want to start with an account. To create an account, you come here and create a new file. This file is going to be called program state, program_state. The reason why we're calling it program state.rs is because it's going to be some state values that the entire program relies on, okay. So that's why we're calling it program state, okay. Now in this program state, we want to make sure that we have access to Anchor, okay, because this is like existing as a different file. So you want to make sure that you have Anchor installed there, available. And a program state is basically a struct. So this is going to be a structure. I'll call it program state. Okay, so a structure in Rust, we have series of is a customized data type. Okay, so it's a customized data type. So we want to have a value called initialized initialized. Okay, initialized is going to be a boolean. All right, so we're going to need campaign count, which, so let's call it campaign underscore count. Okay, which is an unsigned integer 65. We're also going to need a platform fee. Okay, so a platform fee, okay, which is also unsigned integer 64, and we're going to need a public address, the platform address. Okay, so say address. Okay, this platform address is going to be a public key. A public key is going to be pub key, which is short form for public key. Okay, so this is not useful at this point. Let's save this first. Let's make sure that inside this state right here, I want to make sure that I make this available. All right, so how do I make it available? I'm going to declare a module here, public module, call it program state. Okay, and at the same time I'm going to use everything or dump everything that it contains inside here. I'm going to say public use, and what am I using? This program state. I want to use everything inside of it so that when I'm exporting it, it will be very handy for me. At this point you can see that it's integrated. So this is basically a structure now, but in Anchor or Solana Anchor development, for you to convert a structure into an account, you have to use this macro called account. Okay, so let's do that. So you have account macro, you put out a pound sign there, and you say account. So that gives you, convert this into an account, okay, that will bear record on the platform. So I want to also be able to dynamically determine, I don't want to assume the size of this account on the blockchain. So I want to determine that using this macro called, derive. Okay, it will derive the initial space. Okay, so when I get this thing together, I can then come to my instruction. Now I have what I can use to create an instruction. So my instruction that I'm going to be creating is going to be revolving around these program states. So I'll come to this instruction. I'm going to create a file called initialize, instruction called initialize, okay, .rs, and I will make sure that something similar like this. Okay, for these initialize, come to this mode, we just say initialize, and here initialize as well. So save that. So when you come to initialize, there's really nothing here, right? So the first thing I want to do is to make sure that I import Anchor preload. Okay, and after I've gotten Anchor, I want to create a function. Before I create a function, I want to create a context. A context is going to be used along with the function, and a context bundles series of accounts that are required to allow that function to run. So there are some things that I want to initialize before people start creating campaigns and making donations. If these things are not initialized, it doesn't work. This would have been very great if Anchor Solana does have a constructor function that once it is deployed, that function is the first to execute. Then I wouldn't have to create this step. But the fact that Solana Anchor doesn't have that, then I have to manually execute that function. But I need to create it first. So to create it, I need a context. Okay. So I'm going to call this public struct, initialize context. So any structure that I'm going to be, anything that I'm going to be using as a context for an account, okay, it has to be, done this way. And you may not know the value of this for now, but let me bring it here. Let me say this is the function. Of course, this is the function that I want to create called initialize function. An initialize function is going to need a context, which is this ctx, and the context is going to be this context, and a context we definitely need a function. So for example, this is a context, and okay, so I'm going to use this context here. Boom. All right. So, and then it's going to return a result data type. All right. So this is what we're expecting it to return. And for now, we can just say okay. Okay. So this is it. But it's going to complain here. Why it is complaining is that it doesn't have all those things that make it a worthy context. Okay, so it lacks the information that makes a structure a context, and you can't make this thing a context until you have wrapped it around an anchor macro called derive account. Okay, just like I think something similar to this derive, but this is for initializing space, but we want to derive account this time. So I want to say, before we do that, you want to typecast it with this called info. Okay, so you can see that it's giving an issue. It doesn't know what this info is about. So but by adding this this thing called pound symbol derive, and what we're deriving is account, this here. Okay, then this, you can see that immediately it fulfills the requirement of an anchor function here. This error went away. All right, so let's work on this initialization context. Just understand, use your photographic memory, use your pattern recognition. Just understand that for every function or instruction that you're going to create on this platform, is going to have an equivalent equivalent context structure to it. So the first thing I want to do is I want to create a say public system underscore program, and this system program is going to be based on a Solana program like this, and you want to add this info, and you want to say system. Okay, so you have this immediately. This has been fulfilled, right? So that from now we don't have to have any issue when we're working on this. Okay, so we have that. So this is you saying that this is a Solana program, and this function, this context now have access to this system. Okay, system is some provision that enables you to have access to the core Solana blockchain, and with this you'll be able to execute some certain function that affect the blockchain, that update things on the blockchains and all of those things. So for now, don't give it too much attention, just follow this pattern. We're going to need an account. Okay, so we say public to initialize this function. We're going to need an account called program state. Okay, this is going to be based on this account here, program state here. So we're going to say account is of a type of account. Make sure that this account has information and is based on program state. Now you see the way as I click it, it kind of imported it straight out from this place. Okay, but this may be problematic. So but there's a way I normally just import it so that it will not give me any potential issue. Okay, So I would do create crat and specify the location, which is in state, and then I want to access this program state. So that is what I'm doing. This is the right way. I think the other one will also work, though I haven't tested it out. But with this, I know exactly which file I'm accessing, so there will be no confusion. This is a lot safer way of doing it. Okay, so this program state, this program state now has access or information about this initialized status, campaign count, the platform fee, the platform address. All of this information can be accessed with this. But this is not the only thing. We need to add some extra information to it. Okay, we need to add some extra information. So to this program state, we want to create it. The first time we're creating it, it needs some information. So for example, it needs, I'm going to break this. It needs, account information. Okay, so this is account information. What the account information is that we are initializing this account. This is the first time it's being created, and we want it to be created once, basically. Okay, and if it is being created, it needs a payer, someone that is paying for that space, which is going to be the deployer of this contract. Now we don't yet have a deployer, but we can create a deployer. If I do save now, you see this should break. Okay, so this we can come here and create a deployer. So say public deployer. Okay, a deployer is a signer. All right, so that is what it is, a signer. And a signer has just information. So a signer is whomever is deploying this particular account. So with this now, this deployer we can be accessed from this place, but we want to make sure that we add some account context to it, which is say account, and you want to say that this is mutable. This deployer information is mutable. So because if it is mutable, then we can be able to do stuff like change the balance of the deployer, manipulate the deployer's information, because charges will need to be made. Okay, so that is it for this account, this deployer here. The next thing you want to do is to complete what we're doing here. To complete that, we'll need another data called space. Okay, this space, you're saying what space should it use on the blockchain, like the space that is going to need. So it should be 8 bits. Okay, plus we had this program state, this program state here that we imported. If you check here, it has this init space, which programmatically determines the space that is going to be that account is going to have on the blockchain. So I want to say this 8 digits, okay, 8 bits plus this program state, and I want to access the init space. So this here give me access to the size of the file that is going to need on the blockchain. And also I need a seed. A seed is basically how we generate or make this particular account unique. Okay, so I'm going to add a seed there, call it program underscore state. Okay, so this is the seed, and after seed we also need something called a bump. Okay, so we need a bump. And now please pay attention, you may make some mistakes sometime and write seed here instead of seeds. It's supposed to be seeds with an S and not just singular. Okay, so that's what is creating the issue. At this point, we're almost done here with this, but I want to create something that we hold this, because I'm going to be using this 8 bits, across various contexts. Okay, so I want that to be just unified. So I will come to this constant here, okay, and I'm going to make sure that that is exportable. So I'll create a public variable called a public constant called anchor discriminator size, which is this 8-bit size here. Okay, it's a type of U size. Okay, 8 bits. All right, with this anchor discriminatory size, I can then use it here. So instead of this, I could do that. But yeah, we can do that. It's saying that this one is coming from constant and this one is coming from state variable. But I like actually putting them in their various lines for easy, understanding. I'll say constant and say anchor discriminatory size. So this is what it is. So that is the same now. You can see that is a bit right here. So at this point, let's finish this function. To complete this function now, we need to come here and let's say this state, get access to this state, program state right here. Okay, we'll say we want to get this CTX, which is the contest, accessing the account. Remember, all these things are various accounts. This is one account here, this is another account, and this is a third account. So we have 3 accounts there. So I want to grab the program state, no, not the system, the program state. Okay, so I got that, but I want to make sure that I'm getting it as a mutable reference. Okay, because I want to make some modifications on it. If I don't want to make any modification on it, then I will need to import, grab it as a mutable reference. So the next thing I want to do, I want to grab the deployer. The deployer, I am not getting it as a mutable reference. I'm just getting it as a reference. So I'm going to say deployer because I'm not changing anything about the deployer. So we'll just do this. Okay. So now that we have the deployer and we also have the state, I want to make sure, I want to check for a condition. If the state is initialized, initialization is true, because I don't want to be initializing it over and over again. There's no need for that. If it is initialized already, then I want to return an error. Okay, now this error that I'm returning is not yet available here, so I'm going to create an error. So let's come to this error here, this constant here. We're going to create an error, for these, and the drill, make sure that you have anchor right here. Error is basically enum data type in Rust. So say enum, say error code. So this is basically an enum, that will contain those error code, but it doesn't really make sense to anchor until you transform it using this macro called error code. Okay, so once we have that macro called error code, you can then have a code. This is the first error. Say already initialized. Okay, so already initialized. All right, but I want to be more descriptive than that. You know how enum data type is, it ranges from 0 down to infinity. So basically this is the first error code in this enum data type. So I want to describe this error more by using this descriptor MSG, and I will say the program has already been initialized. Okay, so this will make it much more descriptive, and at this point I can come here. If there is any error, I can then say here, I want to reference that already. So, and how you reference that, let's say create and then we'll say errors, and want to access that already. Want to access error code, and want to access this already initialized. Okay, so this is what we want to access here, and you must add up this thing called .into. Okay, so you save that. All right, so this is the error that it is going to return in case this program has already been initialized. All right, so but if it's not initialized, I want to say this state dot the campaign count, I want to initialize it with 0. Okay, because if it was Solidity, I won't need to do this because by default it's going to be 0. Okay, we also need to initialize the platform fee. The platform fee is going to be 5% by default. Okay, we can change this later on by creating a function that manages that procedure. Okay, and we want to also get the platform address. The platform address, which is a string, should be this deployer. Okay, this deployer, and then say :key. This key will give you the public key of this deployer. So this will be his public key will become the platform address. And lastly, you want to say the initialization state to be what? True. So with this, you have successfully initialized this program. This is cool. Now, this is cool, and we're almost done with that one function, with that one instruction. The next thing now is to make sure that it is usable here. Okay, this use super is very important because you're saying that you inherit the properties of this anchor macro code program here. Okay, and at this point, what you just need to do is to create another function exactly as the same name as this. Okay, so I'm going to copy this. Okay, so but if I'm copying this is the context that I'm expecting. Okay, I'm expecting that this should come from from here. Okay, this is why it's not complaining. If I end this, if I don't do this here, this should complain. Okay, it still has access to read though, but this is coming from that place. You can see this is the initialization context here, and this is expecting a result, data type to be returned. But in this case, I can just call on these instructions, okay, and then access this function called called initialize, and that is it. That we solve the problem, and at this point, we've been able to create our first function. It took multiple steps, but this is how you actualize it. You can see here this little complaint that is coming from Anchor here is because we are not directly accessing any information here. So there's a warning here. So I'm going to say it should instruct it to allow unused imports. So unused imports should be allowed. Yeah, that is how it is. So in the next part of this program now, we're going to start creating campaigns. So I'm going to do just about the same thing I've done here. I'm going to do it for campaign creation. So that is what will be called the campaign instruction. So I will see you in the next part of this video. Okay, so at this junction, we're going to jump into creating a campaign. And it's very important that you do this very well because the campaign is the meat of this entire course. So it has to be done very well. It has to be very detailed, having a lot of properties that will be very handy when you're translating it on the front end. So this is how we go. The drill. You always start with a state, which is basically an account. All right, an account that is going to be set up on the Solana blockchain. So I'm going to create a new one. Call it campaign.rs. Okay, so this is a campaign, and campaign say public struct campaign, public struct campaign, and then you say public CID. This CID will represent the campaign ID. It's going to be managed by us because we are going to, design a method for keeping track of that. Okay, so I have these. Okay, so let me make sure that it's part of this module so that it will be exportable. Okay, so I'm gonna come here, say campaign. Okay, so we have that. Always make sure that you declare the module and also make it usable in this format. So there you go. So this is active now. I'm also going to need the creator, which is public, call it creator. Creator is going to be a public key, pub key. And of course, we're not importing it like this. We're importing everything from preload. So yeah, so this public key is also imported as well. We're going to also import, say public key title, okay, which is going to be a string, and we're going to import a description, an image URL, or string, description image underscore URL. And we're also going to import goal. The goal of this project, the amount to be raised, the timestamp, the number of donors, the number of withdrawals, the number of balance, and a state called active or not, which indicates whether the campaign has been deleted or not. We'll say goal, I'll say amount underscore raised. Okay, and we're going to also say timestamp. And we're going to say donors, and we'll say withdrawals, and we'll also say balance, and we'll say active. Active is going to be a Boolean key. So these are the properties that makes a campaign. Now I want this to be declared as an account, so because it's to be an account on the Solana blockchain. And not only that, I cannot I can't always be sure the size that each campaign is going to take on the blockchain, because you don't know how long the description of this campaign is going to be. You don't know how long the title is going to be. You don't know how long the image URL is going to be. All this information, they could increase or reduce the size or the space that it takes on the blockchain. So we want to preemptively do that by programmatically determining the space it's going to take on the blockchain. So you do this by saying derive, okay, and want to derive the init space. So you see these three errors that are produced. This error indicates that it's saying that it expects a maximum length attribute. This attribute is used to mark or to cap the limit of a text, you understand, of a string, so that Rust can calculate how much space is going to reserve for each campaign on the blockchain. So how you do this is by putting an attribute here called max length, and in this max length you specify, like, I want it to be 60. I want it to be 64 character length, okay, for the title, and I want the description to be 512 character length. You can see those ones are disappearing. And lastly, I want the string for the image URL to be 256. Okay, so those are the various max length that I'm going to be needing for working on working on a campaign. So afterward, you then have to come to create the instruction here. So you create the instruction by saying create campaign.rs. So this is where the instruction comes in. And in creating campaign, you want to make sure that you add it to these exportable members. Okay, so I'm going to say create campaign. All right, there you have it. So in this place, as usual, you want to make sure you import this. Okay, and then before we can proceed. And to proceed, you want to first create a context because it's going to be needed here. So let me say I create a function first. Function, public function, create campaign. And in this create campaign, it's going to return a result, and that's what we are expecting, that it returns a result. And we can just simply say okay for now. This is it. So the context, say ctx is equal to it's going to be based on context, and this context we're going to call it create campaign ctx. So we're going to copy this. Let's create a context. Okay, so just follow me here. A context is basically a struct again, so it helps to define complex data structure. And what we're doing this time is we're basically creating various accounts under this context, accounts that will hold the creator of this platform, of this campaign, the account that will hold the program state, account that will hold the system program, the campaign itself. So these are various campaign elements. So if I say here, I want to, give you this information, now is complaining. Why it's complaining is because this is not, doesn't have an account attribute. Okay, so I'm going to make, add that macro that enables this to be a valid derived account. Okay, so save that. You can see this has already disappeared. Now let's improve this here. So the first thing I want to do is to say public. We can literally just copy this here. We can copy this here, copy this up to here. Okay, come here and paste, because I'm going to need those same things. Nothing missing. I'm also going to make sure that I am grabbing this correctly from the state. So here we go. We're getting the program state. We're getting this time around we're getting the creator. So this is the creator of this campaign, and we're getting the system program. Exactly the same thing that is done here. It's just a few changes that we did. Okay. So, but this is for grabbing already existing content. Okay, things that have already existed. What about to create the campaign itself? The campaign is not yet created, so we need to create a campaign. And to do that, we'll need an account for campaign. I could duplicate this here and come here and call this. So I'm going to call this campaign. and make sure that we're getting this campaign here. Okay, we can decide to do this way. Okay, so these two are coming from this state, the campaign and the program state. They are all coming from the state, okay, that we bundled here inside this mod. Okay, so at this point, you want to give this campaign some attribute, because this is the first time we're creating a new campaign. When you're creating a new campaign, it's different from referencing an existing campaign. Okay, so let's create a new campaign, and how you do that, of course, you start with this macro. In this attribute, call it account, singular account. And if you take note here, you can see that this is also an account. So I'm just referencing that here. So account, and this account is going to have these various attributes. First of all, this account is going to be an init. So I'm initializing it. That means I'm creating it. It doesn't yet exist. This is the first time. The payer, whenever you're creating a new or a fresh account, then you need a payer, someone that is going to pay for that particular creation, okay, which is going to be the creator. So this is the payer for this campaign, and the space that is going to take on the blockchain, which we can grab this anchor discriminator. We got this here, so I'm gonna call this here. I'm gonna totally call this. I have to do this myself. Say constant, and let's grab this discriminator, constant with an S, not singular. Okay, so at this point I can use this discriminator, which is basically 8-bit size, plus the campaign init space. So I'll say campaign, call on the init space of the campaign. So this will dynamically determine the space each particular campaign is going to take on the internet, on the blockchain. And now we need seeds. Seeds is very important for because it helps you to make a campaign unique. Two campaigns cannot have the same, it cannot have the same PDA. Okay, the PDA is created through this seed. This seed is responsible for determining the string content, or how the campaign is going to look like. Okay, so I don't know if I'm doing justice to that explanation, but think about this key here, okay, or this key here. Let's say this one, or this one. How this key is going to be created, this one is going to be created, which is a PDA in this case. How this key is going to be created is going to be through these seeds that we are specifying here. So that is what I mean. So specify by saying campaign you can't use only this for this seed, because this is not unique. A lot of campaigns are going to bear this particular information. So, but you want to merge it with one extra information, which is this program state right here. This program state contains information such as the campaign count. All right, and remember, we've already initialized it with 0. So the campaign's count right now is 0. So we want to grab that program state, okay, call it here, and call on the campaign count and add 1 to it. So this will make this particular campaign unique, because only two campaign cannot have the same campaign ID. So I'm using this to dynamically orchestrate what the CID is going to be. So then I'm going to say dot to little endian, okay, byte. There is something called this. Okay, and I also want to convert this to as a reference, as ref. Okay, when I save this, okay, now a seed definitely needs a bump. Bump must be provided with seed. So if you're doing that, you need to provide a bump. So I'm going to say bump, which is automatically determined, by Anchor itself. All right, so these are all the information you need to create the account derivative, the information that it's necessary for creating a campaign. Now that is not all going to need. We're going to need some more information. So this is a context. We've already dealt with it. We also need some extra information for creating a campaign, like we need the title of the campaign. Say title, which is going to be a string. We're going to need a description. We're going to need description. We're going to need an image URL, and we're going to need a goal, and this goal is going to be unsigned integer 64. So these are the data that we're going to need to be able to prosecute these, the creation of a campaign. At this point, I want to grab some accounts. I want to grab this campaign, and I also want to grab the state, which is this program state right here. To do that, I'll come here and say campaign, say let for variable creation is equal to, I want it to be a mutable reference because I'm going to be changing some things about the campaign. Say ctx.account.campaign. The reason why it's available because in this context it has information about it, right here. So all these details makes for a campaign. So we also want to grab the state. So I want to say state is going to be, call it program state. We have access to it here. So those two information are available. Now I want to perform some checks. Okay, some checks are indeed needed for us to move forward here. These checks are going to enable us to make sure that we are not getting an empty string. Okay, so I'm just going to paste those things. I'm not going to write it all by myself. So it's going to be about description, image URL, and the goal of the campaign. So these things are just very simple. This is what title too long. You just put an extra message at the top of it here saying title exceed the maximum length of 64 characters. The same for description, the same for image URL, and then lastly, invalid goal amount must be greater than 0. So these are situations where someone is entering the wrong input, so we can just display these messages for them as an error. So let's come here and let's start using it now. We want to use if condition. We could use require, but I discovered that require had some issues. Like I could have easily said something like it requires that this title, okay, the length is greater than 64. Otherwise it should say title too long. Okay, and this title too long should come from, we should grab it from the error. So we can say, this is errors. I want to grab error code and everything inside of it because we're gonna need a lot of it. So, but it's just keep giving us this error, and because of that reason, we can't use it this way. We want to use it in an if-else condition. Okay, so we can say if the title, the length of the title is greater than 64, we want to return an error. Say return error, and the error we're returning is this. But you must say .into. If you don't do that, it's going to produce an error. So so this converts it into an implementation that can return that message. Okay, so want to do the same for description, title, and goal. So we say description here must be greater than 512. Otherwise say description too long. Want to do the same for image URL. Otherwise, it must be greater than 256. Otherwise, you say image URL too long. And lastly, the goal must be greater than 0. The goal, if the goal is less than or equal to 0, okay, the goal is less than or equal to 0, then it should say invalid goal amount. Okay, because we want the goal to definitely be greater than 0. Okay, it is not right for it to be less than that. Okay, so it shouldn't be greater than 0. That's what I'm trying to say. Okay, we're gonna have to make a little bit of changes here. Okay, because this is cool, this will work, but the goal, whatever we're intending to do here, everything, I want to make sure that the goal, the amount to be raised, everything is recorded in Solana standard, in Lamport equivalent. So to do that, I can't use this 0. I want to say that the goal must, if the goal is less than, this is what a Lamport equivalent in Solana will be. Okay, so whatever I'm feeding into this as goal, I'm going to multiply it by this 1000 to make sure that it matches what I'm intending. So we're going to see it in action. Let's go. So the first thing you want to do is you want to access the state right here. Okay, because this state contains the campaign ID, the campaign counter, so that I can know where the campaign ID is right now, so that I can access it. So I'll say the campaign count by default is going to be 0, so I'm going to increase it by 1. So after I've increased it, I can then create a campaign. Say campaign.cid. Okay, it's going to be equal to this state dot campaign count. So this will become the CID. For the creator, it's going to be CTX. I'm going to call on, because CTX has various accounts dot creator dot public key. Okay, so I want to get the key as a reference. Okay, so but I will need to dereference this as well. Okay, so if I don't dereference it, you see mismatch type public key found a reference of public key. I think we can also do something like this. Okay, yeah, this will give us the right way. We don't need to dereference it this way, because this is basically the right way to get it. All right, so okay, so at this point you want to also get the title. Okay, the title is going to be coming from the parameter, so we'll just say title here. Description is the same. You have the image URL, the goal, All right, so those are it. Then we need to also create some default values as well. So for example, amount raised, I want the default value to be 0. That means it has not raised any amount yet. I also want the number of donors to be 0 at this point. Number of withdrawals, to be 0 at this point. Okay, and there's one more, that is the timestamp. Timestamp is going to be the current time that this particular campaign is created, and you can get that using this thing called clock. Okay, and then you get the current Unix timestamp, and currently we have a mismatch because this returns an I64, which is integer, okay, which could be negative or positive, but it has to be only positive. So I want to convert this as U64. So with this, it's gonna be resolved. And lastly, I want the active state. Oh god, I made a mistake here. So it's not active, it's active. So I'm gonna change this to a V. Come here, say active, okay, to be true. Okay, that is great. So with this information, a campaign can be created with all this information prepared. All right, so at this point, this is the time when we now jump into the entry component, which is like the home page, okay, and create a function that we match what we need. And at this point, you can just do something similar to this. So I'm gonna copy this and come here. So we're doing something similar to this, and you save this here. So then we just need to call on this instruction. So instructions, and grab the create campaign instruction. Just drop these things here, okay, which are included: CTX, the title, the description, the image, URL, the go. All of those things we are passing into this. You see how simple this looks, and with this, it's been accomplished. Okay, so there you have it. At this point, I'm thinking maybe we should be testing along, but I don't want the lesson to be too cumbersome. Otherwise, as I'm creating each function, I would like to just go and test them all out and make sure that everything is well before we proceed. But since that is not the case here, we want to finish the development of the contract first, and then we'll go and test it out so that the learning process we have sequence. Okay, so in the next part of this video, I will then teach you how to update an existing campaign before we delete, and then we jumping into donations and withdrawal and the updating of the system settings. All right, see you in the next part of this video. Okay, the good thing about updating a campaign is that I don't need to create a campaign anymore. I already have done the creation of the campaign state, so I don't need to go through this process. So I'll just jump into this one and create an instruction. So it's instruction, by the way, just straightforward. I'll say update underscore campaign .rs. Now it's gonna have something similar to this. First of all, I want to make sure that I come to the mod here, make sure that this have update campaign. Okay, that's good. Now close this, come here. I need you to grab these things because we're going to do something very much similar, and then I'm going to copy this because it's going to be quite similar as well. Say okay, and this is going to be called update campaign, and want this to be update campaign record. So I'm going to copy something similar to this. See, most of these things are just about the same, so we don't need to repeat too much things or repeat ourselves so much. So I'm going to copy this at this time. So this almost look, all right. There are just some things that we need to change. For example, I'm not creating a campaign this time. This campaign already exists. So I just want to access that campaign by specifying the seed and making it mutable. So all this is not going to be necessary. All I just need is to make sure that it's mutable, because I want to make some changes on that particular campaign. And I'm not referencing this seed this way. This is not how I'm going to grab make the seed or derive the seed. So I'm going to derive the seed using a different way, because I'm going to be inserting right here. I'm going to be also getting a CID. So I'm going to this instruction here, this CID is going to be coming in. I'm going to make sure I have supply CID as well. So I don't need this way to grab the CID. So all I need is to come here and say instruction, put it like this, instruction, okay, and the instruction that is going to be passing just this. Please make sure that whenever you're passing an instruction, it must be present in the parameter of the function that you are dealing with. So I'm going to say CID, and you also want to make sure that it knows the type, which is 64. So this CID, this is what, in creating a campaign, this is how we derive a CID, but we're not creating a campaign now, we're only accessing an existing campaign. So I'm going to pass this here. So if I'm passing this, I don't need too much of that, so I could use this way instead. So this is how I get the campaign reference, all right, the seed for the campaign. So with this, I don't also need this program state. Why? Because I'm not going to be using it. So because of that will reduce our work very well. So I'm going to also remove this and just make sure that I keep it clean and simple. So at this point, I want to do all the things that I did here, which include these validations. I'm going to grab all this and bring it here. I'm not going to be using this, so I'm going to remove that. So all of this must be present. Okay, so I'm doing all those validations that we've already done. Now, as an additional step, it's not as if this step already make sure that whatever campaign that you're grabbing, it does exist. Otherwise, if it doesn't match this seed system, it's not going to get you a campaign. But I want to make an extra effort to make sure that whomever that is trying to access this campaign is the creator of the campaign itself. So I'm going to say creator is going to be campaign, the creator of the campaign. That's great. And then I need to verify this creator. I'll say if this campaign dot creator is not equal to this creator here dot the key itself. So okay, if it's not the same as this key, then it should return an error. Okay, now this error, we're going to have to go create it. This error is going to be called unauthorized. Okay, not everybody are authorized to access, to edit that, so we say unauthorized access. All right, so that is important. So come here and say unauthorized dot into. So this we flag off whenever someone that is not the owner of the campaign is trying to make some changes on the campaign. So we also want to make sure that the campaign exists. So there's also another step that we want to take here. So I'll say if this campaign.cid is not equal to this CID that you're providing here, okay, then it should say campaign not found. So we also want that campaign not found message. Okay, so we're going to say campaign not found. Okay, so this here, bring it here, and we say campaign not found. So that will make sure that a campaign exists before you'll be able to create, modify its content. Okay, so with all this existing, we can then make some changes. The changes that we're making are very simple. We want to change the title, the description, the image URL, and the goal. Those are the only things that we're going to be changing. So I'm going to copy that and just bring it here, save that, and that is just it. This is what it takes to create a campaign. We did not even need this in the first place. Okay, so these are all the details for modifying or updating a campaign. It's very simple, right? So at this point now, you want to make sure that it's part of this arrangement, and you can quickly do that by copying these details, come here and say this. Okay, so and say instructions, access, update campaign, and then just pass these values in it, save, and that is it. We've been able to update a campaign. This is cool, very sharp and very fast. How about we go and also create another one for deleting the campaign? Okay, to do that, you go and create an instruction. We don't need to create an account because we've already done that for campaign. So we'll say delete campaign, delete underscore campaign .rs. So on this on delete campaign, you want to make sure that you include it here. All right, so we say delete campaign. So you save that, close this, come here. Of course, we're going to need something similar. All right, so I'm going to grab all this. When I grab all that, I will come here and grab this because it's going to basically be the same thing. So I'm going to grab this account derivative method here. I'll call this delete campaign ctx. So that is just it. We'll grab it. We're getting this same thing right here. It's just exactly the same thing. And with that, we can come here. Let me copy this. So you see how simple it is. Because it's a framework normally just have the same way of doing things without too many hassles. So I'm only going to require two of these, which includes the context, which is the delete campaign, and the CID, which is the campaign ID. Is very important that you get those two. And of course, you want to check for these. You want to make sure that the campaign, you grab the campaign, you grab the creator, and want to make sure that the campaign is the attempt to delete the campaign is done by the correct owner and the campaign does exist. Okay, those two are important. And then we also need a third check. This third check is if the campaign is active. Remember, campaign can be active or inactive. When you create a campaign newly, it is active, but then afterward, when you delete it, you have to toggle it to become inactive. Okay, so that is what is going on. Now I leave that place. So we'll say, oh, look, the problem is with this name. This name cannot be existing two times. So say delete campaign here. Okay, so that's good. So we can duplicate this and say campaign.active. So we are expecting that this campaign is not active. Is not false. The active state is not false, because if it is already deleted, then there is no point trying to delete it again. So we want to, in that case, just provide an inactive campaign warning. So you come to this error and say inactive campaign is what? Inactive. Okay, so and then you just make sure that, you copy the name, inactive campaign, and that will become the error charge. And there is just one simple thing you just need to do about this campaign, which is to call on the active mode and toggle it to false. So with this, the campaign will go offline. It will still be accessible, but with this now, you won't be able to do things like donate to it. Okay, I think you will be able to withdraw if you already have fund on it, but you will not be able to, people will not be able to donate to it anymore. And it will not be listed on the main page, because we're going to filter all those things out. Okay, so this is great. Now the next thing you want to do is to make sure that we can do it here. So want to bring it up here. So I will say copy this line, come to the home page here, and say instructions, access the delete campaign, and then pass those information right there. And there you go. Very clean, very smooth, very exciting. So we've been able to achieve this about campaign. These are the things that we're going to just do in about campaign. The rest of it, we'll take care of it on the while we're testing and in the front end. So in the next part of this video, I want to show you an instruction for donating to a campaign. And this part is going to be very important, because this is how you understand how to send money into a campaign. All right, so let's get it done. So at this point, I want you to come to this state. We're going to create an account called, or a state called transaction. The reason why I'm choosing transaction instead of calling it donation or calling it withdrawal, because I'm going to be using it in two instances. Say transaction.rs. I'm going to be using it in two instances. The first instance I'm going to be using it is when donation is happening and when withdrawals are happening. The reason why I'm doing it like that is because the two of them they are just too close. There is just about no difference, just one single difference. So it's better, for you to combine that trait together instead of trying to make them different. Okay, and I think it's one of the things that we could have done to improve this as well. This could also be made one, like this context can be used for delete and updating without having to replicate the same thing for the both of them. So I'll come here and make sure that I import this. Make sure that you also include this here. So we have transactions. Okay, so we can come here now. So in this transaction here, you know how it goes. The drill is a struct, and it's going to be called transaction. With a T. All right. So a transaction has an owner. Okay, the owner is, who is this person that performed this transaction? So this is going to be a public key. Transaction has it has a CID, so we know which campaign was this transaction performed on. So is on sign integer 64, and the amount as well, the timestamp, and this one difference which I'm going to show you now. So the amount okay, a timestamp, and lastly, this is going to be called credited. Credited is a boolean. Okay, this credited, I'm going to use it to determine if this is a credit transaction or a debit transaction. If it's credited, that means it is a donation transaction. But if it is false, that means it's a withdrawal, transaction. And of course, to make it an account, you have to make sure that you provide this, macro, call it account. Okay, and for us to also determine dynamically the space this is going to take on the blockchain, you need to put this macro as well, call it derive, and you're deriving the init space. So this, we're done with this transaction. Then we can go and create instruction for making donation. Okay, so let's call it donate.rs. So that is the instruction that we're dealing with here. And in donating, I'm just going to take something really similar here. I'll come back to it. So we're going to say public function, we'll call it donate, and it's going to have a CTX, which is a context. Now this thing is not giving me some auto suggestions because I've not included it in the mod, so I'm going to make sure that I get that done. So we have donate, okay, and yeah, let's go now. Public fn donate. We're going to call this context. It's going to be, this. I will say donate CTX. Let's do that for now, and say result. Okay, so donate, you can say okay. So donate context, we need to create something similar to that. We need to create a context for that. Okay, so what are we going to need? We're going to need these things that are just here in the campaign. It should be similar to what we did here in the campaign. So I'm going to grab all this for now and come here. In fact, I'm going to grab this entire thing the way it is, come here and create one here and just do this. Okay, it seems all right, but not everything is ready. So we are able to grab a campaign by the campaign ID. Okay, and of course, for us to be able to donate, we also need the CID, which is a U64, and we need an amount, which is a U64 as well. So we need this information. They donate a specific amount, right? So, but we're grabbing that CID as an instruction here. So, and then all these things they're on point. At this point, you want to make sure that you call this creator donor. Okay, so that donor, it's more descriptive of what this account that is performing this transaction is doing. So one more thing that we want to do is we want to create another account. Let's call it transaction. Okay, so let's call it transaction. I would have called it something like contribution, but for maintaining standard, let's just call it transaction. So this will be transaction, and let's say transaction. Let's say transaction. I don't think we're transaction. Okay, so there you go. But we need to define the attributes of this transaction because we're creating a fresh transaction. So it has to be a little bit different. we can borrow, the ideas that we've already done in this create transaction when we were creating a campaign. So I could just copy all this information here and don't need to repeat myself and paste it here. So you can save this, but this is not it. We still need to make some modification. First of all, who is paying for this, for the creation of a transaction? Is going to be the donor, so the person that is making the donation. And this, is coming from here, obviously. And we're not trying to determine the space which we use in creating a campaign, but space for creating a transaction. Okay. Now you don't need this. What you need is a CID instead here, because we are getting the campaign ID from this instruction here. It's almost cool, but this is not the things that we use in determining. You see, the seed is not the same way that we use in creating a campaign's seed. So for example, this is going to be a donor, okay, and a donor, I want the donor's key, so which is the public key of the donor, and I want to convert it to reference. So this will also make up the key. I want to also grab the CID. So this is the campaign ID. So we're having this string, this text concatenated with this donor key, concatenated with this CID. Okay, all of this is cool, but they are not going to be unique yet. It doesn't make this transaction unique, because okay, this is not unique. This is only unique to one donor, okay, and this is only unique to one campaign. What if I as a donor want to donate more than one time? I don't want that to be conflicting, so that's why I have to add a fourth seed to keep that whole thing flowing. And this fourth seed is going to have something similar to this. So the fourth seed will go like this. I'm going to access the campaign, okay, which is this campaign right here, and I will call on the donors. So I have, how many number of donors do I have, and then add one to it. Okay, that will now make this completely unique for every single donation that happens on this platform. So this is what a unique transaction. All right, so with this, we're cool here, we're really cool, and we can go ahead and make the donation. And now to make the donation, I'm going to need to grab the campaign, I will grab the donor, and I will grab the transaction. So I'll say let campaign be equal to the context CTX. Okay. Now you always want to grab the context, the reference of it. So the principle of borrowing and ownership. So you want to borrow it. Okay. So we'll say mutable reference of this context dot account dot campaign. So you want to grab that, and I want to also grab for donor. This is the donor account, and also want to grab for transaction. Okay, so I'm gonna say transaction here, and make sure that I have that here as well. So those are the things that you need, and you also need to do some checking. The first checking that we want to do is to make sure that campaign is campaign. If it's a campaign is not active, so if it is not active, if it is deleted, then it should just give this error. You understand? It should just flag this error. That is what we mean by that, so that once our campaign has been deleted, it can no longer receive donation. Okay, and the second thing you want to do, you want to test if this campaign does exist. Okay, so you can do that by using this. So the campaign does exist. I think that should be the first thing. the campaign does exist. But if this thing is returning, okay, let's just keep it here just for more detailed reasons. Okay, so these are two conditions that it must pass. Then you have to pay attention here. Okay, once it passes these two criteria, you want to also check the amount as well. You want to make sure that the amount is greater than the base level, okay? Which, if you look at the create campaign criteria here, let me just copy this. So we have this here. I'm going to say amount. So, for example, amount should be greater than this, okay? Because this is like the base level. You understand? Like what a lamp port means, okay? One lamp port to a Solana token, okay? So if you're sending a Solana token, it's going to be multiplied by this particular value here. We're making sure that you're not sending a value that is too low, that it cannot make sense, to our contract. So, but this is not the right error. So you want to come to this error code and you want to say invalid donation amount. Okay, say donation must be at least one Solana token. Okay, donation must be at least one Solana token. So donation must be at least one Solana token, okay? Otherwise, you should not accept. So one Solana token is the least amount that we're doing that. When you're designing your own and you want to be able to get something smaller than one Solana token, then you have to change this approach, and you can basically just use 0 like how it was initially, but there is a reason why I did that, to make things so much easier for everybody. So make another comparison. Okay, I want to say if this campaign, okay, call on the amount that is raised, if it is greater or equal to the campaign.goal, so if it has reached the goal, then you say campaign goal actualized. You understand that? So I want to give that kind of error. Campaigns goal actualized. So let's put that error code here. So campaign goal actualized. So we can say campaign goal actualized. This is great. So these are all the conditions that must be checked before we can be able to make donation. All right, so at this point, let's actually make the donation. Okay, we're going to basically transfer the amount that is coming from the donor into the program derived address of the campaign. So the campaign itself has its own balance. It has its own account. So the money is going to be going to that specific campaign, not our platform, but that specific campaign. It's not the owner, it's not the creator, but the specific campaign. So watch how we do this. This is very important if you want to learn how to move money around. And this is one of the core purposes that we initiated this course, to teach you how to make transactions within the blockchain space. It's very important. All right, so we come here, say let tx underscore instruction. So a transaction instruction. So a transaction instruction is going to be based on anchor lang. So a transaction instruction is going to be based on anchor lang, and I'm accessing this Solana program, and I'm accessing the system instruction. Okay, because this is where the power to move money lies, in this system instruction. Okay, this is the core foundation of the Solana blockchain itself. Okay, so then I'm going to invoke this transfer, instruction here. Okay, so a transfer instruction has the following this thing. So it has the following requirement. I'm going to break this down, or let me move this up so my face will not be blocking you. So we have, so a transfer instruction has a public key. Where is this money coming from, and where is this money going to, and how much is going to this address. So where is this money coming from? You're gonna have to supply that, and this is gonna be the donor dot key. Okay, but it's going to complain because it has to be a reference. You understand that you have to reference it so that it will not mismatch the the type that it's required. So I'm going to say ampersand here, that we make it a reference. So where is this money going to? Okay, so I could break this into multiple lines. Okay, come here. So where is this money going to? The money is going to the campaign's key, PD itself. So we say reference of campaign dot the key. Okay, it's good. And how much is it going there? So we're going to say amount. See, the amount is exactly in Lamport. That's why we have to set it up in this way. Okay, but whatever amount that you're passing in here is going to be in Lamport equivalent. So this is the instruction for moving money. So after you create the instruction, the transfer instruction, you want to execute it. You want to invoke it, because right here the money is not sent, it's just prepared. It's more like you go to the bank and you want to move money from account number 1 to account number 2. So they gave you a deposit slip, and you filled up your account details and the amount that you want to send to which account and all of that, but then you never really submitted it. You just left it there. You see, you have to give it to the cashier or the agent right there at the counter to perform that transaction for you. So this is the process of doing that. It's called invoking the transaction. So say let result of invoking this transaction equal to this anchor lang again. We're calling on the Solana program, and we're grabbing program. We're saying call on invoke. So invoke will allow us to pass in the instruction, which is this tx instruction, and it must be a reference of it. Look at it. Okay, you can't just put it. It's expecting a reference. It's not expecting the entire thing. Instead, it's expecting a reference. Okay, and you want to pass the account info. All right, so this is very important. Okay, like it is done well. So the account info is going to take this shape. It's going to be a reference of an array of collections. So the donor dot, you want to convert that donor to account info, right? You also want to convert this campaign dot to account info. These two elements, these two are responsible for executing this transaction. Okay, so yeah, so these are the account infos that are involved in this transaction. All right, and then you want to ensure that transaction succeeded. Okay, so say if let error, and let's say the error here, So we're testing for this error if there is an error. Okay, if there is an error, that is what we're testing for. So if there is an error that came from this result, okay, this is what we want to do. Want to give a message, all right, and say donation transfer failed. So donation transfer failed. Okay, and when it fails, you want to give the reason why it fails, which is basically the error, or you want to format it because the error is like an object or so. So you want to pass in this error, so it will log the transfer failure right here. And not only that, we want to also return that error. Okay, and then say all.into. So this will return the error. If it fails, okay, return the entire thing with the error. So if everything was done successfully, now it's time for us to register that transaction. So I want to say transaction dot the amount. Oh, sorry, let's start with campaign. For campaign first, we want to say campaign dot amount raised to be plus equal to this amount that was donated. Okay, and you want to also increase the balance of the campaign. The balance and the amount raised are going to be different because this balance is going to be responsible for informing us how much is left in our account after we perform transactions such as withdrawing and depositing. So it's going to be different, but this amount raised is going to stay like that because we don't want to mess with it. This is going to be specifically for keeping track of how many amount of money has flowed into this. Meanwhile, this will keep track of how much amount is left after withdrawing and depositing. So that's the difference between it. And lastly, you want to say the donors, how many number of donors we have, we multiply it by 1. So we have an extra donor here. And after this, you then want to call on that transaction and start doing something. So we say amount, okay, how much did it cost for this transaction? This transaction took this amount of money, and the CID, which is the campaign ID, is this campaign, or you can just call this CID that we passed in here. Okay, so, and who is the owner of this transaction? So we'll say owner of this transaction is going to be this donor, and then call on the key. Okay, so that's the public key of the donor. And at what time was this transaction? What time did it happen? So the timestamp, we can just go here and copy this. So this line of code here. So this will give us an idea of the timestamp. And lastly, you want to tell us what type of transaction is this. So what type of transaction is this? So you say, transaction dot credited is true. So this is a credit transaction, and that will be it. So with this, you've been able to have donation coming in. Please take note of this. These are the most important part of this segment because it teaches you how to move money, the instructions on transferring fund and executing that transfer. All right, so let's make sure that it's now available here. So to make that available, I'm going to come here, close this, then come here. I'll come to this donor here, copy this line and paste here and say instructions, access the donate instruction, and they just pass those information right there. So with that, we've been able to add donation to our record. Great, we're moving far and we're going high, and in the next part of this we're going to actually try withdrawal. There is there's some key difference on how money is moved when you're donating and how money is transferred when you are withdrawing. And I told you about the split mentality. We have like 5%, going to the platform, and the 95% going to the creator. So all of those things, you're going to see it in action in the next part of this video. So let's perform the instruction for withdrawing. So I'm going to come here and create a new instruction, call it withdraw dot arrest, which is Rust. And withdraw is going to have a lot of similarities with donation, but there is also a lot of differences as well. To withdraw, it's almost similar, like I'm saying. For now, let's make sure that we have this thing called withdraw. Okay, and make sure that is included in this place. So have this withdraw, save that, close this. So say okay. So we don't have this context. Okay, so let's work on it. In working on that context, it's going to take something similar to how we do for donation. So I'm going to copy this entire donation, pattern here. I'll call this, withdraw CTX, and make sure that it is present here. So you save that. So everything seems almost right, but there are just a few things that we need to do. I need to add like 2 more accounts to this, and the first one is going to be the program state. The program state is it has information about our address. How will I say it? It has information about the platform's address, because we want to send money to the platform address, right? So we need to have access to that information, because we don't want somebody just supplying any kind of address and then rob our platform of the money that is supposed to be coming. So we're going to need that. Let's say program state, a public program state. And this program state, we can just easily get it from here. Okay, where is it? Here. So we can just grab it here. Okay, so we need to grab it there. I'm going to grab it here. So this is program state, but I want to make sure that it is mutable, because I want to change some things inside the program state, okay, which is the account of the platform I want to send some money to it. So it has to be mutable. All right, so that is one account, and make sure that this is available, and you can make that by also importing it here. Okay, so also another account that I want to do is called the platform address. This is just going to be an address. That is just it. So I could just duplicate this right here. I'll call this platform address. So this is the platform address that we're getting, and it's only going to be this. So it's not going to be an account, but an account info. Okay, so it's an account information. All right, so and if this is almost cool, you don't see any errors in the compiler, but if we do not do this here, so if we don't, let me show you something. Let's say anchor build. Okay, it isn't showing up here, it isn't showing up here for now. Okay, this panic, okay, this safe check panic here that is coming is as a result of this. We needed to add this check here. Okay, this keyword check, you need to add it on top of this sort of account system. Okay, this account info. If you don't do that, it will complain. And when you're checking, you can put some keywords. Say we are passing charges as this one here. Okay, so this is the account that is going to be responsible for receiving the platform's charges. Okay, that is what it simply means here. And yeah, when you build, this particular error should no longer be there. Okay, you can see that error of safe check has disappeared. Okay, these other ones, don't worry about it. It's just warnings from unused parameters and imports. So now this donor here, I want to make a little bit of change here. It's going to be called Withdrawal. So I'll call this Withdrawal. Withdraw. Wow. Okay. Or this place can be withdraw. Okay. So have the account here. This is a withdrawer, someone that is withdrawing the money. Okay. This is a withdrawal seed. And here we don't want to use donor, but we want to use withdrawers. So number of withdrawers, that is what we want to use there. Remember that a transaction has all those information. It has how many number of withdrawals that is keeping track of. Okay, so I think that will be it for all the records that we're going to need to perform this. Remember here, don't get these two things confusing. So this will give us information about our states, the various states on our platform, including the transaction fee, the platform fee and the platform state, platform address where the money is going to be sent. Meanwhile, this here we give us information about the platform's address. You're gonna get to see this in action because it's pretty pretty important. Okay, you will see why we needed to do this, so that this is the account, this is the platform that the money is going to be coming to. All right, I needed to do this way because this function you see here, it took most of the time, it took more time creating the rest of the program than it took more time creating this function than writing the rest of the program. It took me days to decode some certain ideas here. So don't take this for granted. This knowledge that I'm giving here will save you a whole lot of stress. All right, so at this point we can then create a withdrawal transaction. Okay, to create a withdrawal transaction, it's going to be something similar to this. I'm going to just grab all this. Okay, so I'm going to call this withdrawal. So withdrawal, this is transaction. I also want a program state. Program state, call this state. And I also want the platform address as platform underscore account underscore info. Okay, this is almost great, but there's some things that we just need to change. First of all, we don't need a mutable reference for this withdrawal, so we just need a reference, that's all. Okay, second of all, for this platform address, I don't need a mutable reference, I just need the reference to this. So once we get that, we can then come down here. Let's do some checks. I want to make sure that, let's copy this information, these checks, copy it, let's bring it here. So what are we checking for? We want to make sure that this campaign exists, that's sure. We also want to make sure that this is the owner of this platform, of this campaign, so that's why we're having this here. We can call this the withdrawal. Okay, so we want to make sure that this is the owner of this campaign, and we want to make sure that the campaign isn't inactive, but this isn't necessary because a campaign can be deleted, but you may not have withdrawn all the money in it. So I'm going to remove this here, and this amount here, okay, must be less than or equal to 1 Solana token. Okay, must be less than or equal to 1 Solana token. If that fails, we just want to drop a little error here. Let's put it here. I want to say invalid. Withdrawal amount must be greater than 0. So we can say withdrawal amount must be at least 1. So okay, so come back here and put that error here. So there we go. And also want to check on the campaign, the amount that is raised. So this here, right here, we need to make sure that is balanced. Okay, let me put this way. If the amount is greater than the balance that you do have, if this is the case, if the amount is greater than the balance that the campaign does have, we want to see insufficient fund. So say insufficient fund in the campaign. So that is very important there. And so you making all those checks, and you want to make this one last check. This check, you're saying that if the platform account info dot key, okay, if it's not the same as, if it is not the same as, this state here, call on the platform address. If they are not the same, we want it to produce this error: invalid platform address. Invalid platform address, because the platform address is very important. That is the one that we provided, the exact one that we provided when we were initializing this program. So this here, see this deployer key, this deployer, see this one here, it must be the same here. We're doing something here. We're making sure that the address that are supplied are accurate and are the same as the one that we have on our platform, so that when the transfer happens, we're not sending it to a wrong person. Okay, so that's what you should take note of here. So that's why we have this condition. If that condition is so, we want to say invalid platform address. So that will be like another error. So take note of all these various errors. Very descriptive, and your code needs to have a good descriptive error. So we say the provided platform address is invalid. Okay, so you can scan this, and you can then copy this address here, come here and paste this. So with this, we are kind of protected to a large extent. Now it's time for us to check some balances. Okay, before you send the transaction, you want to make sure you want to access the balance that is remaining on the platform, on the campaign. I want to explain some things for you. There's a concept known as rent balance. Remember, we're trying to access want to check the balance that this account or this campaign does have. If it is, the purpose of this place is we're checking the campaign balance, if it is enough to sponsor the withdrawal. All right, to do that, you first need to grab the rent balance. Now, rent balance in Solana is basically the amount of money that is needed to sustain your, an account. So an account doesn't just stay dormant on the Solana blockchain. It must have a certain amount of Solana token, just small, but just enough to keep it active. Otherwise, it's going to be deleted. So that's the reason why we're having rent balance. So that is the amount of money that is remaining for you renting a space on the Solana blockchain. And how you do that is by getting it called, you go to rent and you call on .get. This get, dot minimum balance. So the minimum balance of this campaign dot to account info dot data length. So this is the size of this campaign. This means that if the campaign has a large data, occupies a large space in the Solana blockchain, the rent balance, the minimum rent balance is also going to be higher. You understand? But if it's a small space that is it's holding, it's going to be lower as well. So it's all entirely determined by the size of the campaign data. Okay, so this will grant us access to the rent balance. Now that we get the rent balance, we want to say if we say campaign dot to account info dot lamport. Lamport give us idea of how much Solana token balance that is available on that campaign. Remember, when we're donating, the money is going to that campaign balance on the Solana blockchain. So we're checking it is in Lamport. So we're checking it, the value in Lamport. Then say dot borrow. Okay, dot borrow. And when you borrow, you want to get the actual value of the borrowing. You understand, of this value. Okay, you want to dereference it. Okay, and then you want to subtract the rent balance from it, and then you want to check, is this smaller than the amount of, if it is smaller than the amount of money that we're trying to I think the best way of doing it is to just say this amount, is it greater than the balance of the campaign minus the rent balance. If this is true, then it should return an error message. Okay, so we can say that message MSG is withdrawal exceed campaign's usable balance. So this is important, like keep note of this, and then return an error instead. And what is the error? Insufficient fund. Say dot into. Okay, so with this you'll be able to detect if we'll be able to check if what we have on the blockchain and you're trying to withdraw, we're checking it against the amount that you're trying to withdraw, if it can sponsor that operation after subtracting the rent balance and all of that. If that is true, then withdrawal is going to pass. But if it doesn't pass, then it's going to fail. Okay, remember here that you must dereference. Okay, if you don't dereference, it doesn't get the actual value of this campaign's balance. Okay, so that's one thing you must know. Now it's time for us to transfer 95% to the so let me just put some comments here. You say checking usable balance, checking amount, comparing amount to usable balance, comparing amount against usable balance. And now I want to say transferring 95% to the creator to campaign creator. Okay, and to do that, you want to get the dereferenced account info here, and then you want to call on this thing called try borrow Lamport. So in essence, this instruction here, this try borrow Lamport, it helps you to access, to mutably change, the balance of this campaign account. You understand that? So that is what we're trying to do here. So you want to say try borrow. So and you subtract, there's a certain amount here that we're supposed to do. For now, let's hold on this process, and I want you to come here, say let's the platform underscore fee equal to this amount that we're trying to withdraw, which is coming from here. This amount, I want to multiply it by the state dot platform fee and divide it by 100 to get the percentage. So the percentage of currently is 5%, so 5% will be stored here. And I want to do creator amount. It's going to be this amount, subtract the platform fee from it, and you will get the creator amount. This amount we're supposed to send to the creator. So at this point now, this campaign, we want to remove the creator amount. That is the amount that we're trying to send to oh sorry, I'm making a mistake here. So it's try underscore borrow modify, okay, mutate the Lamport. Okay, this is what is happening. Try borrow mutate the Lamport, you understand? To change the balance, we're actually withdrawing here. We're cashing out from this campaign, this campaign, what's it called? From this campaign's account, and I want to do something similar here. I want to say for creator, which is the same thing as the withdrawal, but I think for making this thing a lot more smooth, I'm going to change this to creator. Well, let's leave it this way. Let's leave it at withdrawal. So I will say this withdrawal, okay, tribal. I'm going to add, that amount instead into his own account. So I'm going to add it into his own account. But I still feel like let's modify this. I just don't like the way this is. So I'm going to say creator. Hope I'm doing everything right. Creator. Man, let's leave it this way. Okay. So I'm adding that amount. I'm sending it to the withdrawer, which is the same as the owner of the campaign. You understand that? So I think we can basically just call it, creator here. So we say creator. Okay. So the owner here, I'm gonna say. So this is the creator. This is the owner of the campaign. Okay. We're sending that amount. We're withdrawing it from the campaign, and we're sending it to the owner of, the owner of the campaign. So we want to do something similar as well for 5%. So at this point we are deducting this 5% from this platform, okay, from the campaign, and we're sending it to the platform account info. Remember that we had this here, okay? So we're doing that, and we're depositing this 5% into his account. So this will ensure that transfer of the fund is split between the creator and the platform, at 95% is to 5% rate. So after this has succeeded, I need to do some checks and balances now. So I will say the campaign dot number of withdrawals to increase by 1. Okay, and I also want to do the campaigns balance, okay, to be subtracted with the amount that was cashed out. Okay, those two information are important. And now I need the transaction, which basically I could just copy all this. Okay, all of this here, I'm going to copy it and paste it here. Then I will make sure that this is false because this is a withdrawal situation. And who is the one authorizing this, performing this transaction? That will be this creator here. So I'm going to make sure that this is the creator. Okay, so and with that, that is all you need to be able to create a to write a withdrawal instruction. So at this point, let's jump into the main place here and just make sure that we put that together there. So we have it. Come here and see instruction, call on the withdrawal instruction and just pass this. Okay, this is great. This is great. There is one last step, one last function that we need to create. Okay, so this last function, then we are done with this smart contract. Okay, so I'm going to close this and close this. Let me just close those ones. So in the next part of this video, I'm going to show you how to update. Remember we have like 5%. If you check this program state, and this initialization sequence, you see that 5% was given to the as the platform fee. So we want to create a situation that will enable us to change this and only be changeable by the owner of the platform. So I'll see you in the next part of this video. So at this point, I need you to go to, we're not going to be creating any state because the program state is already available, and that is the only thing that we need to manipulate the fee percentage. So I'm going to come here and create a new file. This new file is going to be called update platform underscore settings .rs. That is TypeScript, and make sure that this is available here. That is Rust update. Okay, so there we go. Close this. So at this point, the drill. I'm going to copy some of these record. I'm going to definitely not need these the only thing I'm going to need here is program state. So yeah, I'm not going to need this either. Okay, so now we're just going to call this is the name of this function. Okay, CTS context. I'll say context. I'll call this update platform settings CTX. Okay, and what do we also need? We need a new platform fee, which is 64, and of course returns a result. Okay, so see, okay, this is great. Now I need to make sure that this is created here. Of course, I'll say public struct and the name of this. All right, and we'll come here and make sure that it says info, and make sure that is a derived account. So we'll say derive accounts. Okay, so and then you come here. Want the updater, basically the updater is basically the same thing as this withdrawal. So the signer. Basically, that is what we're going to call this owner, or let's say updater. Okay, let's call that updater. And this updater, please listen, it must be exactly this platform address, this deployer key. Okay, the deployer key must be the one updating the percentage, otherwise it will not be accepted. So you should take note of that. And we want program state. Okay, we want program state. We can just copy program state here, copy all this, come here and paste. Now for this program state, there are some things that we need to change. We don't want to put all this. We just want to modify it. So I'm going to say mute here. All right. So that is it. Basically, updater and the program state. Those are the two things that you need. And you don't need to initiate. Initiate it means that you are creating it afresh. No, we're just accessing it because it's already been created. All right, during initialization. So these records are complete now. So I'm going to need some access the state, which is this context ctx, and it's going to be mutable reference of the account dot the program state. Okay, because I want to change it, and also I want to access the updater, which is just a reference. Okay, call this updater. Okay, so I'm grabbing those two information. I want to say now that if this updater dot key is not equal to this state, you see what I'm doing here, this state dot platform address. All right, then it should give an error, say return error, say unauthorized. So you're not authorized to access this place. And then you want to say dot into, of course, so that it can be applied. So if that passed successfully, you want to also make sure that the amount that is being supplied is within the range of 1 to 15. Okay, 1 to 15%, and we want the minimum to be 1%. So we don't want you to go beyond that bandwidth. Okay, so that limit must be maintained. So you do that by saying, so pound symbol, say giving a range. Okay, so we're saying from the range of 1 to 15, if that it contains this new platform amount. If it contains, then you want to return. If it doesn't contain, okay, that is why I put this pound symbol. If it does not contain, if the amount that is being put as a platform fee does not contain, it's not contained within this range, then you should return an error saying that invalid platform fee. I've introduced it to quite a lot of errors here. Invalid platform fee. So you come here, paste, and you say invalid platform fee, but this is giving an error. Let's say dot into. So this is giving an error. It has to be a reference of it. Okay, so you're referencing this and you're checking against this new item, this number, if it is, if it matches, if it is contained within this range, then we're good to go. But so if it fails, then it can pass through. So once all those requirements are fulfilled, Then you can now say state dot platform fee, then you update it with this new platform fee, and that is just it. With this, you'll be able to modify the state of the charges that the platform is taking. And afterward, you want to make sure you include it here. Including it here, it should be pretty simple. You just want to copy this line and paste here and say instructions and say update platform instruction, and that is it. There is no error anywhere. So you want to build this and see if everything is all right. Everything seems to be all right. There is no more warnings, nothing, no unused anything. Everything is all good. So in the next part of this video, I want to start showing you how you test this smart contract. You want to test out the smart contract and make sure that every single thing are doing exactly what we had designed them to do. Once we verify that, then we can jump in and start integrating it into our front end. So I will see you in the next part of this video. Okay, the next thing we want to do is to test. But before testing, we want to do something different. In the last build that we did on this channel, when we were working with Anchor, we realized that there were need to initialize some certain, state variables. Some things needed to be initialized first before you will be able to interact with the functions successfully. And we had to be doing that on both the test and also on the interface. We had to have a button where we click initialize, and that wasn't very nice, and it also increased the number of lines of code that we needed to do on the front end. I'm proposing a different way of doing it in this particular tutorial. I'm going to write it in a different way to make sure that anything that has to be done once, it's not necessary for that to be on the front end. Okay, so for example, before we are even able to do anything, on this function, before we're able to create campaign, update campaign, or make donations, and so on, we had to have had the contract initialized, and the initialization of the contract should only run once. Even with the instruction, it is designed to run only once. You can see that if it is already initialized, say it's already initialized. This would have been cool if Anchor Solana does have a constructor function that automatically runs. Then we won't need to, dedicatively, write a function that addresses that matter. So this is one of the bottlenecks that I've seen in the contract development for Anchor. So the way that I propose on doing this is a little bit different. Okay, so how we're going to go about it is we'll create an initialization script, a script that will be responsible for starting, executing that function. So I want you to come to this Anchor, create a new file. I'm going to create a new file. It's going to be under a folder called scripts, and I'll call it init.ts for TypeScript. So that's what it's going to be, a TypeScript, script. Sounds repetitive. So I'm going to create a function called main, and what this function simply will do is accept a cluster. A cluster is a string. A cluster could be main, it could be the main function, it could be the main cluster, it could be the testnet, the devnet, or the localhost. So all of these things. So I want to create an object that contains these various clusters. So I'm going to have const clusters, cluster URLs, which is any, of course, and is gonna have these various items as its object, For example, this is the main for mainnet. For mainnet, this is how it should be. So mainnet beta should lead you to this particular URL. So if I'm supplying this cluster as mainnet beta, then this will be the string, the endpoint that I'm supposed to be pushing this thing to. So I'm also going to need testnet, and the rest of them. Okay, so I'm going to paste this here. Okay, so these are the various clusters that exist on the Solana blockchain that I can make use of. Okay, and the next thing I want to do is to create a connection to the cluster. So this one defines the clusters URL, and this next step creates a connection to the cluster. And so let's create a connection. Say const connection is equal to new anchor dot web3. We don't yet have anchor here, so we need to import it first. To import anchor, let's do import everything as anchor from this URL coral-xyz/anchor. This coral.xyz/anchor is part of this packages we installed. You can see it here. So this gives us some anchor connection. Okay, so it's very important package right away. So anchor, you can say new anchor now, and then you call on the web3 module and you say connection. All right, so we open up the connection, we say cluster URLs, and we're targeting this cluster that we passed in here. So this will give us the URL that we're supposed to connect to, depending on whatever we passed in as the parameter of the main function. Okay, and we are targeting the status, or what they call commitment flag for this connection to be confirmed. Okay, so we're done creating a connection, and after you create a connection, you want to load the wallet. You want to load the wallet address of the deployer key from wherever it's stored on your computer, because if you want to make this initialization, you need a wallet provider, a deployer key, or whatever, whomever is the default person that is responsible for sending out or sending transactions, so that wallet provision. So to get that, we say const, we can call this load the wallet from the deployer. Okay, this stage deployer's key pair file. So this stage is very important. Okay, this will save you a whole lot of doing it on the front end, and not everyone is supposed to run this function. This function is only the person that is responsible for running this function is the deployer. Whomever is deploying this deploy the contract is the one that will also run this particular script to secure and permanently set up everything, so that campaign creation and the campaign activities can start happening without any issues. So we say const key pair part. So this is the part where the key pair exists, and call it the string. So say this process dot environment dot home. Okay, / dot config. So we're accessing, this is specific to my computer. Okay, so wherever your own key pair is stored on your computer, then you have to specify it in this part. Since I'm using Mac, and if you're using Mac, I think this will just work just fluently for you. But if you're using Windows, it may be a little bit different because these parts are different for each operating system. And probably also for what is it called, Linux-based systems such as Ubuntu, these parts should probably remain the same as well. This is Solana and id.json. Okay, so this is the part to the key pair, and it's a const key pair data. So get the data. So JSON, is in JSON right now. So we need to pass it so that it become like an object. So say dot pass, and we're calling on fs. Fs module is going to be coming from here. We say import fs from fs file. I think fs means file system. I call it file system basically. Okay, it's file system basically. So the file system. So we're accessing the file system because you want Node.js gives you access to the file system of the machine that it's running, and this is Node. Okay, fs is a provision that came as a result of installing Node.js on your local machine. So I'm going to access this fs dot read from sync. Okay, returns the content of the path. All right, so I'm gonna pass in the path, which is this key pair path, and the standard, the encoding which we are looking to read it on from. So UTF-8. Okay, this is standard. So now I have the key pair data, and now this is the wallet. I get the wallet address or the wallet, entire thing. So you can say anchor dot web3 then you call on key pair, okay, and you call it from secret key, because this is the secret key right here. So I'm passing the secret key here in a unit on unsigned integer 8-bit array. Okay, so you say on int 8-bit array. So then you say dot from this key pair data. Okay, so that will give us the wallet address, and now we can use that to create a provider. So create a provider, and creating a provider, now you say const provider is equal to new anchor provider. Then we need to pass the connection which we created above here, and you say new anchor wallet, and you pass in this wallet we just derived, and then lastly an object that will be the commitment level to be confirmed. Okay, so this will get us the provider, or set up a provider. Basically create a provider object. Then we can set that provider up, say anchor dot set provider, and then you set it with this provider. Boom. So with this, you've been able to set up a provider. Now this provider enables us to communicate with blockchain of any cluster that we wanted. So let's go. Now let's load the program, the fundus program, that we want to interact with. So our smart contract, basically, that's what I'm saying, the ideal. So say load the program. So to load the program, you say const program is equal to new anchor dot program, and this is where we load it. But you will need to import the type of that program, information about that program, is going to really help, it helps to define a structure for us to follow, so that we'll not be working in a dark room. So these type and structures of this that anchor build or generate by default, when you click anchor build, it helps provide light so that we can know the various properties, functions, methods, and all that our smart contract generated. So I'm going to say import something from, we'll go to dApp, we'll go to targets, go to types, and we access fundus. Okay, so in this fundus type, which is basically going to be very useful for TypeScript, we want to import fundus here. So at this point, we can then see that this program is a type of fundus, and we need to also grab the idea from almost this location. So say idea is coming from the target, of course, slash idea slash fundus.json. So you need to pass in this idea. This idea, let's look at this idea. You see, it contains every information that the smart contract builds or generates, such as this is the address or the program ID. Okay, you have all this information about the program. You can see the instructions for creating campaign, deleting campaign, and all the information about the various functions and parameters, context, so many things. You can literally use this to recreate the function. This gives you the ability, with this information here, you'll be able to use even though you don't know the smart contract, to a large extent, you can use an AI to recreate the smart contract with this information. That is how powerful this information is. So now I'm going to pass in this idea here, okay, because those are the things I'm supposed to pass in: an idea, like you can see here, an idea, and also a provider. Those are the two most important things that I'm supposed to provide. So this is the idea I'm passing in, and also want to pass in the provider. Now the idea is giving me a little bit of an issue because it's supposed to be a certain type, and this isn't just getting it. So what I'm going to do is I'll call it as any, so that we straighten it and make sure that it doesn't complain. So after I've gotten that, I can start interacting with the smart contract. One of the things I want to do is, first of all, get the program state PDA. The program state, when we're dealing with initialization function, okay, when we're initializing this function, let's come back to this instruction. So because we have this thing called program state here for initialization, you're going to need the program derived address, because this is an account. So since it's an account, you need the PD of the account so that you can interact with it here. So I'm going to say const equal to public dot find. Now this public is going to be coming from somewhere, okay? Is going to be coming from, let's say const with the structure this anchor dot web3. Okay, we want to access two packages. For now we say public key. So this public key, now this is what I'm interacting, this public key, and I want to say dot find program address sync. Very important. Find program address sync, and there are some things I'm going to pass in here. Like you can see, this program address sync, it for this PDA, this program state, it contains information such as this seed. Now this seed here, so I need to make sure that I represent this seed properly in buffer format. So I will say buffer dot from, and then pass in this program state. So that's the only seed in that array. And then I will say program state, program colon this program ID. So this program here has an ID. Okay, so yeah, the program has an ID, so I access the program ID from here. So now I have this program state. I can run a try catch here. The reason why I'm running a try catch you will soon discover, but we needed to wrap it up here because you can see that this will return an error if the program is already initialized. So I'm making a provision, I'm making an arrangement for a situation that you're trying to initialize this function or initialize the script again. You're trying to run the script a second time when you've already run it. It should just tell you that this particular initialization function has already been done, the initialization has already succeeded. You can't try to do that 2 times. So that is just a safety net right there. So I would say const call it state is equal to this await this program colon dot account and colon the program state. You can see because of this fundus here type that we're getting here from this generated packages build, we are able to access those information, without being blind or working in a dark room about it. So I'll call on dot fetch here. Dot fetch. There are many kinds of fetch thing, but not all of them are very useful to us. So this fetch helps us to grab an account from the Solana blockchain. So I have to pass in the address of the account, and this address can be gotten by program state PDA. Okay, program state PDA. This is the address, so I'm going to pass it here. Okay, and wait, so it's saying that this expression is not allowed because this is not an asynchronous function. So I have to make this an asynchronous function here by adding this keyword async, and that error is gone. And after I do that, I will just log off a console log, say program already initialized. So if there is a state, we found a state, this returned successfully, this executed successfully without any error, then it's just going to log it out. Because if this executed, if this is allowed, this worked out, it means that this program has already been initialized. But if it doesn't work out, then it's going to proceed with the other, whatever piece of code that we're going to write here. So say program already initialized, and say status is, then we can put in something like that, this state here dot initialize. You can see we have access to all those information that we wrote on the blockchain. So this is how cool it is. Very important that you write it this way. Okay, so that gives you, that would be for a condition or a situation where this has already been initialized. But if it has not been initialized before, then we want to call the initialization function. So we do that by saying const tx for transaction. I'm going to save this transaction. I'm going to ensure that it is finalized on the blockchain before I even move on. Because if you don't finalize it first and you proceed to, let's say you're running this init function and it has not yet been finalized on the blockchain, and you're trying to create a campaign immediately, then there will be some issues. It will not succeed because it has not yet been confirmed on the blockchain. So those are some vital issue that you should take note of here. So we'll say program dot, there's a method called RPC, there is various way. This way here, it's kind of depreciated. Like that's why you can see this depreciated, issue. I think the right way to do it now is to call methods dot initialize, and that initialize, it doesn't really accept any argument, and then you call dot RPC here. No, dot something like partials dot account partials, and then dot RPC. So this is how it's now happening, and this account partial is normally this way. So we can break this into multiple lines. Make sure this is on this line. Now, what does this require? It requires a program state, remember, and this program state, you're going to have to pass the PDA that you created here, which is this program state PDA. Okay, it requires a deployer. Remember that it requires a deployer and it requires a system program. So we say deployer is going to be this provider dot wallet dot the public key. Okay, so, and then it requires a system program. Now just take note that anytime you see anything that is separated with underscore, when you're working with it on the front end, it's going to be translated as a camel case. Okay, so just take note of that. So the system program, I'm going to grab it from here, say system program. So this is coming from Anchor Web3. So I'll say system program dot program ID. This one is different, and it's very unique to the Solana ecosystem. So this we create or perform the transaction of initializing this particular function called initialize, and afterward you want to wait out for the confirmation of this transaction. And how you do that is say await connection dot confirm transaction, and then you pass in the transaction that you're trying to confirm. You can see this particular one has also been depreciated, but I haven't yet figured out a replacement for it, so that's why I'm still using it. So even the other one, it still works, but for future purposes, please find out the replacement for this confirmed transaction here. And this confirmed transaction, the commitment level is finalized. Please make sure that you understand this, very important. And then you log out a message saying program initialized successfully, and then you also print out the transaction ID or record. So when you save this, we're good here, and let's go. Okay, so let's run this. Okay, at this point let's run this and make sure that everything is working. And how we run this, our blockchain is running from the previous video. I showed you how we started it up, but I can end this and run this again. So come here, we are in this, make sure that you're in this anchor folder right here. So you do anchor, since we didn't change anything in the smart contract, we can just do anchor deploy and run that. So our smart contract is going to be deployed on a net. You can see it's deployed with this program ID. Now there is something else you need to do. You see, for us to execute, that this thing is written in TypeScript. For us to execute a TypeScript file on the terminal, we needed a package called esrun. Look at it here. So this esrun will help us to execute this script right here on the terminal. So let's check it out. So we'll say npx, I would go esrun. Okay, that's that module, and then we'll call on this script folder, and then the init file.ts, and then we execute it. Then we wait out for this. So I know why this is failing. This is failing because we did not, execute that function. Okay, we only created a function, but it's not it's not active. So first of all, I want to execute that function now by calling this main function and say .catch. If there is any error, you should just report that error. I say logging out. I logging it out, so that error. So, but I need to pass in a cluster here, and the cluster that we're dealing with here is, in this case, is going to be the if I open, let's say cd, and then code.env. Okay, I don't have anything on my env file right now. Okay, so for now, I'm going to do something. We want to use something similar to what we did here, okay? And want to use something similar to that on the environment variable here. So since I am dealing with Next.js, so I'll say next public cluster. I'll call it next public cluster. Okay, for this I'll say local host. For now, this isn't very necessary though, but later on we're gonna need it. So we can say here that const cluster is now equal to, this should be a string. We're making sure it's gonna be a string. Okay, and we'll say process.env dot this, and then put a fallback of localhost. I think it's like this. Okay, so if it does exist, you provide it. If it doesn't, but at this point it will not really matter, because we are not yet, the default one is localhost. So if it does exist or it doesn't exist, it doesn't make any difference in this case. So I'm going to pass this cluster here. Okay, and with this I will succeed in executing this function successfully. So let's cd into the anchor and environment and run this particular command again, which is npx esrun script /init.ts, and let's see how it goes. So we're waiting. So this is waiting out for the confirmation to the, you see, is initialized successfully. It's waiting out for the finalization. You see, if the commitment level was just, if it was just confirmed, it would have been fast. But since it's finalized, it's waiting out till this particular transaction that is performed is completed and is finalized on the blockchain. So you can check it out by coming here, to your Mozilla, browser in this localhost and checking for that transaction record. You can see that this is a transaction record is initialized. Okay, instruction initialized. This is the program log, and that is cool. And you can see the program that is being initialized. You can see the various accounts that were involved in initialization. The system program is definitely involved. The deployer, which is the signer, okay, is also very much involved, which is the public key of my loaded secret key. And this one here is the program derived address for this particular initialization. Okay, so in case you don't understand what I mean by that, this is the program derived address. So this is the account that I'm talking about here. So this is cool. What if I try to execute this function again? Okay, you see that program already initialized status is true, so it doesn't need to initialize more than once. So that's what I actually mean. So with this, we're cool. And in the next part of this video, I will now show you how to test this function. We start writing test cases to test out the various functions in this smart contract. So I'll see you in the next part of this video. Okay, so in this step, let's go back to this Anchor folder. Inside this test, I've already written this before, so this is fundus.spec.test. I'm going to remove all these things. Okay, this is fundus.specification.ts. So this is the test script. So create everything from scratch all together. First thing I want to do, okay, is to come to this place and say describe, okay, fundus. So this is fundus, or we can call it crowd. Let's call it fundus. That's the name of the contract. So why do I keep calling it fundus? It's actually fund us, not fundus. Okay, so this is the describe function, and we need a provider to grab the provider. Okay, provider is equal to Anchor. We don't yet have Anchor, so we need to import Anchor. So to import Anchor, we're going to say const. We're going to do something similar to this, which is copy this, paste that, this import Anchor, and we also want to grab this. Okay, so those are the two things that we need. We can call on Anchor here, dot Anchor provider. We did that similar to this. You can see how we created a provider here and we set it up. Okay, so but we needed to grab the key pair, but in this place it's going to be a little bit different because we are not going to be grabbing the key pair that way, but instead we want to call on the local. The reason why we're not calling on the local using this method here is because this function is applicable to all chains. I mean all clusters on the DevNet. But when you're testing, when you're running test cases, you're only testing on local development. You understand that? So you're not testing on a live server or only test server. So because of that, you want that to be fast. So this provision by Anchor enables you to load up all the wallet and all that, without you having to set up too many things about the provider. That's the difference between these two. Okay, so with that explained, you can then easily say anchor.setProvider, and then you say this provider, period. Now we need to grab the program as well. Say const program is equal to anchor dot workspace. This is how you get the program this time. You see here, after we've finished setting up this provider, the way we got the program in this initialization space is by calling it this way. We can actually do that, that same way. This is one way you can do it. This is another way you can do it. This other way you call it using workspace. Okay, so you can say anchor.workspace and then say dot. So I would like to show you a different way of doing this. This is how we got load program here. Okay, and this is cool, but we can also do it this way by especially when you're working with this .local, and then you say your program provider, you can call on anchor.workspace and then say .fundus. Okay, so this knows how to figure out where the ABI is. IDL, this ABI ID and types, all these things are figured out using this one workspace, and you wouldn't need to write all those other scripts at all. Okay, so that is why we're using this. Just know that this is the second way of doing it, and there will be situations where you're going to need this way. So you say write our first our first test case, and it says it creates a campaign, and this is going to be an asynchronous function. Okay, so first thing you want to do is when you're dealing with any one of these test case is to get the wallet address. So in this case I'm going to say creator is equal to this provider dot wallet. Okay, so that's the wallet address. And you say you want to get the program state, because if I'm communicating at this point, let me close this. Let's say create campaign. So if I'm communicating with this create campaign, if I'm communicating with this function create campaign, then I'm going to need the program state for sure. I'm going to need the campaign, I'm going to need the creator and the system program. So that those are the things we need for the account. So I had already done this here, so I'm just going to copy this program state, just copy this thing here. We don't need to do everything from scratch. So that is the program state that we defined earlier. So after this program state, we want to know the next key, okay? Because if you look here, you can see that program state dot campaign count +1. So I am preemptively guessing the next program state ID by supplying this +1 here. So I need to model this. I need to model that into my PDA determining my seed structure. My seed structure has to model this way of determining the next program ID. I hope you understand what I mean. So, but to do that, you then grab this state, say const state, and you want to say await. Basically, this is the same thing that we've done here. You want to grab the state here. Okay, so I'm going to grab the state. So I'm grabbing the program state. Now I want to hold the campaign ID. Okay, I want to call this is going to be called campaign ID. So I want to put it in a place where it will be accessible to every test cases in this function. So I'm going to do that now. So I will say let CID be any, and here I will say CID is equal to this state dot. Now, because we're using this method, it doesn't really provide me with those information, which is one drawback. So I think the best way you can do this to make sure that it provides you with those IntelliSense and all that is to use this method here. So if we use this method and replace this, make sure that we have this imported. Okay, we have funders, and you want to make sure that you have ideal, the ID as well. This method will make sure that you have at this point, if you do dot state exe, it gives you IntelliSense. So that's the difference between the other one and this one. Okay, so I think I prefer this one since it provides me with IntelliSense. Very useful. So I'm going to call on this campaign count right now. Okay, and I will say dot add, because the campaign count is a big integer. Okay, just know that in Rust generally anything that is unsigned integer, okay, or integer, anything that is integer is going to be, especially if it has this base 64 is a 64-bit integer or whatever, is going to be regarded as big integer. So when it is coming over here, it gives you some certain ability, such as you can add things. You don't add using plus, you don't use plus here. Okay, you're going to use the keywords, called add. So for me to preemptively determine this seed, you see, I'm adding 1 to it. And for you to add, you need to also add in big integer, big number, not big integer, big number, which is bn. You need to add it in big number format. All right. So, and how we do that is by saying new anchor dot big number. Okay, and we need to add 1. So we're converting this 1 to big number, and then we're adding it to this campaign count so that it will determine the next step for us. So I need to then create a campaign PDA. Okay, so I need to create a campaign PDA. So to do that, I'll just come and say campaign PDA. And now in this campaign PDA is going to take a little bit of a different shape. So first thing, you want to make sure that you grab this campaign. That is what you're specifying here. And it's going to be more than 1 seed. So this is 1 seed. Okay, seed 1. So seed 2 is to convert this CID, this CID to, it doesn't give us, but I think .to buffer should work. But let's use this way. This way is tested. Let's use the tested way. Say to array like, and then you say buffer, and you're specifying the left endian, and you're saying it's 8-bit. So this will be how we're converting it into the exact format here. You can see that this is to left endian, byte, it's an 8-bit, structure right there. All right, so that is what we're specifying. So this will get us the campaign PDA, the program derived address. And now we want to create the campaign information, because if you look here, we need to supply the title, description, image, URL, and go. So I'm just going to go here and paste it here. So we have this title. I'm interpolating this title and converting the CID to a string, which is basically like going to give you a human understandable format of it. Okay, because the big numbers are not really readable, easily by a human being, but these ones are readable strings. Okay, so this is the campaign goal here. Now for this campaign goal, I'm going to make a little bit of an adjustment. I'm going to multiply it, I'm going to multiply it by that 1000, which is this here, to give me the accurate representation. So multiply by this, and I will say something like 25. This is 25 Solana tokens. Okay, so that is this campaign goal, about 25 Solana tokens. So 25 souls. Okay, so that is what this means. And at this point, we can then do something like this, call on the transaction. So I'm going to copy this line, paste it here. So for this method, what am I calling? I'm calling on this create campaign method. And in creating a campaign, I'm going to need the title, I'm going to need the description, I'm going to need the image URL, and I'm also going to need the goal. So those information, that is what the campaign is seeking for. And then here, I'm going to need, like what we have here, I'm going to need the program state for sure. I'm going to need the campaign, the creator, and the system program. So we have this should be the creator. Okay, the creator can be this now. So we say creator dot public key. So this is the creator, and we have system program. We also need to pass the campaign. So we say campaign is going to be this campaign PD. All right, so there we have it. Those will help us to create a transaction. Now for these ones, we don't really need to wait out for their confirmation, so we can just proceed. So we say transaction signature, okay, and say TX. Okay, so we'll log it out. So after we log out the transaction signature, we want to load the campaigns and find out how many, if we have a real campaign now. So we say const campaign, the campaign object basically that has just been created. So we say program dot account dot campaign dot fetch the campaign PD. So this will grab you the campaign, and you can then log it off by saying campaign, and then you pass in the campaign object that you just grab. This is great. And there's two more steps that I want. Okay, I'm going to get that later on. Later on, we're going to need that. So for now, let's save this and run this on the terminal. For us to run it, I need to open this. I want to do anchor test, but I want to put this help flag because I want to grab some certain information. So the first information I want to do is I want to skip local validator, because if you don't skip that, it's not going to just work out the way you're looking for it. And I want to skip deploy because I don't want to deploy this contract again. I've already deployed it. So those are the information that I want to skip. So we can now have anchor test, skip local validator, and skip deployment. So let's run that and see if everything is working out just fine. So it's finished optimizing and it's running the test, and the test succeeded, and you see it's grabbing the campaign information. You can see the transaction right here. So with this transaction, I can even come to the Explorer and check for that campaign information. You can see that we have this instruction to create a campaign here, and this is data, all these things that we just created in hex format. You can see the 4 or 5 accounts that we added to it. If you check here, how many accounts? 1, 2, 3, 4. Where is another account? 4 accounts. That is what we passed in. There's also 4 accounts here. 1, 2, 3, 4. So when we check here, we have 5 accounts though. 1 is system program, understandable. 1 is the signer, so understandable. 2, that is creator. This is the program derived address. Okay, that is 3. And okay, this one is the program. Okay, and this one here is the program state. Okay, this is the program itself, the program that we are working with. All right, so this is cool, and yeah, that succeeded. And you can see the information about the campaign, such as the CID. You can see that this is a big number format. The ID of this campaign is 1. This is the creator of the campaign. This is the test, description and all of that. So, and it's currently active. So withdrawals, all and balance, withdrawals, donors, all of those things are all good. So that's good. Now in the next part of this video, I'm going to show you how to update a campaign, and also delete a campaign, and we'll just keep moving forward and test out the entire functions in our smart contracts. So I'll see you in the next part of this video. All right, on the next test here, we're going to try and update this. So what I'm going to do is we actually duplicate this, and let me close this one. I will call this update campaign, and there's the creator. So in updating a campaign, you need similar things like before. The thing is that you will not need this line anymore because you're not trying to create a new campaign. There's a campaign PDA, it's great. It's utilizing the same CID that we stored. Remember, because of this last line of code, this line of code, we're going to be having access to the recently created campaign. So the ID of it, you can always have access to it there. All right, so this is the campaign, and you want is a new title. I just put new in front of them, new title, new description, new image, and new goal. So we can call this updated campaign title. I think we can just we just say new title. Let's just update only one thing here. Maybe we'll update the description as well, say new description. So say, let's don't do it here, we'll do it here. New updated text, updated, and maybe we say want this to be 30, okay, instead of 25 Solana tokens, so 30 Solana tokens, and that is good. It should also take note here that during the creation of the campaign, this actually it did not flag it as erroneous because we are making sure that we're dealing with Solana tokens here and not values below a Solana token. Okay, so we have all this information. Now we can come here and call on update campaign. Now in updating the campaign, I'm going to close this. You will need the CID. This is one that is missing, so we need that CID, and I'll just pass it here, call it CID, and that's great. But there's some other thing. Let me shift this over here so that we can see what we're dealing with. So we have, for updating the campaign, you need a campaign, the creator, and the system. So basically, you don't need this program state here, so it's not required. And this is the value of making sure that you typecast this program with fundus so that it can know exactly what is needed and what is not needed, so you will not have to waste your time and try to figure out things in a black box. Okay, so with that, I will not need this anymore. It kind of streamlines and make the entire testing simpler and cleaner. So this is great, and this is the campaign. After it was updated, we'll use that to check the campaign record before and after it was updated. Okay, so let's run this and see how it goes. Remember, the goal is the same evaluation here, so let's test it out. Come here, run. Now it's going to create another campaign. That will be the campaign number 2. Okay, we're having an issue here. It's saying it actually updated though, but the creation failed. What's happening? What happened? So it's saying that address is already in use. Okay, so something isn't adding up, guys. I figured out the reason why that was messing up is our bad. Okay, so I'm going to explain it to you, all the way. The thing is that each time we created a campaign, even though our logic had already authorized an increment of that program state, the campaign count, to increase by 1, it is not increasing. Why is not increasing? Because of one vital issue. Okay, this logic is correct. It's supposed to increase by 1, but the problem is this program state is not mutable. I forgot to instruct it to make it mutable. Without mutation attribute to read, it cannot change from one state to another, which is required. Look at how this is. This makes it mutable. So if I copy this line of code and come here and put it above here, then this will be mutable as well. Okay, so this is the major issue that we were experiencing, and that's why it wasn't working out. Okay, so I'm going to redeploy this, build this thing again, redeploy, and work on it again. Hopefully I don't need to do everything from scratch, but we can just do anchor build now. If there is any error, it's going to flag it here. This thing is just a fake error. It's not really an error. It's just a dummy complaint. So compilation is completed. Now I'm going to redeploy anchor deploy. Now, please take note, whenever the simulator complain like this, all these things concerning recovery of intermediate account, keep here, season, blah, 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 this issue that you're seeing, okay, just restart the Solana console. That is all you need to do, and that means you're going to have to do everything from scratch. So you have to restart this Solana console, Solana blockchain, and after that, then you can redeploy, okay, and make sure that you initialize as well. That step is very important, otherwise the test ain't gonna work out. Okay, so now let's run the test again, the same test. Let's run it this time again. Okay, so the first time it passed, right? So look at the previous state, the state of it and the blockchain, and when we incremented it. Okay, so now let's run that again and see. Okay, it's working now. You can see that this is 1, and you can see that this increased by 1, and the creation is just working out great. This is exactly what we wanted. Okay, I'm going to close that because it's just giving me a fake error. Okay, so updating and campaign creation, they are all working fine. I don't need this line of code anymore to verify anything. I can close this, and in the next part of this video, I'm going to show you how to delete a campaign, and then we can proceed. Please take note here that active is true. So long as active is true, that means that campaign is not deleted. Okay, so let's go and delete the campaign. Okay, so at this point, I want to open this delete campaign record, and let's work on that one as well. So I'm going to duplicate this, copy this, and paste, call it delete campaign. So in deleting of a campaign, what do you need? You need just 3 accounts: the campaign, the creator, and the system program. Now this is the campaign. We don't need all this because we're not updating anything. So I'm going to remove all this. You can see from here that the only parameter will be this CID. So I'm going to have to make sure that I have delete campaign there. Basically that will be it. So that will help us to perform that test. So let's check it out and confirm that everything is working. So let's run that. So everything is working. This is it when we created it, the 3rd campaign. So we updated this 3rd campaign. You can see this record here. So we updated it, and then we are deleting it. You can see this active state here is true, and later on after the deletion, the active state goes down to false. So that is how you delete a campaign in this platform. The next thing I want to do, I think I should show you how you can update the state or the percentage of the platform fee, so that let's get that part together as well, the platform fee. So I'm going to duplicate this, say update platform fee. Okay, so this will be, I'll call this the deployer. Okay, so let's say update platform fee. This is the one we're working with, and this only needs two accounts. So I'm going to make this the updater and the program state. Okay, now this one will pass because we have mutation flag here, so it's going to work out. So we don't need a campaign here. We don't need to work with campaign, so we're removing this, and I'm going to call on update platform settings, and this is going to be the updater, and the system program is not required. So what we need is a program state, and you can get the program state here. We can just copy this line and replace it here. So call it program state. You pass this. Okay, and now I'm going to call this before and after. So for now, let's say let's call this program. Let me just say program state. Okay, and then you pass in this program state PDA here. So here I'm going to call it, let me reduce this here. So yeah, I'm going to call it state. Okay, and this should be state. So I'm going to call it before and after. So before, let's say okay, or say state before. Okay, and state after. Okay, we can leave it this way, or just call it state after, so that you can see the difference, between when we updated it and when, before we updated it and after we updated it. So, and if we're updating, we also need to pass in the new platform fee. So the new platform fee in this case, we want it to be, I'll call it here new anchor.bn. So I want it to be 7% now. Okay, it's failing. Okay, we don't need, they only need one of it. One, it only takes one parameter. So I'm going to save that, and let's run this test to see how it goes. So I'm going to run this test now. So that entire thing passed. You can see, so this is before updating it, the platform fee is 5, and after updating it, the platform fee is 7%. So that's the difference. You can see the number of campaigns that we have is 4, and you can see the initialization status is true. You can see the address of the deployer, or the platform address, which is this. So it's all cool. Now at this point, there are 2 more functions that we need to test, which is the donation function and the donation function and the withdrawal function. So we're going to test that in the next part of this video. To donate to a campaign, I'm going to copy and paste this, call this donate to campaign, and in donating to a campaign, I need a donor. Okay, so the donor, and I'm also gonna need the campaign itself. So to get the campaign, you can just use this record here. So we're not needing this program state, so I'm going to paste this here, campaign here. I'm going to remove this too because I'm not going to need that. So I need the campaign PD. Now let's come to donate here, instruction. The donate instruction requires this following account: the campaign, the transaction, the donor, and the system. So we have how many here? We have we just need to supply all of them. We need to create a special one again, which is this, this transaction PDA. So we need that. I'm going to create that right now. So transaction PDA. Okay, for this transaction PDA, this is how we're going to form it. So it's going to be called donor in this instance, and let me break that into multiple lines. So a donor, and then we also need this donor key. Okay, the basically the public key of the donor, or the that's what it is, the public key of the donor. So I'm going to say this donor above here dot public key, and then say dot to buffer. Okay, so to buffer we give you its representation this way. Okay, and we need the CID, which is already represented pretty well. Okay, and then we also need one more, which is not the CID this time, but the campaign donors. Okay, the number of people that have participated in that campaign. So, oh boy, I've been doing this in the wrong place though. So I'm gonna come here and do this, and I will cut this one and bring it here. Okay, so I will do that in the right place. So, but I need to fetch this campaign first, because I have some information from that campaign that I want to add up here. Okay, without those information coming from that campaign. Okay, we don't need to do it that way. We don't need to do it that way. We can do it, we can do it this other way. All right, so let's do it this other way. So I want to have donors, we can call it donor count, and this is going to be any as well, any. Okay, so for this donor count, when I create that donor, so when I create a campaign, at the same time I want to say this donor count is going to be this campaign dot donors. Okay, that will give me the total number of donors that we have for that particular campaign, and I can then use this donor count here by saying this donor count, then I have to add one plus add, and I have to add a new anchor dot bn, add one to read. Okay, and then convert it to this array format before I can send it to the blockchain. So this will give me this representation. So campaign dot donor, which is this donor count, and adding one to it, which is this part, okay, and then converting it to array in this format, buffer in this format, and this is how it is. So that's great. Now that we have this, let's get the balance of the donor. Okay, before we start performing the transaction, to get the balance of the donor. So donor before, and then we say await this provider. This is how you get the balance of a specific account or wallet address on the Solana blockchain. Say the provider dot connection dot get balance. Okay, this function. Then you now pass this donor or whomever donor dot the public key, and this will give you the balance of of the donor's account. And then you also want to do the same for the campaign. Okay, campaign, that we also store money in campaign. Every donation that goes into a campaign, it's stored in the campaign's balance. Okay, so this place you want to pass in the campaign PDA, so which is like the address of the campaign. Okay, so this will give you the information about them. Now we can perform the donation. So we say donate, and when you're donating, these are the things that are required. It required a CID, so I'm going to pass a CID here. So say CID. It also requires an amount. So amount which I am intending to donate. So let's come here and say const donation underscore amount is equal to the new anchor.bn, and then I'll say math.round. I want to send 10.5 Solana tokens, so I'll make sure that I multiply it with this number. So I'm going to copy this number here, the way it is described that way. So multiply it by 1 Solana token. Okay, so that will make it 10.5 Solana token. So, and then I'll pass this as the donation amount. Okay, so this account partials, what do we need? So we need a campaign. So we say campaign, and you want to pass in the campaign PDA. Okay, it needs a transaction, so you want to pass in the transaction PDA. It needs a donor, so we say donor, and you want to pass in the donor dot public key. And lastly, it needs a system program, and that one you can easily just copy the same thing that we've done here. So copy this line and put it there. All of these things needs to be represented, otherwise it will flag in some errors. So we don't need this line. And now we want to get the balance again after the transaction has been confirmed. So we say donor after campaign after. So that's great. There's a couple of things we need to do now is to represent these things in a way that we can understand it. So we want to log it out. Okay, say log donation. So we say donation and then put a comma here and say, or we can just call it transaction or donation to be more precise. Okay, so come here and say this TX. Not yet. So we need to grab something different. Want to grab the transaction. Say const transaction is equal to await, and what are we waiting for? Want to say this program dot account dot transaction dot fetch, and we'll be fetching up transaction PDA. So we just want to dump it that transaction there so that we can observe the content of it. We'll log off the balance here, say log, and say, let's just say this. Okay, so this is a donation before, or donor balance before. I'm going to say donor, copy this, donor balance after. So we can, okay, so that is great, so that you can see the differences that has happened. And you also have campaign balance before and after. Campaign balance. So we see campaign balance before and after, so that you can also observe the differences. So let's check it out. A caveat is that this may fail. It may fail because this has already been deleted, because if we look here, we say that if the campaign is not active, then it should say inactive campaign. So but let's check it out and see, and then we can make any adjustment that needs to be done there so that we can test our stuff in peace. So you can see it's saying that inactive campaign because it's been deleted. Okay, campaign is inactive. Okay, so how about we cut out these ones and bring it here. We want to donate first before we even try and delete. How about we do that? If it doesn't work, let's check it out too. Okay, so before we delete a campaign, we want to make sure that we have donated to it, so that we prevent or help us escape from the need to make any more adjustments here. So let's look at this, what happened here. First of all, we're dealing with donation. So this is a donation. Okay, so this is the transaction at the campaign that we're working on, and this is the transaction for creating, for making the donation. And this is the donation we did, and it's on the 6th campaign that we're donating. Just like you can see that this campaign ID is 6th, so we're donating this amount to it. You can't read it because it's in a big number format. So, and it's credited, that means it's a donation and not a withdrawal. And this was the balance of the donor before before about 20. How many was the amount that was donated? Around 10.5 10.5 Solana token was donated. So when 10.5 Solana token is removed, I think this is what we now had, something smaller. So, but definitely there was some changes to it. Okay, so some deduction happened here, and this is what we get. You can see that this here is a little bit smaller. This is smaller than this. Okay, so, and you can see the campaign balance. This was the campaign balance before and after the transaction. You can see the campaign balance that has increased by 10.5 10.5 Solana tokens. Okay, this is good. And if you check this transaction, copy this transaction record and come to Firefox here, our Solana Explorer, and check out the details of that transaction. You can see that 10.5 Solana token was sent to this program derived address, the campaign derived campaign program PD, program derived address. Okay, so this is a specific campaign that we donated to. Okay, so, and you can see the balance of that campaign has increased by 10.5, just exactly as it is here. You can see that 10.5 here as well. So this is what you should take note of, when we're dealing with Solana in this way. And you can see the instruction that is a donate instruction. This is cool. And at this point, we have to now perform the withdrawal operation, to test it out and see that it is working as well. So I'll see you in the next part of this video. Okay, to withdraw, we're going to do something similar to donation. Okay, so what I'm going to do, we duplicate this, because after donation then is the best time for us to be withdrawing. So withdraw from campaign. Okay, and we're going to call this the creator, because the creator is the one that's supposed to perform the withdrawal. So the creator, and what are the accounts that are needed? The derived accounts. We need a campaign, we need a transaction, we need a state, we need a platform address, we need a withdrawer. A withdrawer is basically a creator, you understand that, and we also need system program. So let's get those things together. First thing I want to do is, this is a campaign, it's already here. Transaction, we have a little bit of an issue. Let's make sure that the seed here is withdraw, and this donor is not going to be donor, okay, it's going to be creator. Okay, so the withdrawer here is basically the creator. So what I can do here is to come here and make some modification. All right, so that, yeah, I'll say creator. If I say so, now it's also going to be affected here, so I'm going to say creator as well. But all these changes will not take any effect until I redeploy. So for now, let's keep it that way. So then this donor, okay, this donor count is not going to be needed because it's withdrawal count that we are looking after. So I will still come back to this place that we created, and let's do another one, call it withdraw underscore count, and is any. Okay, so I'm gonna come back here and say withdraw count in this create. Okay, I'll come here, duplicate that withdraw count, call it withdrawals. All right, so that can give us information about how many number of withdrawals that have been made on a specific campaign. Okay, then here would not be withdrawal count. Okay, that will succeed, that will make this to succeed. And then I want to change all this a little bit. So I want to say, instead of donor, say creator balance, before, and this is the campaign balance. And in this place, we're going to call it, okay, so I'm going to change this to withdraw. And in withdrawing, what I want to withdraw is I want to withdraw just around 1.5 Solana tokens, or we can call it 3.5 Solana tokens. That is all I'm withdrawing. And this account partials transaction is there. This creator or withdraw, for now it could be called withdraw, but when we redeploy this, then it's going to be called the I think we should just do that. Okay, so I'm just going to say anchor build, say anchor deploy, update has happened. And so this should not be called creator, you understand that, and no longer withdraw. So it will be the creator dot public key. And so let's come back here again and say creator after. So you get the creator, the transaction as well, and this one is going to be called withdrawal. Okay, and this is the donor balance, but this is going to be called creator balance before, and everything remains the same. Okay, so here is not yet complete, because if we look here, we have campaign represented here, we have transaction represented here, we have creator represented here, we have system program represented here. We don't have platform address, and we don't have program state, so we need to also represent those there. So how we can do that, I'm going to grab my program state here and make sure that is represented. So I'll come here and represent it. Say program state All right, and one more, I need this platform address to be represented as well. So to get the platform address, this is what I'll recommend you to do. So before we come here, okay, at this point I want you to do const grab the program state is equal to, and then you call on this await program dot account dot program state dot fetch. Okay, and then you pass that program state PDA. When you fetch that, you want to get the platform's balance. Okay, so we can do something similar to this here. So say platform, if it's really important, platform balance. Okay, it's important because we want to also see the balance of the platform, which can be different from whomever is the creator, but in this case the platform and the creator is the same person. So I would say get the balance of the platform or program state PDA. No, not program state PDA. No, dot address. Now I'm getting this thing wrong here. Program state, get program state dot this address here. So this address will grabbing it. Okay, so platform before, and we're gonna also need the platform after. Say after. Okay, so let's add let's go about logging of all those information. So we see we have the creator balance, say platform balance before and after. So this is before and this is after. So we have all those information represented. So let's test it out and see how it goes. Run this test. So the withdrawal is failing here. Say platform address is not provided. That means I've not added that. It's very important that I add that as part of this account system here. I forgot that here. I'm supposed to add it. So I will come back here and say platform address is going to be this program state dot platform address. Okay, let's save that and run that again to see. Okay, that is amazing. So this is withdrawal. So when you withdraw, this is a transaction that is provided. So now this is amount that was withdrawn. You see that is a false credit. So that means it's a withdrawal, is a debit. And this is the creator's balance before. This is the platform's balance. The platform balance and the creator's account, in this particular case, they are the same, but the creator could be anybody. Okay, so it's just that I haven't actually looked at a different way of, how should I say it, a different way of setting up a different account that is, that I can use for testing this purpose. But it's okay when we are putting it on the browser interface, you're going to see all these things fully. So this account and this account, they are the same. That's why the balances are showing exactly the same thing. But when it's being used on the web, the creator balance is always going to be different from the platform's balance, except the platform owner actually is also creating a campaign. And you can see the campaign balance. This is the campaign balance before, and this is it after. There is definitely going to be a reduction. So there's a reduction. It moves from 10.5 to 7.7, which is because I withdraw about 3.5, and if you subtract 3.5 from 10.5, that will be 7. Okay, that is why you're having this here. So let's check it out and see how the money moved, the movement of the cash. So I'll come here now. So this is the movement of the cash. Okay, if you understand, let's come here. This is the total amount of money that was sent to this account. Now there's a little thing that we may be missing, because we are using the creator's account and the platform account as the same. Because those two accounts are the same, that's why this money is sent to just about the same place. Otherwise, the withdrawal would involve one account for the creator and one account for the the platform, cashing out in all those different places. Okay, to go around this, okay, I will have to create something to go around this to make sure that we have a different user that we can call the creator, and then we use that to test our application much better. Let's create a user too, okay? And it's going to be a little bit different, so I'm going to create it. How do we create it? Write another script. We'll call this gen user.ts. Okay, I'll generate user.ts. So I'm going to, of course, I'll have to import fs from fs, and I'll say const user. This user, generate user, is equal to key pair. Now this key pair is coming from Solana Web. Okay, so Web3. I'm going to grab it there, and I will say dot generate. So for you to generate a new key pair for me, and I will say that key pair data, okay, is equal to JSON dot stringify, okay, and say array dot from this user dot secret. So they keep your data, and then I'll have to save it to if I say fs dot write file sync, and then we'll call it user dot JSON, and that will be this key pair. Okay, and we can just log off some things on the console. For example, we want to log off the key pair generated and saved as user.json. Okay, so I also say the public key, and then say user dot public key dot to base, okay, 58. So I'm going to save that, and let's test it out. To test this out, you have to do npx, still on this anchor place here, npx es run, okay, say script, and then you want to say this gen user, and then let's look at that so you can see that a new key pair has been generated for us, and you can see the data here. Okay, so this is where it should be, but I don't think it's best for it to be here, so I want to put it in the same location as the script. Yeah, let's remove that, and let's say, let's leave it there. Let's generate a new one. Okay, so we have that. So now that this is generated, okay, this is the account, the secret key that has been generated. If we check on the Solana blockchain, this doesn't really have any value. Like, it doesn't have, check it out again. Okay, it doesn't have any it doesn't yet exist. Why it says that it doesn't exist? Because it doesn't have any space reserved for it, doesn't have any amount reserved for it. So we want to put some money inside. Okay, when we put some money inside, then it will then exist. So we say Solana transfer to this particular account, and how much you want. We want 200 Solana token transferred to that account. I want to say allow -- allow. Okay, you can say -- help. Let's see. So when you do -- help, you see this flag called allow unfunded recipient. So we'll come back here, do this, and say allow on this thing. You can see that this transaction has been verified, have been added. So let's check out the chain again. Come back here, you can see that it now exists, and it has about 200 tokens, Solana tokens that is available. Now we can use this guy as the second user in this our case. So we'll come back to this test. Okay, so we're going to use that user too as the creator for creating a donation, managing donations. Managing campaigns. We're going to use that to manage a campaign. After you've generated a user and funded the user balance, you now have something to do. Now, at this point, we want to create a custom provider that utilizes this newly generated account, so that whenever we want to create a campaign or manage a campaign, we'll use that particular account. So I'm going to, write that function above here. Say const get custom provider. All right, and then we say this custom provider, and we will say we need to grab, just like we did here before. Okay, this keep here data, we need to grab it from the location where it was stored. So I'm going to say this location is user.json, and you need to make sure that you also import fs from, you see this fs file system module, and then with that you can grab this particular user data, and once you grab it, keep here, and you need to do exactly what you did here before, which is get this as a wallet. It basically converts, you can say we convert this to its value as a wallet. So I will say this process is a little bit complicated, but I'm trying to get it to answer to us. So stay with me here. So get creator, let's call it get creator provider. All right, so we are here. What you want to do is to say const default provider is equal to anchor.anchor provider. Okay, and then you say .local. Okay, and you say want to return a new anchor provider, and you want to say the default provider connection. Let's look at this. How do we formulate it here? So we can just do something this way. Okay, let's use this format. So say provider, and we need to get connection, and we can use the default provider's connection to make sure that this thing is up and running. So I'm going to come back to what I was doing. So this is the connection, and you want to say new anchor dot wallet, and you set this this keep here. You set this wallet as the new user, and then you say you should have this default provider dot option, the options that it has. So this will return this. So okay, so at this point I want to do an if else statement. So let's call this user is either going to be deployer or creator. Okay, so we can come here and say if user is equivalent to creator, then this is what we are looking for. First of all, I want to make sure that we have let wallet call to any, and we can do this here. Else we want to get this idea that we got here. Now please make sure that if you've gotten to the stage where before I made all this modification, you will save. You don't really need to go all this way, but I'm just making some improvements on what I had already done. Okay, so this place here is the user one, is the deployer, and this is what the creator. Okay, so I'm going to be using this to toggle between the creator. I don't even need to toggle it. I could just say const provider and then say set. So we'll say anchor dot set provider, and you set it with the new provider. So we can just do something like this called toggle provider. Okay, toggle provider. So at this place we have everything exactly how it is already. So instead we can just say, let's say toggle provider, and let's specify the deployer. Okay, so we need to then return the provider as well. Okay, so when we return it, then we'll be able to use it here. So in this case, let us run this and see and test out everything if it is working, because I've done quite a lot of changes so far. So let's check it out. Okay, our test is working just fine. So let's do some manipulations here. So by default, I want it to be the creator and not the deployer. Creator, and then but I'm going to toggle, let's say call this let, but I'm going to toggle this when I'm going to be using it in a different place. So when I'm dealing with all this, everything that concerns creation of a campaign, update, delete and withdrawing from a campaign, I'm going to use that creator, the creator account. But whenever I want to do donation, I'm going to use the deployer's account, because I just have only 2 accounts and I want to manage that. And the updating of the fee, I want to use the deployer account. As of this time, even let's see, as I'm using this deployer creator account, if everything is working. So everything seems to be working except the updating, of course, which is expected because the update is not the creator's account. So let's change some few things. So we're going to say here that the provider is a different person, is going to be the deployer and not the creator this time. So that is one thing we want to do here. We want to do the same thing here. Okay, then we want to switch that here. Want to say is the creator. Okay, back here, and here we want to switch it back to the deployer. So I'm just making some modifications. So these are the deploy. This is the deployer, and for managing these, what's it called? For managing the campaign, it has to be the creator. So it has to be the creator that manages campaign. Withdrawing from campaign has to be the creator, not the deployer. Okay. Donation, it should be the deployer. Updating has to be the creator. Creating also have to be the creator. So I'm just making some few changes, to this. Okay, this is the deployer, and let's see how it goes. So everything worked out great. So this is fantastic. Now, one last thing we want to check is during the withdrawal process. So this is it being withdrawn. So you can see that during withdrawal, this is the creator's balance. You can see that this is the creator's balance, and this is the platform balance, okay, which is the deployer, and this is the campaign balance. You see that each one of their balance are different. So let's see what were the error that we noticed before. First of all, this thing here should reduce, because there has been some interactions that is happening underneath. So I'm going to come here, open this. Now you can see, look at how the money is distributed. So this is the creator account. You can see 95% of the money, which is 3.5 Solana token, is going to this address. And you can see this is the platform address. And you can see about 5% is going to this platform address. And this is basically what is remaining in the campaign address. So this is the campaign balance. This is the system program. Okay, this is where the money is withdrawn from. This is the campaign's balance. We can even end it all and kind of restart everything so that you can see it one more time, the procedures involved in the entire process. So step 1 is to make sure that your blockchain is running. Okay, so the blockchain is running. Step 2 is to make sure that you built your Anchor program. Make sure that you're in the Anchor folder. Step 3 is to deploy it, Anchor deploy. So Anchor deploy and is out. And then step 4 is to say script. Okay, is to initialize the program. You have to do that, okay? And this is very important. Step 5 is to make sure that you generate a new address for user 2, which is the creator address. So we say generate user. So we have this user now. So step 4 is to send some tokens to that user. Solana transfer, and then you set this amount. You say you want to send 200 tokens, and you want to say allow. I want to say help first so that you can see what you're doing. Sorry, this transfer is not correct. Transfer. So the help, and this is what the flag that you say allow unfunded recipient. So you want to send this to that address. So since that address now have some tokens, because if you say Solana balance of this, you see that it now has 200 Solana tokens. Now you can then perform the testing by saying Anchor test, skip validate, local validator, and skip deployment, and let's test it out now. Okay, you can see all the accounts are participating in the transaction. Okay, so in the next part of this video we'll be jumping straight into integration. Okay, so first thing you want to do whenever you're starting this integration angle, because that's where we're going into now, you want to make sure that the wallet connection is functional. So what does that mean? It means that when you come here, make sure the app is up and running. Say yarn dev. So let's refresh this. So this is what we mean currently. Okay, currently the button is just a dummy button, but this is not even the button we want to use. But we want to make sure that the wallet integration is up and running before we start integrating other aspects, because for you to interact with the blockchain you need that wallet connection up and running, otherwise you can't do anything with the blockchain. So I'm going to jump in here and come to this project, come to the SRC, the component, and among this component I'm going to create a new component called App Wallet Provider. Now I've done this before. If you've watched my previous tutorial, you will see where I did this before. So this is exactly the same thing. App Wallet Provider. All right, so what I'm just going to do, I'll make this a lot more quicker. Okay, so I'll come here. This is what we are doing. So making sure we're exporting this App Wallet Provider, and the App Wallet Provider is going to need the following and a closing function here. So I think I've just installed Copilot and it's already providing me with some auto suggestions. I thought I disabled it for a moment, but I guess I have to restart my computer because I don't want for Copilot to be interfering with what we're doing. So I'm going to restart my computer, my ID. So restart. Okay, it's disabled now. Great. All right, so here I would say this place will be children. Okay, and the children is going to be of a type of React React node. All right, so I'm getting those, and what we want to achieve here, we want to establish a wallet connection, and the provider for this wallet connection is the Solana wallet adapter. Okay, it's default to the Solana ecosystem, and you can use it to customize as much as you want. And to customize it, it relies on a styling. Please, this is a styling. It's coming from this Solana wallet adapter, and if you're wondering where all these packages are coming from, they're coming from here. I'm going to separate this. You see the Solana wallet, all these packages, they are all part of the same thing, the wallet adapter, both the React UI, the wallet, the base, and all of that. We're going to be making use of it. So like this one is coming from this particular wallet here, package here. That is the style that we'll use for the entire website, okay, for the entire application. So the first thing you want to do is to make sure you grab your network. So the network is going to be coming from this thing called wallet adapter network. Now this thing is not automatically suggesting where this should come from, but we now have to be importing it ourselves.
So for example, this is supposed to come from React, wallet adapter base, the base, which is this package here. This is where it's supposed to come from. So we have to import it manually. So we say import, and then we say from that Solana wallet adapter base. You want to import wallet adapter, or not just adapter, wallet adapter network. This is what you want to import. So you have that there, and once you get that, you can have access to whatever network that you're looking for. In this case, we're just going to put it as devnet, but you can, it doesn't really matter how much, it's just to create a connection. And then you also have endpoint. Why I'm saying that, you can see that this same setting, I use it for my localhost connection. I also use it for devnet, and I'm sure it will also work on mainnet as well, so long as you're connecting to the right network. So for this endpoint, I'm repeating myself in this. If you had watched the previous tutorial, you wouldn't need to go through this step, but I'm only going to do this for this step. Maybe in previous one, I would just copy and paste this without having to go through all this process. I'm just doing this for learning purposes only. Then you come here, use memo, because you want to memorize this. You don't want this to be consuming too much memory or computing resources, recalibrating or recalculating or doing the same thing over and over again. So the endpoint that you're looking for is basically based on a cluster network, okay? And clusters are coming from Solana Web3. So you can say cluster API URL. It's coming from Solana Web3, and I just imported that. And once this is here, I can supply the cluster that I want, which is this network here that I just added. And it also will require a dependency in the dependency array here, which is this network. For if the network changes, then the endpoint should be recalculated. That's just it. After this, you want to grab series of wallet adapters. Okay, so it's a wallet is equal to, also going to be using memo as well. Okay, here it's going to just execute some arrays, just going to add some things to an array, and if the network changes, so it should also perform these operations. So one of the things we want to add, the wallet wants this application to work with, is the Phantom wallet. Okay, now it's not providing me with that information, so I will have to manually import it from this library called Solana wallet adapter wallet. Okay, so I'm gonna come here, import from Solana wallet adapter wallet. Make sure I import Phantom wallet adapter, and I also want to import this one called Soulflare. Okay, so these two are going to be useful here, so I'm going to add this. All right, I'm also going to add this one here. All right, so I have wallets now. After this, then I can simply return what React would expect, a React element. So this element is going to be based on, say, connection provider. This connection provider is not yet coming forth, but it's coming from React. This Solana Web3 React here, this one, that is where it's coming from, so I have to import it. So I'll say import from this and say connection provider. So I can copy this, make it available here. So for this connection provider, one of the things that is going to take in is the endpoint. Okay, and this endpoint, we just pass in the endpoint above there, which is this, and it's going to of course require children. So one of the children I will add in is called wallet provider. So we'll see here wallet provider. Okay, it's coming from that same location, which is slash React wallet. So now for this one, it's going to require 2 props. So we'll say first prop is going to be wallet. Then I have to add this wallet that I just included here, and also want to put this auto connection prop so that our application will automatically be connecting without, once we're connected, without having to be clicking that connect button every single time. Okay, so and lastly, we want this thing called wallet modal. Now this one is not giving me the vibe, the suggestions that I'm looking for. So what I'm going to do is to manually import it. So I'll say import, and say it's going to be coming from this UI, React UI. Okay, so I'm going to say from here, say wallet modal provider, exactly. And once we get that, we can then use it here. Okay, and of course what is going to require is the children, and that is it. We are done. But one more thing, since we're working with Next.js, you want to make sure that you always have this thing called use client when you're dealing with a React component such as this. So we have this, we can then hook this up to our our layout. Okay, our layout is found here, which is, this is the main layout here that encircles the entire thing on our website, which is this. So this layout here, we want to wrap this entire application inside of that provider, that this app wallet provider that we just created. So I want to say app wallet provider is coming from that component. Okay, and I want you to move all of these inside there, and that is great. So you save that, and let's check our browser. Everything looked all right, and there's no issue here. So let's work on this modal now. That place, once we work on that, our ability to connect will be up and running. Okay, so you have to come to, I can close out from here now. Say come to header components. Okay, this is how it currently looks like. Alright, so let's modify it a little bit. The first thing I want to do in modifying this, we're not gonna modify everything though. So I'm just gonna modify the wallet button. There is a button called this connect wallet button. Okay, we can use this one like this. This doesn't have any functionality. The React, this package called React UI, has all the information that we need. So we'll say import this package from Solana, this one here called React UI. It has a certain element called wallet multi button. Multi button. Okay, this wallet multi button is what we're going to be using to replace this, because we're not going to be using this. So we come here and paste this here, and we can save that and see on the browser. See how it looks now. Great. We can add some colors to it, but I'm not always sure that it obeys this color right here. So you can see this, save that. You can see that it gave us the green color format that we're looking for. So just add this style background color, this the color of the text is white, and there you go. You want to also do the same thing here. This thing has a mobile view and a desktop view. So we've done for the desktop view. You can copy exactly the same thing for the mobile view here, and you save that, and this will be, this will work out both for mobile and desktop. If I click here, you can see that as well. So that is what you want to take note of. So with this point, we've been able to connect this, or let's click on connect first. Connect. Oh, it's leading us to another place. Oh, it's saying that it doesn't know this, so let's unlock this. I don't know why it's not recognizing. Let's refresh that. Oh, disconnect. Now let's refresh again. Click select. You see that it's working. Maybe I needed to just refresh that. Okay, so wallet is connecting, and this auto connect ability is working because it's not, whenever I refresh this, if it was previously connected, it gets reconnected, and that is absolutely amazing. Now in the next part of this video, we should be able to go and start creating new campaign. We'll create new campaign, and then we'll be able to list those campaigns. So I'll see you in the next part of this video. So in order for us to create a new campaign, we can just go to this page. Now this page has all the various things that we need. Okay, so I'm going to open here because I want to test out some. Come to this Docker right now. Check out the console. I want to drop some things and see if it is. This has to be a URL. So let me copy this URL here. Okay, so this is what is currently happening here. It's just logging off all the information for us on the console, which is great. Okay, so when we come to if you want to see where the create page is, make sure you come to this app. You see this create right here. This is what I'm talking about. So in this page, you can see what is going on. We're just logging off these values that we're extracting from these forms. Okay, so that is all we're doing. Here is an input that is ensuring, is it like a text, but we're using a regular expression and unchanged function to enforce numbers only. So this is a little trick that we're using to make sure that we are formatting, the numbers very well. Okay, and these are just various form inputs, okay, or form fields. All right, so we want to do something extra, which is want to add that toast notification to read that toast notification. So to add a toast notification, we're using Toastify. So if you are not conversant with it, Toastify helps us to present various notification things, which look at the React Toastify, which can also include progress bar or progress notification that comprises how the progress of a certain process is happening, and that is the one that we're most interested in, because we want our experience, the user experience for our blockchain consumers to be smooth, because you don't want them to be waiting and don't understand what is going on, because blockchain is a little bit slow because of validation reasons and all that. So you want to make sure that they are aware that the process is up and running. And how you do that is we'll call on this await. Before we can use await, we want to make sure that this is an asynchronous function. So we use async there, and you say await this toast is imported from React Toastify, and call on this method called promise. It has a promise method, and in this promise method, it takes in two information. One is a promise, the other is an object that has three conditions, three state, which could be a pending state, a success state, and an error state. Now, for this promise that is expecting, you can say new promise. Okay. Now in this new promise, you want to typecast it that it should return void, and it has to be asynchronous as well. So it will contain a resolve and a reject. Okay, I'm only going to do this once because in subsequent times we just copy and paste. So this is a promise right here that I'm defining. Now this new promise, I'm going to write the following things inside, which is just log off the form. No, you can just log off the form. Okay, and say resolve. That's just it. So this time around, when I come here and I click on this, it doesn't seem to be doing anything. I need to put it around the try catch, I guess. So I'm going to say here try catch. So this is what it's trying, and this is what it's catching. So catch, you should reject. You should reject with this error. Okay, so let's try that again. This is supposed to wait for some certain minute or so. Okay, it doesn't seem to be working exactly how we're expecting it right now, but that's no issue. So what I'll try and do is I'll try and resolve this after 3 seconds. So I'm doing this set timeout and resolving it after it's 3 seconds. So I can put this inside here as well. So let's save that again and let's try it. Okay, it doesn't seem to be working. Okay, you can see that approval notification, and after 3 seconds it's dumping. So this is what we wanted. That's why we're surrounding it with those notification sequence. Now this thing is not really useful to us because we're going to work on it soon. So there are some things that are required for me to make a transaction. You understand that? A transaction that involves the invocation of my wallet provider. Without those things, nothing is going to work out here. So I'm going to work on it right now. So I'm going to need these things coming from the wallet provider. So that will include, say, const. We're going to destructure this at the end of the day. It's coming from this use wallet. Now this use wallet is coming from React, Solana wallet adapter for React. I'm going to need my own public key. So this public key here, I'm going to need to be able to send that transaction, and I'm also going to need to be able to sign that transaction. So these are the things that I'm needing to perform a transaction on this in this application. Now I will need to pass this information to the provider. Remember, we have this thing about wallet a provider. If we come back to this fundus here, you find out one of the things that we did was to create a provider, and the provider literally just have a connection. It has the wallet that you intend to use and a commitment level. Okay, so those are the things that are required to create a provider. So but I'm going to create a provider, but mine is going to be a little bit different from what you just saw, because I'm in the test environment. I'm not working with any wallet. I'm only working with accounts that are generated on localhost. So it's a little bit different here. So I'm going to come here. I'll create an entire service that will be responsible for helping me manage all these connection, and that service is going to be called blockchain service. I like putting everything that are related in one file so that I will not be confusing people, because you don't want to scatter all the codes that belong to a certain class of operation all throughout your application, then it will make it difficult for maintenance, and you don't want to add to the complexity of blockchain development. So I'm going to come here and create a new file, call it services / blockchain, come on, blockchain.ts, or we can also say tsx. Okay, so inside here, that is where I'll do all of these blockchain operations. Now the process is a lot, but once you get the hang of it, understand pattern recognition. These patterns that I'm using is not often changing, so when you're writing your own project, you just need to make minor adjustments. I could have just easily copied what I've done previously in the class before, but I'm not going to do that. I'm going to write that from scratch this time, but in subsequent one, I'm just going to copy those things and don't need to explain too much, because by then you should have gotten a lot of understanding on how this thing works. Okay, so the first thing I want to do is I want to create I want to say let tx is going to be any, and I'm going to be using it to store my transaction records. So I'm going to be processing a lot of transactions, and each time that transaction is completed, I want to store it there so that without having to recreate that over and over again. And I want to get the RPC URL for, okay, this one is going to take a little bit of, it's going to be a little bit different from the way I did it before. So I'm going to come here. For now, let's come back to that. Let's say init this here. So here are clusters. I want to do something similar here. I would say I want to create a function. Should I create a function? So let's do it this way. So these are clusters, okay, and the RPC URL, which should be a string. I think I should define this as its own function. I would say const get cluster, okay, URL, and say it will take a cluster, which is a string, and return a string as well, and then we can ship this whole thing inside here, okay, and then we do return this cluster URLs here and pass the cluster that we are targeting. So now at this point, I would say cluster, and say cluster is going to be process dot environment dot Next.js. I think we have something similar like that. Next underscore public, but in this public it's going to be called cluster, public cluster. If it doesn't exist, it should just return local host. Okay, so with this, the cluster URL now const RPC underscore URL, and you want to say this RPC URL is going to be called from this, is going to be coming from this get cluster URL now, and I'm going to pass this cluster in here. So the block scope is an issue, so what will happen is I'm going to move this thing downward here. Okay, so this should be able to get me whatever host that I'm looking for. Okay, so I have the RPC URL, which also specify that is a string. Okay, now that I have that, in fact, I want to specify this using the number format, and this is just a letter format. There is no difference between it, but I just like keeping it this way. Okay, so I will come here. I want to get provider, because the provider is what enables you to speak to the blockchain. The provider captures all the information that is required to make a communication with the blockchain. So we say export const. The reason why I'm adding this export is so that it can be utilized in other files and other components all across my application. So I'll say get provider. Okay, and say, no, it's not here yet. Say, okay, so this provider, I will request some information. All this information I'm requiring that it should have, they are all coming from this page here. So I'm going to separate them. So I want to require that it has this, it has this, and it has that. So I'm passing all those information here. So I will come here, copy this, and paste it here, and basically break it down into multiple lines. Okay, so because these are the information that is required to speak with the wallet, and now you need to define what this is. Okay, TypeScript, you have to do that. So this is a public key. Now this public key is coming from Solana Web3, of course. Okay, so but it can also be null. No, it should not be null. So let's keep it this way. So this can be any, okay, because we don't know what it is made of. We don't know if it is made of titanium steel. Funny. All right, so once we get that together, it should return a certain data type that we're looking at for. So it should return a program. Now this program is coming from this library called Coral XYZ Anchor. So this is a program that is returning. Now this program that is returning is not just any kind of program. It has to be typecasted with the type of program that our application generated. So I'm going to say import, from, I would say dApp, no, and go to this anchor folder, go to the target, come to the types, come to fundus. So fundus is the program that I'm looking for, and I want to typecast it here. So this is fundus. This is what we're expecting, okay, for it to return. We also expect that it could return null. It could return null. I guess this is why we can say that this can also be nullable. So at this point, you want to first of all check if this public key and this signed transaction, this signed transaction, they both have values, because those ones are very much important. So I'll say if there is no public key, or if there is no signed transaction, then it should return this error. So we say return null, okay, but it should say console log, come on, okay, for login error, the error is going to say wallet not connected or missing signed transaction. So that is the error. But if this was all good, then you want to grab the connection. Say const connection is equal to a new connection. This new connection is coming from Solana Web3, and you pass in this RPC URL. All right, and you say const, you get a provider. This is how we form our provider now. provider. So it's going to be equal to new anchor provider here. Okay, so now what are going to be made up of this anchor provider? Let me give you a clue. If you come back to, let's say, this one here, you will find out this is how we formulate the provider. We had provider had a new anchor provider had a connection. So I'm going to add connection here. Connection, that is first key. An anchor program provider does have a wallet. So this is where it's a little bit tricky, but I'm going to add this wallet here. This public key, you see that this object, the signed transaction that we're using, okay, and the send transaction, which is this one here, the send transaction, okay, and then we need to make sure that we typecast it as wallet. Wallet is coming from this Cora XYZ as well, and then you want to again typecast it as you want to first do that as unknown and then as wallet. So that is important. And then you want the commitment level, just like we have here. Okay, we say commitment to be processed. Okay, so processed, and at the end of the day you want to return a new program. Okay, new program, and this new program is going to have an idea. This idea is not yet available, but this and also going to have a provider. So let's get this idea. This idea is coming from a place similar to this. So I'm going to say idea. See that this one is gone here. So I'm going to say it's coming from not types. It's coming from idea, and this one here. So you see that it's giving an error. Okay, so I'm going to say as any. Okay, but it has to return exactly this type here. Okay, so I'm going to say here fundus. Okay, so I understand why this thing is having this error is because I'm getting this wrongly. So this is supposed to be this way. No, not like that. This way. Okay, so it's either returning a program that is fundus or null. So that's what is happening, and it returned null here, and it also returned the program fundus here as well. So there we go. Those are the two ones we need. Again, there is one other provider that I want us to create. This one is going to be called read-only provider. Okay, it's not going to take any parameters. So I'm going to do this right here. So we have read-only provider. It should return. Let's do this. So call it read-only. Okay, so we want it to return this fundus. Period. So no negotiation. Just that it can be another alternative. So I would say here, how do you get this one together? Okay, this one has to use a dummy wallet address, because it's not, if it is read-only, it doesn't hurt anyone to use a dummy wallet address. So that's why we're doing this. Say const dummy, let's just call it wallet. Okay, wallet. We don't need to call it dummy wallet. Let's don't insult it. Okay, so for this wallet, we're gonna need a public key. Okay, come on, public key, which is going to be, we'll call on this public key, public dot, there's a default one, so I'll say dot default. Okay, so that will be the public key, just like we had here, right? So that's public key, and you want this thing called sign transaction, and This is going to be an asynchronous function, and we're just going to say that you should throw error, new error, and the new error should say read-only provider cannot sign transaction. Okay, so I'm going to do this similar for sign all transaction, and we'll just give the same error as well. So this forms our wallet. Okay, that simply like that forms our wallet. Now we can use this wallet to create our provider. We'll say const provider is equal to that new anchor provider, and we're passing that connection that we've always had, connection. Okay, so but this connection we haven't yet worked on it, so I will whenever you create a connection, I want to say confirmed. So we'll copy this. I missed that part, so I'm going to bring it up here. So this is the connection. So I'm going to pass in this connection here, and I'm also going to pass in the second parameter for this. I'm also going to pass in the second parameter for this connection, which is processed. Oh, I'm missing something, sorry. So it's going to take the connection, okay, and the next thing it's going to take is the wallet, okay, which is something similar to this. So we'll have that wallet right here, and this should be as wallet. Okay, you can see as unknown. Okay, and then lastly it needs that wallet. Okay, so let me first make sure that I break this into multiple lines. Okay, so that this would be good looking. All right, so the next thing that is remaining there is this commitment level basically. So I'm going to do that. So we have a provider, and with that provider we'll return exactly the same thing here. Boom. And now we have two provider. One gets, one is for read write operations, and the other is for read only operations. Okay, so you should know the difference. If I want to read something only from the blockchain, this will help me in case I want to read something from the blockchain and it doesn't necessarily require that I write to the blockchain, then this will be it. And for reasons, and it's very useful when I want to display something without needing people to connect wallet first. Okay, that is very important, because you're going to be dealing with people that just visit your website. Not everybody wants to connect immediately, so they should be able to retrieve the resources that is coming from the blockchain, and that is where this read-only operation comes in. But if you want to actually put something on the blockchain, you're going to have to use this one here. Now, let's write the function that is responsible for creating new campaign for us, because that is what we want to do in the first place. So you come here and say export const create campaign. Now you see async, function in that. So what does this return? This returns a promise. Okay, a promise, but the promise is going to be based on this transaction. It's just going to be a transaction signature that is also coming from Web3, a Solana Web3 as well. So let's break it down here. All right, so here we go. What we need to create to be able to create a program. And let's look at that funders test here. If you come here, you find out that you need a program. A program, we already have a provider, so we need a program. We need a creator with the wallet address that is responsible for creating this. Okay, we need those two, and then we need these titles, this input. Okay, so let's get that together. So I'm going to say we need program, and this program is going to be a type of program and fund us. Okay, I'm also going to need public key. Public key is going to be a type of public key. I'm going to need a title, which is a string. I'm going to need a description, an image URL, and a goal. So we'll say description, image URL, and a goal. This goal, we want it to be a number. Okay, so those are the things that I'm going to need to create a campaign. Now that I have all those information, I can proceed to creating a campaign. So the first thing, remember, to create a campaign, you need this program state PDA. Okay, so I'm going to copy it literally and bring it here. Okay, and because I have a program here, so I can access the program ID, and because I have this public key imported here, I could call on this find program address sync and grab the PD of it. So I have that one figured out. So the next thing I want to do is to grab this state and store it in CID here. So we can do something similar to this. Now I have to come here. I just need to create this. I don't need to store it anywhere different. So we have this. So we're grabbing, if you look here, if we come here again, let me do that, dot account dot program state dot fetch, and what you're fetching is this program state PDA. Okay, so it's the same thing literally. So I need to import this BN. Okay, so it's coming from this Coral XYZ. Got it right here. Great. So we're going to use that to add one to this campaign ID. Once we get that figured out, then we can actually now have this campaign PDA. Exactly the same thing. We don't need to change anything here. And once we get that, the title, description, and goal, all that are already available. So so I will say I'll copy this line and come here and say this goal, call it go BN. Okay, it's gonna be this, whatever the goal was multiplied by this Solana standard. Okay, so this is what it is now. Then I can call on this function, this entire thing. Okay, I'm not going to use this because this TX is already created here, so I'm going to use this one here instead of creating a new one. Now it's complaining because of this goal, so I have to use this goal BN right here. All right, and this is very cool. And for this creator, I just need to pass that public key. I just need to pass that public key for this creator, which is this public key coming here. Okay, and for the system program, we're gonna have to import this one. So I'll say import from Solana Web3. So when I have system program also imported here, if I do this, you see all those information. Great. So these will get you creating that campaign. Remember, you want to make sure that the transaction is confirmed. Okay, so before you proceed, so I'm gonna create a connection here again. All right, I'm gonna create a connection, and for you to create a connection, we have this. So I'm gonna come here. Let me close this. Okay, so create a connection here. Const connection. The connection, the RP, the URL right now. Okay, the URL is gonna be. I'm gonna have a different way of getting the URL, but it's basically the same thing. But I just do it this way because it will be dynamic depending on the wallet that I'm connected, the cluster that I'm connected to. So I want to make sure that I'm getting the URL from this program dot provider dot the connection dot the RPC endpoint. You get that? So this is where I'm getting my my connection now, and from that place I want to await the confirmation or the finalization of that transaction. Say connection dot confirm transaction. Remember what I said, I haven't figured out, this is depreciated, I haven't figured out the new way of doing it. And then you pass in the transaction that you're trying to confirm the finalization state, which is this, and afterward you just return that transaction ID. That's just it. And with this you'll be able to create a campaign. So let's save that and come here now. I can close this for now, or just hide it for now. Okay, so let's make sure that you have the full view. So we're gonna manipulate this place now. This is where we're gonna be manipulating. So we want const tx, which is a transaction. I want to say await this create campaign services. It's coming from the blockchain service that we just did now. And then here you want to make sure that you supply all those information, like for example program. You want to supply program, but we don't yet have program here, but you can create program because of these provider that we've already done. So that we can't use read only here. We're only going to use the read write provider to get the program. The provider returns the program for us. So let's get it together here. We'll say const. We're going to use memo to grab this provider. So I'm going to call this program. Get the program. Program is going to be based on use memo to make sure that it's not consuming our computation power. All right. So and you call on this get provider. It's coming from the blockchain service, not read only, but this one. And what do you want to pass? You want to pass in this public key. Okay, see that you want to pass in that is it send transaction, and no, you want to pass in sign transaction, and you want to pass in send transaction. Okay, so those are the information that you're passing in there. And remember, a memo has a dependency array, and that dependency array will just be based on these same things. When I refresh that, format that, you see how it is. So this is my program now, and I'm going to pass this as one of the items here, and it cannot be null. Okay, that's what I'm specifying that. And now I have to pass in this title, description. So and to get that really clean and and straight, I have to destructure this form here. So to do that, const is equal to this form, and I want to grab the title, the description, the image URL, and the goal. So I've destructured it, so I'm just going to pass this information down here. Okay, and you want to make sure that this thing currently is a string. You want to make sure that is a number, so I'll convert it to a number. It's still complaining. It needs 6 arguments but got 5. Okay, also need a public key. All right, it needs a public key. It cannot be empty either. So if this one, it can be null, so we're putting that to ensure that before you can call this, we're making sure that you're connected. You understand that? So that is one of the things you can put as an if statement here. So you want to say if there is no public key, okay, you want to return a toast dot warning, say please connect wallet first. So that will make sure that this public key is always available. Okay, so with that, the transaction is created and I can resolve with that transaction as any. Okay, we can even, I think we can do it like this. Okay, we can resolve with that transaction. This transaction, you can also say transaction signature. So argument of type string is not assignable to, let's just keep it as any. Okay, yeah, that will make much sense. So, but that is not all. We want to reset this form. So once that is successful, we want to say set form. Set form should be an empty value. So we reset that. Want to also log out the transaction tx. So with that, these are all you need to be able to create a new transaction. So let's check it out on the browser. Okay, so I'm gonna refresh and let's create a new campaign. I think I like doing that with another wallet provision. So now I think I should use this opportunity to teach you how you can add a new wallet here. To add a new wallet, you can simply just click on this add, okay, and you create a new wallet address. Okay, that is how I created this one here, which is this wallet 2. All right, I'm going to copy that wallet 2 address. Okay, and disconnect, reconnect. You can see that is a wallet connected, but this wallet of course doesn't have any Solana token in it. Let's refresh. Okay, the blockchain is not live, so I have to make sure that the blockchain is up and running. So if I come here, so I'll say create another one, can say Solana test validator # reset. So we have Solana test validator. So now I want to send, I need to check out what I was doing before. So if I refresh this and I want to check this address, you can see that it doesn't even exist because it's not aware of it and it doesn't have any Solana token. So I can do Solana transfer. Remember, if I do Solana balance, you find out that I have over 500 as this local host. Okay, for local host purposes. All right, so if I say Solana transfer, to this wallet address, I want to transfer like 200 Solana token. Let's try that. You say recipient address is not funded, so I have to add this key, this flag here. So if I add that, it has sent a certain amount of money into that wallet. So at this point, if I refresh that, you can see that I have 200 Solana token. Otherwise, if you don't do this, then you're going to have an issue. Okay, you have an issue working with this, like that is you're going to have an issue interacting with it because it doesn't have any Solana token. And also, I think I should use this opportunity to show you how you can import. Remember, we generated a user JSON. This is a private key, before, so we can also import that into our wallet by going here, coming here, say add new, and you say import from secret private key. So we import this, call it dev3, and you put the private key. See that, and click import, and now we have that account. I copy this and also transfer a certain amount of Solana token to it. All right, so we can say 250, and we have those two wallet addresses, funded, and we can use them for our operations. Remember how you can generate new user is by executing this script, and you just use ESRun, nps ESRun, and then you specify the address or the location to the script and execute it. It will generate a fresh new, account for you. So those are the things that you just need to know. Now that I've done all that, I can proceed to creating a new wallet address. So I'm going to put the title here and the image URL, copy that address, paste here, and you want to see how many Solana tokens do you want to do with this. So I'll say 34.7. okay, and you just put the regular extra description here, which is just this. So I'll create it now. Oh, it's saying account does not exist or has no data. So now I need to disconnect first, okay, and reconnect. Remember, I actually changed an account, so I have to connect to that account. Now I have that account connected, so let's create it now. Oh, my bad. This is happening because I have not initialized this project. In fact, I've not initialized the program at all, and this is the reason why it's having all this issue. It has nothing to do with this wallet at all. So I have to come here. I have to initialize this work, and the program is not even deployed on the network either. So I completely missed out. I skipped this whole step. That is very bad. So I have to say anchor, say cd into anchor, and say anchor build. Okay, it's already built. Say anchor deploy. All right. So and then we say anchor. If it is deploy, I say now I will say npx ESRun, okay, script, and then initialize. So let's wait out for this to complete. So this is the reason why it has been misbehaving, because I completely missed out, skipped this whole process, and that is not a great thing to miss out at all. So this has been initialized now and confirmed on the blockchain. So let's try it again. Create. You can see that it's working now, and click confirm. Man, spent quite a lot of time trying to resolve that simple issue. Okay, so this is great, and it's created. I think we should create like a second one, maybe with a different user. So I'm going to disconnect. I will use that third user, connect back. Okay, let's use that third user to create another donation. Okay, this one is called storm damage. Okay, and I'll paste the URL here, and let's say 22.5, and just tell them little short stuff. Okay, so now let's create this with a different creator. Confirm. Okay, so that has been successful. Now what I want to do is I want to now connect with this main guy, because I will be using it to list out stuff on this. To make donations. So at this point, I would like to actually list out this component. Very important. I want to list out this component before we do other things. So in the next part of this video, we'll tackle that angle. Okay, so in order for us to have this thing listed here, we're going to have to modify our blockchain service a little bit. After the modification, then we can pull data from the blockchain, which is what we're looking for. Okay, let's get it done. This is going to be a little bit different from how we pulled data the last time. Last time we're working on the voters, program. This one has we can only show campaigns that are not deleted. So we need to make those modifications as well. Those considerations, sorry. So the first thing I want to do, I'm going to separate this, come here. I'm going to close, say here, and come here, close this. So let's create another function, call it export const, call this fetch active. And the reason why we're doing active, let's search for campaign. If you come to campaign state, we only want to fetch campaigns that active is true. Okay, that's why we're saying fetch active, campaign. Okay, and it's going to be a synchronous arrow function. Okay, so this is going to return an array of campaign. Okay, maybe I've not shown you this, but we do have interfaces. If you come to this place called utilities, okay, interfaces, you'll find that we have a campaign interface, and this campaign interface has all the properties that this campaign does have. Okay, it's just pretty much correspond to what this campaign has. The only difference is that an additional key is provided called public key. Now this public key is useful for knowing the PDA. Like this is basically the PDA of the campaign. It's not normally included in this because the way you get it here is by saying campaign.key. You understand that? But here we'll put it together in this place. So that's why we're getting this. So what we want to return from this function is a campaign array, a promise, of course, promise that is based on campaign import that array. Okay, so what about what you're going to put as parameters? You cannot, for every interaction we're going to have, we only need that program. We need that program before we can do anything. And now that we have that program, we need to fetch all the campaign. And you can fetch a single campaign this way, or you can fetch all campaigns. You can fetch all campaigns, say const campaigns is equal to this program here .account .campaign .all. All will get you all the campaign. Okay, and we can do some further filtering. So we say const active campaigns is going to be campaign .filter, and for every one of those campaign, I'm looking for the ones that campaign.account.active. Okay, if it is active, then it is qualified to be retrieved. Okay, so we're only getting the active campaigns. That's what we're getting here. And after this, we can return this campaign, active campaigns, but it doesn't satisfy the return policy that we had specified here. So we need to transform this into a format that, you see, this is BN. If I come here, let's look at this interface here, compare this to this interface, you find out that we have, these ones are number string, boolean, but we have big numbers, public key, string, big number, like that, boolean. So there's differences. You need to make them equal and the same. And that's where we need a function that will call, serialized campaigns. Const, okay, serialized campaigns. Okay, for this serialized campaigns, it's definitely going to accept a bulk of campaigns. It's gonna take in a lot of campaign, and it should be of any. We keep putting it any because we don't know the definite type. We don't know the definite type that we want to describe this, so we just keep it as any array. And what we expect to bring out is campaign array. Okay, and now we can immediately start doing it. We can do it this way, or we can do a return later. So let's say const modified. Okay, campaign modified is equal to this campaigns dot mapping through that campaign. So I'm going to return modified. Okay, so say modified is campaign array. So what we're doing, we're mapping through everything here, and for every campaign which is of type of any, we're going to immediately return that, and it's going to be, let's make sure that we first of all say dot account. Just like here, we need to access the account first, and then we need to add the public key. So we need to access the public key. Okay, which is going to be this C dot is something called public key, and then I need to convert it to base 58. Okay, so that is for that one. All right, so I also need this CID, which is going to be this C dot this account, of course, dot CID, and you want to convert it to number. Okay, so this is just what we're doing here, and we want to do for title. We're not touching the strings because the strings, the ones that are strings, okay, they actually turn out well, and the one that are boolean turns out well. We're only working on the numbers and the public key. So let's work on this public key called creator. So this one is going to be a public key, so I'm going to make sure that it's public key. So let's have the go. I'm going to say go. Let's have amount raised. Now in this place you can't use underscore, you have to use camel case. That is how it works here. Okay, so we need the timestamp. Also we need the number of donors. We need number of withdrawals. We need to modify the balance. And we need to modify, that's it. The rest, the rest is all good. Now you can just decide to return this way. This will be, like much sharper, faster, clean, without having to put multiple steps into it. So come here, copy this. This is what we're going to return now. We know that this is an array, so we're returning an array of these values. Now that we have this, we need to come to the page that is responsible for displaying the various campaigns, which is this home page here. And this is where we get the campaign. Right now we're getting it from a dummy campaign place, which is not what we're looking for, so we're going to have to modify that. So to modify that, we need to first make sure that we get the program, just like we did here. Let me bring it here. What we did here was to first get the program, but this is read-write program. We want to get the program from a read-only provider. So we say const program is equal to use memo. You have to always do that, and you want to get provider read-only. Okay. And what are you passing in here? You don't pass anything. The dependency array remains the same. So this is what it is, and we would need to change the way we do this. So we need to put it in a use state. So we'll say const campaigns. It's going to be coming and set campaigns. Okay, it's going to be use state. The type of campaign array, and then by default is an empty array. Okay, so at this point I will use state to pull this campaign, from the campaigns from the blockchain. So I will say use effect. Okay, inside of this use effect, I will come here and say I would then say, what we use in describing it is fetch active campaign. So I'll call on fetch active campaigns. All right, then I'll pass that program because that's the only thing I need, and I'll make sure that it's always present. And then say then the data, since it's a promise, okay, the data that is returned, I can say set campaigns with that data. Okay, so this is just what it is, and that should extract all the campaigns and display it here instead. So let's save that and check it out on the browser. So you can see that those are the two campaigns. Beautiful. This is absolutely amazing. You can see that whenever I hover here, it's directing me to the campaign, program derived address, which is also very cool in its own. So now this is great, but the thing is, when I click here, it's not gonna give me what I'm looking for because it doesn't have access to this information. So we need to make sure that we're retrieving we're able to retrieve a single campaign by specifying the program derived address. And how you do that is we have to come back to the blockchain service, and in the blockchain service, the way we fetched a specific campaign, that is how we're going to do it to capture exactly what we want. But we have to make it in a very pretty way, a way that it can be used. So it has to be usable. So I'll say fetch campaign details. Okay, that's the name of this function, and I think I should just duplicate this and change this name to fetch campaign details. You supply the program, and you also supply the PDA, which is a string. Okay, so at this point I'll come here and say this campaign, a single campaign, I'm expected to only return a campaign, not an array of campaign. All right, so this single campaign, I want to do .fetch, okay, and I want to fetch this PDA. Okay, so once I grab that, I can basically serialize it by doing the same thing that I did here. Okay, I'm gonna come here, or the same thing that I did here, this one here, this object, copy it, and say const serialized initialized, which is of a campaign detail, is now equal to this instead. So now we need to make sure that this C here, this C that you have in here is actually a campaign. Okay, and secondly, it doesn't have any account. Okay, so now about this public key, we just make sure that it's the same thing as the PDA that we just supplied. So this campaign dot CID does not exist, so let's check it out. Why is it complaining dot CID? Okay, I see why it's behaving like that. It's because we didn't put an await statement in front here. So yeah, so it has to be a promise, so you have to wait for the result to return and before we even proceed. Here we also need to make sure that we are waiting, and that's why it was misbehaving here as well. I didn't see that. Okay, so I have to make sure that that is well represented. Okay, so at this point we can then return this serialized, and that will fulfill the criteria of this function. Okay, so you save that. I could have used this function on it, but the fact that when you're retrieving a specific campaign, it doesn't come with this public key, so I have to modify that myself. That's the only difference there. So at this point I'm going to save this, and at this point I was grabbing a specific all the campaigns, but now let's grab a specific campaign. So come here, where is this campaign? This is a specific campaign here. Okay, so I want to grab that. I want this to come here and this can go here. So it has an error red symbol here. So this withdrawal, we'll come back to it for now. Let's comment them out. Okay, and I remove this. So just to make sure that everything is clean, here is complaining that I should put program. So make sure you put program there. Great. So in this place here, it's just filtering out. Okay, but this is what is most important at this point. So let's modify that to work out for us. So to modify it to work out, we'll still need to create that program. Remember here, we need to first make sure that we got the program. So this is the program. I need to make sure that I get use memo, and I get this one as well, all represented, and I have to fetch this data. Okay, come here and see this, install this, and here it's going to be a little bit different. So before this runs, we want to check if we have a CID, because if we don't have a CID, and if the CID changes as well, I want this to be run again. So if there is CID, I want to create a function called fetch details, because we are fetching details from the blockchain. So we have details here is equal to async, this function. Okay, want to call on this await fetch campaign details, and in fetching the campaign detail I have to pass the program and also pass the CID as a string. All right, so this will return the value const. We can call it data. Okay, and we can store it here in the campaign. We can just create a campaign use state here, or let them call it We don't want it to be an array, we just want it to be a single value. So it could be null or that. So it should be null by default. And make sure that you import that use state. This is campaigns as singular, and here I need to make sure that I comment that out and just say set campaign to be this data here. So at this point I can then execute this function, say fetch details, and that will retrieve the value from the blockchain. So let's check it out and see. Save. So let's visit this place. You can see that it's grabbing this information now from the blockchain. This is cool, although not everything yet is represented properly, and not everything is represented properly, so we need to make some good representation. To represent that, we need to come to these components, this component called campaign details. And in the campaign details, we want to modify some things here. So for example, if you look at this number is way too large, it's not how we're supposed to represent it. The representation has to come in, even though this is its representation in Lamport, it's not really in, so we need to convert it to its representation in Solana token and not in Lamport. And that means you have to divide it by this value. So for example, the goal has to be divided by this value, which will be the representation of 1 exponent 9. This is 1 Solana token. Okay, this is what it means by 1 Solana token. So we need to represent it that way, and you want to do the same for this, and then the balance you want to do the same, and then for timestamp you want to multiply it by 1000, because if you look here, even though we're not really showing the date that it was created, which is something that I feel like it should be added, a date created, then that is it. I think we can add it here. No, so let's do the same here. Amount raised, timestamp, multiply by 1000. Donors remain like that, balance. So if I save this now, let's check it out again. You can see this is the right representation. So this is cool. And what else? At this point, I think we can let's go to React icons. Okay, and let's look for calendar or date. So which one will be very useful to us? Look for, say, calendar, FA calendar. This one, I think this is okay. And then we can come to the campaign details here, and after we have these donation withdrawal created by, we need to modify that place a little bit. So I'm gonna move all this into a div. Okay, and make that div a grid system. So if I save this and check it out first, okay, it looks okay. If I duplicate this, yep. So with that, I can copy this registration and close this first one, open this one. Here's that icon right here, and make sure you import it from React icons, and we can call this created art instead, and we can remove all this. Okay, and we can bring in the date. I'm gonna come to this withdrawal list and copy the way the date is structured here. So I'm gonna copy this date system. I'll bring it here, so it's gonna be this campaign.timestamp to local date. So let's save that and check it out. Okay, look at that. That is cool. I think I should just give it like a similar color to this. Let's check it out if that would be great. See, orange. Okay, you see yellow. Okay, that looks absolutely, that looks better now. And I think even on, small screen, right? Yep, everything looks absolutely on point, very responsive, and so on. So at this point, we are cool. We are able to create a campaign and so on. So how about we make donation? That would be fantastic, right? But before we make donations, we want to set up our Redux system. Okay, these things have to be Reduxified if we're gonna get the best out of it. So I'm gonna do that in the next part of this video. Okay, so to Reduxify this, I'm gonna close all this. Come to this place. Here, I need to create a new folder here or a new file. Call it store/state/global state.ts. Okay, so we just created a file here. Now I want to show you something. Let's go to interface. Now interface right here, we've already set up something called global state. Now this global state is a bundling of, it's basically me bundling these various campaign, transaction, program states, just bundle them together because I want to be able to access them in the store. So the things I'm going to be accessing in the store, I'm bundling them together. That is what it is. I'm making a root state where from one position I can have access to all this information. So that is what we're doing. So we're using export, okay, const, call it global state, and global state, you want to make sure that it has a type called global state that is coming from interface right there. Great. So, and you have to make sure that it's represented properly. That if you look at that interface, it does have global state, it has donation, it has campaign. So we can start with campaign singular, because I'm not putting all the campaigns in the store. It's just the one that is currently being looked at, viewed, or the one that is currently being observed, which is the details of it. So it's going to be null by default, and want the donations to be an empty array. Okay, the withdrawals to be an empty array. Want the program state to be a null value by default, and we want the delete modal to be a string, I want the withdraw modal to be a string as well. Empty string. Okay, there you go. I'm gonna save that. Now for each one of these items, I want to create a reducer or a function that will modify their content. So, and that's why we come back to this place, this store here, create new file in the store, create a new file, call it actions/global actions.cs. So I'm gonna copy this. So now please, you should be aware that this action should not be in this store. I don't know why. Okay, it should be in the store, sorry. It should not be inside the state folder. It should be in a store action. It should be on its own. And for action, it's gonna look similar but not exactly. So I would say export const global actions, which is equal to an empty string called is set, an empty object. The first thing we want to do is to set donation. So let's look at this. So I want to set campaign first, set campaign. Okay, and campaign, this is how the structure of a reducer is basically a function. So it's going to take two parameters. One is the state, which is global state, and also the action. And this action is going to be payload, action. And this payload action is coming from, since it's not important, I'm going to do that manually, from at reducer to Redux toolkit. So I'm going to get payload action. Redux toolkit is present in the package.json. Look at it, part of what we installed, and also React Redux, the two work together. So come to payload action. Now in the payload action, we want to typecast it. What kind of payload is it getting to us? Is going to be a campaign. Okay, now we understand what that means. Okay, so now let's open it up and just say state dot campaign is equal to this action dot payload period. So we're going to do something similar for donation. So we'll say set donations, and this is going to be transaction instead. Transaction from that interface, transaction array, and this is going to be donation. All right, I'm also going to do the same for withdrawals. Okay, and withdrawals, there's the withdrawals here. After this, I'm going to do the same for program file, which I could duplicate this, cut that. So say set state. Okay, and this is going to be program state. From that interface, I will call it program state. And I also want you can say that it can be null, but this isn't really important for now, because we're not trying to reset some certain things. Okay, so lastly, you want to do the same for delete modal, and this is going to be a string, call it delete modal. Also want to do for withdraw modal. Okay, withdraw modal, and this is going to be a string, call it withdraw modal as well. So these are the various actions that we're going to be needing. I'm going to save that. as a second step, now we have action, we have state. So the next thing we want to do is the global slice. We want to bundle them into something that some people call reducer. So come here, make sure you close. See, global slices .ts. So in these global slices, we want to export const global slices to be equal to create slice. Okay, and that is coming from React Redux as well, and it takes in an object as a parameter. The name of this reducer is going to be called global. The initial state now we have to import this. I'll call it global state. Okay, now but I'm gonna alias it, okay, as this. So we do this, and we also want the reducer. Okay, say global actions. I'm gonna alias this as well. Okay, give it here. Great. Now I want to export const global action. You see, this is why I gave it alias, so that this name will not disturb this one, because this one now is seen as this. That's why here. So that's why we make sure that this global action is not the same as this one, so it will not complain. So global slices dot actions, and say export default, say global slices dot reducers. Okay, so this is what you use in bundling that slice. Okay, we only need one slice. That's why I'm naming it global, because I don't, the application is not wide, it's not voluminous, so we don't need to do something crazy. So lastly, you want to create a file called index.ts. So this is where you bundle every single thing. This is basically the store, so you want to export const, call it store, and this store is going to be a configuration configure store. It's coming from the reducer as well, and this Redux toolkit, and then you apply this reducer. Is going to be that global, call it global slices. Okay, so this is going to be stored in this global state. The name of this reducer is global state. So it's giving me an error here. I need to find out why this is an issue. Let me see, reducer, and let's do, okay, say global state is global slices. Okay, so this is how we specify it. Great. At this point, we want to bundle it in our main layout application. Okay, so I'm going to close this for a moment. I'll come here. Let's look at this application. Go to this layout here. Okay, in this place we're going to wrap everything here inside the store. All right, and let's come in and see provider. Now this provider is supposed to come from React Redux, so I will say import provider from React Redux. So this provider here. Great, so this is provider, right? And I want everything here to go inside here, but you need to make sure that this provider does have what they call a prop called store, and you want to pass that store that is coming from store. So this is what we just created, right? This config store, so we're passing that store inside here. All right, So we haven't saved yet, so we need to observe the difference. So at this point, if I come to, let me open this. So if I come to localhost here, all right, and check on inspect, okay, let's look at Redux. You find out that we don't really have a lot of things, anything that is concerning us, not all the things that we put in, we've been creating as appear there. But let's say the moment we save this and we come back here, we refresh the page again, you can see now that we have this global state that has all this information that we created. So that is what we would to verify that the store is up and running. So now that is working, I'm going to do a little bit of a change to this blockchain service. So this blockchain service, whenever it's fetching at this point, before it returns this, I want to access the store, okay, call on dispatch, because I want to send in data. So, and at the same time I want to do const, get the action. So global action from this global slice, I want to set campaign. Okay, so I'll come here and say this dispatch for setting a specific campaign, say set campaign, and then pass in this serialized into it. Great. This little step is very vital, so I will save that. Now this is supposed to be the singular campaign page, the specific campaign page. So now with this new way of doing it, I can grab the campaign directly from the store and say use selector. This is how I grab things from the store, and say states, and this is going to be root state, an interface that comes from the store as well. And then we say this state dot global state, and then I can access the campaign here, this campaign here, but it's going to be conflicting with this one. That's okay, because we don't really need this one anymore. But here it's going to also complain, it's also okay, we don't need here anymore. But what about this place? It can return data, which we can, if we needed this way, but we don't need this anymore, because right here the store is saving it whenever that method is called, so we don't need to worry about that anymore. And we can remove this, and we can remove this as well, and save it, and let us check it out. Refresh. So you see that there is no difference, but there is a huge difference, because it means that when I now make donation, I can programmatically send the data, the new data, update the new data on the store, and this will reflect and change dynamically. But if I did it the other way around, that it used to be, I will have to refresh it before the changes appear on the page. These are major differences that I want you to take note of. So in the next part of this video, we'll start making donation. So I'll see you next. So it is time for us to make some donations. Okay, so to make a donation, we need to look into that donation component. It's called campaign donate. So you come here, right there, campaign donate, and this is the component I'm talking about here, this one. Okay, so let's check out what it does when I try to make donation. Say 4.56, and it just dump this on me, which is okay. So at this point, what we need to do is we need two things. Okay, so let's come back here. This is the page, this is called the campaign detail page. So you want to locate this component called campaign donation. Okay, this is a component right here, and you want to make sure you're passing in a campaign object and a CID, basically, which is the program derived address. All right, once you do that, you receive it on this end, then you can perform your donation. And now, for us to perform a donation, I would like to just, let's say, let's use this, let's use the logic that we have here. So I'm going to borrow this copy. Oh, I don't need to copy everything, I just need to copy this to here. All right, and okay, then just do this. Okay, I'm gonna remove this here. Okay, let's look into, sorry. Okay, let's work on it one after the other, one step at a time. Okay, so at this place we want to make sure we import this React Toastify, and you want to make sure that this is an asynchronous function. Then you want to import this public key thing, so we're gonna get it here, make sure it's available, and import that from Solana Web3 wallet adapter. Okay, so at this point the only thing we need now is the program. Okay, now if we're looking into the program, which is this, you can copy exactly what you have here. Okay, and you make it available here as well. So this is a program that we're looking for, so get all those things available. So at this point, the only thing that is left for us to do is to write the function that will be responsible for performing this donation. So we can copy or duplicate this and just change some certain things in it so that we can speak to our function. Say donate to campaign, you can call it that. So in donating to a campaign, you need these two are undebatable, you need them, so you're gonna have to keep it there. And you're gonna need the PDA, so which is the program derived address of the campaign, and you need an amount. How much do you want to donate here? So these are the details that you need. And once you have that, the first thing I want to do is, we will not need this here, so we'll not need this. So the first thing I want to do is to get the campaign. So I'll say const campaign. We can just do that using what we've already done here. So we can just grab the campaign. Okay, let's grab that campaign. Okay, now we have the campaign. Once we have the campaign, we want to create a transaction, PDA. Remember here that we'll search for donation instruction. In donation instruction, this is how you form the seed donor. You see donor, the key of the person, the public key of the donor, and the campaign program derived address, and also the total number of donor that is available. And of course you need this transaction here, so we're creating this transaction PDA. And to do that, I think I'm just gonna I'm just going to duplicate this. Okay, so I'll call this transaction PDA. And some of these things I don't need to recreate it this way. Let me just let's do this. This is a lot better. Let's do that testing, and where we have all those things done already. So we have to this create, update. This is the donate. This is where we're donating. This is how a transaction PDA should look like. So I'm just going to copy what we've already done, and after that I can then modify this. So this remains true. Donor.public key is just that public key that we're getting here, the buffer. And here, this you can just change. You can just use this PDA, because if you look at it, it's still a public key. It's just a public key. Basically, it's just a key. And just like we did this, we can also do that. So we can do this way. Of course, we're always open to experiment. If it doesn't work, we can go back to this format. But since this is the PDA, we can say .to buffer. Okay, so it isn't working that way because it doesn't regard it as a public key due to this being a string here. Okay, if it was a public key, it will have this method. So instead of doing it that way, let's go back to this way. We'll call on this campaign.cid. Okay, so that way solve the problem. And then this donation count, donor count, we'll do campaign.donors and then add 1 to it, and that will solve the problem. So here we go, we have that transaction PDA. What else do we need here? If you come here, you can then do this. So let's copy this whole line here that we've done before. We don't need to code everything from scratch. So now this CID will be campaign.cid. Okay, so at this point, what you want to do is make sure you copy this and use it to replace that, and then we're going to make some modification. First of all, I'm not going to be needing this campaign PDA. Okay, so I'm going to remove it here. Instead, I'm going to replace it with this PDA here, this one that I got here, because they are basically the same thing. So, and this place, I'm going to remove this and I'll pass in the real amount here. Okay, and here I'll pass in this campaign.cid. Okay, so, and this is going to be just the public key. All right, so with that, this is just all you need. The most important place was for you to formulate this PDA. Very important that you get it accurately. And once you achieve that, then you can proceed and come over here. Okay, so let's proceed. We'll save this, and then we can invoke this function over here. Say donate to campaign, and this we need to pass the PDA, and because the PDA must be present, and this is going to be the amount. Here I want to use toast.1. Let's save it and check it out on the console. Come here. Let's say we want to before I proceed. But let me test it out and show you the difference. So let's say I donated 1.5 Solana tokens. Click on donate. You see what is going on now? This is invoked, and I'm just going to confirm anyway. So we'll wait for this to be completed. Okay, that was successful. But there's a problem. I cannot see these things. These changes won't happen. You see, everything remains the same until I have to refresh this. You see that? So we want to get rid of that issue, and how we can do that is we have to come to this place, okay? And first of all, we want to also set the amount to empty string whenever the transaction has succeeded. So there is some things we need to do. Let's get, let's call this dispatch. Is equal to use dispatch, and it's coming from React Redux. Okay, I also want to get the action. So I want to say global actions. All right, and for global actions I want to get set campaign. Okay, set campaign right there. So I want to grab that set campaign. So at this point I want to do dispatch. I want to get this again. I want to call on this function. This is the main campaign, right? This is how we got the campaign details, by using use effect to grab the campaign information. I want to call on this same method again, and because we've set it in such a way that under the hood, it will fetch it and store it and get it stored in the store. So we just need to make sure we invoke it at this point. So I will call this, okay. Then I don't even need all this. I don't need all this here. I don't know why I even did all. I don't need all that. So I'm going to remove all that. So I only just need to call on this function. And this CID, I'm just going to pass the PDA here. So once that is done again, then this should be updating at real time. So let's look at it again. Come back here. All right, so let's donate around 2.6 and click on donate, confirm, watch this information change, and here watch as they change. Did you see that? This just increased right in front of us, and this also increased right in front of us. That is what we're looking for. Okay, so that is how you donate. Donations, very simple, straightforward, no hassles. So in the next part of this video, I want to list out donations, okay, so that once donations have been made, we can actually list them out here. Like there are 2 donations that have been made already, so we need to list them out. So let's get it done in the next part of this video. So let's go and fetch all the donation, okay, right away. So just close up all this and close this. So you can come fetch, copy this and come here, say fetch all donation. To fetch all donation, we're gonna need the program and then the PDA of the campaign, which is gonna be a string. All right, and what you expecting is a transaction, okay, array of transaction. And of course, the first thing you want to do is to fetch that campaign. So call on this fetch and you pass the PDA, and once you get that, you want to do a check here. You want to get the transactions this time. So you can say transactions, okay, is equal to this account, call on this transaction, and then you want to fetch all. So all the transaction, okay, that you have. Now you want to filter those transactions to only match the ones you only want to match transactions that belongs to this campaign. So to do that, you want to say active I want to call it donations is equal to these transactions, and then you map through each one, and each one, let's call it TX. Each one is a TX, and you want to check on the CID of each TX, and you want to check if it is equal to this campaign above. I don't know why I call it campaigns, just singular campaign dot CID. So if they are the same thing, it will return. And not only that, we also want, I think I should put this in a whole new line on this one, and this should return. Okay, now so I have return any donation that matches this campaign. Now in transaction, both withdrawals and donations are together, so there's really no difference between them. The only difference between them is if one is credited or debited. Let me show you back again. If you check on transactions here, you see if it is credited, that means it's a donation, but if it is debited, it means, if it's not credited, it means that is a withdrawal. So I want to also check on that by saying this TX, this is a second criteria, that the credited, it is a credit, is a credit donation, then it should return that transaction. Otherwise, at this point we can then serialize this, because we need to serialize this. It's not very clean, so we need to serialize the campaign. We can just serialize the transaction. We can just duplicate this and modify it a little bit. Serialize TX, okay, which is transaction TX. Okay, and you want to make sure that these are transactions, okay, and it's returning transaction array. So what do we need to remove, and what do we need to add? First of all, we're removing this amount raise and goal, and this will rename it to owner. See, what I'm doing is basically I'm translating this. Look at this timestamp amount owner. That's what I'm doing here. Timestamp is remaining. CID, this donor is going, and withdrawals is also going. This balance, I'm going to transform it into amount. These now make up all that we need. So these things you see here, they are the PDAs of each one of those transactions. This is the owner of each one of the transactions. This is the campaign, the campaign ID of, the transactions, and these are the amount, okay, in Solana tokens. Right, so those are all the information, and now we can serialize these donations. See that? And after we serialize the donation, we can return that serialized donation. Serialized transactions, which is basically serialized donations. But the cool thing is you want to make this Redux friendly. So I'm going to have this set donations functions here. So I'm going to call on the store, the dispatch, and set donations, then passing this serialized donations. Boom. So this is what you need to do to fetch a donation. So I'm going to save that, and I'll come here. At this point, whenever I perform a campaign donation I also want to fetch the updated list of of donations that have happened. So I'm going to call on this. So exactly the same thing. Now I will come here. Let's look at this. This is this page. This is this page. Whenever we land in this page, I want to grab all the donations as well. So we want to do that together. So here I'm going to duplicate that and do this. Okay, so now we have all donations as well, and I want this to become withdrawal, donations, but it's going to conflict with this here, so I don't need that. I'm going to remove that, and let's save it, and let's look at the browser. You can see these are the donations that we have. This is great. So this is really good, and we can also do the same for this withdrawal since they are just about the same thing. So I won't need to make too much of changes. So all I need to do is duplicate this right here, and I said get fetch all withdrawals. Okay, so this we can call this withdrawals. Great. And let's come here, say set withdrawals, and in this point we want to say set withdrawals. Now everything seems almost perfect, but one more thing here. This is just basically going to get us donations if we don't do this. So we need to make sure that it is inverse. So if it's not credited, that means it's a withdrawal. So you save that. That is what you need to do. Okay, so this same thing, we can just come to this place and make sure that it's also part of this fetch. Whenever we make sure you import it, and make sure you're using withdrawals now, and make sure you remove this. Okay, so these differences are very useful. So at this point there's no withdrawals yet, so because since there's no withdrawal, nothing is going to happen. Okay, so this is how you list out these donations and these withdrawals. So in the next part of this, I think we should do this as well. This place is still listing out dummy campaigns, and I don't think this account does have a campaign yet. So let's come here and let's grab the campaign that belongs to this specific account. So each account should have their own you can check out all your campaigns here, and the campaigns that can appear here can either be deleted or not deleted. It doesn't matter, all of them will appear. So we're going to call it fetch user campaign. So let's come here to the blockchain. You can close here and see after fetch active campaign, we can duplicate this and call it fetch user campaign. Now the trick here is going to be a little bit different. So here's the trick. You're saying that for each campaign, you're not looking for active state, you're looking for the creator. Now this creator here, you want to compare it with a public key that you want to supply. Okay, so I'm going to copy this public key, so the currently signed in user. So you want to compare this public key. So this creator here is a public key. All right, so you want to say dot to base 58. That will give you a string. There's a reason why I'm doing it this way, because when you compare the string itself, it will give you exactly what you're looking for. But if you try to compare the public key, it will not give you what you're looking for. So I learned that myself, and I don't want you to go through that stress. So we can say return. If this is a call to, you can keep it at to this public key here that I'm submitting, and you want to also convert it to the string. So if this match, this will be the kind of campaign. We can call this user campaign. Okay, so now let's save that, copy this. Let's come to this page, app, account, this page in account. So here we're going to manipulate it a little bit. And how we can manipulate it, let's look for, can use the same ideas that we got here. Okay, so the same idea, which is to fetch. We'll just copy this whole thing here. Okay, and come here. These records, we need to change them. So I'll come here, pass this. Need to import all these things that are not here. Need to import use state. Need to import use memo. Need to import this provider. Okay, you need to import this campaign interface. I need to import fetch user campaign. All right, a request to argument, you want to also pass the public key. So now the public key is not supposed to be a string, so I have to make changes to it. And how you do that is, let's come here, copy this, paste here, make sure you import this adapter. I don't need these ones, so I'm going to remove that. I'm only going to use the one that I want. And also you want to make sure that this public key is part of here. So with all these modifications that you've done here, can remove this dummy data now. When you save this, there's some errors down below. So before I'll come back to this. It doesn't have access to programs, states. But let me show you this one first. You see that this guy doesn't have any. Saying public key is null. Public key is null. Okay, we need to make sure we protect it, because there could be a situation where it's not fully represented, so we want to protect it so that it will give us exactly what we want. So I'm going to come here. I will say I'll wrap this in an if statement. If, in case this, so if there is a program and there is a public key, then you should do this. Save that and let's refresh. Now we no longer have that issue. Now there is something here that we needed to display, which is a form that should be available to the owner of the platform, this form. But currently it's lacking two things. Basically one thing, this program state, that is what is lacking. So it doesn't have it now, so let's make that available. We need to grab the program state. When we grab it, then we can be able to use it. So we'll say fetch program state. Come to blockchain. I'm going to duplicate this line. I'll call this fetch program state. And what does it need? It only needs the program that we're fetching. And with this, we'll use that to we need this program state here, PDA. So I'm gonna do this program state PDA. Great. And I need to grab program state. So call on this. program state, account, column program state, and fetch that specific program state PDA. So now we have the program state, and once we do that, we need to serialize it. Now let's come here. Let's call this serialized, and for now it's just an object. Or let's give it a type of this program state that is coming from our own interface. Remember, we have a program state right there that has initialize, campaign count, platform fee, address, and all that. So we need to make sure that that is available. This program state that is coming, comprises of some things like big numbers and public key. We need to make that, match this one, which is just numbers and strings. Okay, so we're gonna say that program state. Okay, and we're going to update. We're going to update the campaign count. I want to say this program state dot campaign count dot to number. Okay, I want to do the same for the platform fee. So the platform fee is going to be platform fee as well. Is a number, and lastly, the platform address. It's a public key here, so I want to change it to base. No, sorry. Platform address. I want to change it to base 58. So that will give me a perfect match for this program state. Great. So at this point, we need to put it in the store and also return it. Right, so to do that, let's come here, say set program set state. Okay, we say here set state, and what we're doing is want to set this serialized. Okay, and we can then return this serialized as well. It's not supposed to, what we're returning is a program state and not a transaction. And it's not an array of it either, just a program state. Okay, so at this point we can save this, and we need to come here. So what are we doing here? We want to have access to program state. So from use selector, that the program state is in the store. So we're going to say use selector. These are the states, and say root state interface, and say state dot global state, and then I want to gain access to that program state right here. Now with this program state available, I can do this. Okay, so it's saying program state dot platform address. This is a string. You can compare with this, so we need to make sure that this has to be to base 58. All right, so with that changes, you save, and let's check it out on the browser. Okay, now we need to make a few more modifications. If there is a program state, so something may be running too fast here, so it doesn't yet know if this exists. So we need to make some modifications. Okay, first of all, if this thing is loading, if the page is loading, I want to display this. So if the page is not yet loaded, I want to say the page is loading. And for that to really make sense, I have to make sure that the process is part of this use effect. Use effect is, it has to be used to determine if the page is fully loaded or not. So I want to move this into its own function. Call it const. I don't think that is necessary. So here in this same place, after this, I want to say await fetch. I haven't actually fetched the program state. Okay, I need to fetch the program state. Make sure I supply this program. But the program I'm supposed to supply here has to be different from this. Okay, it's actually the same, so there's no issue. Okay, so okay, I see why I needed to put this in its own function. So I will say const fetch data, which is an asynchronous function. Okay, so there we have it. Make sure that I execute that function here, fetch data. Okay, so at this point, let's create a use state. Say const loaded and set loaded. This is a use state and false by default. Now, after I have fetched all the necessary information, I need to set loaded to be true. Let's save that. You see, this is showing up now because the page is loading up at the right time. What if I disconnect this? Okay, what if I connect that? Okay, so this is great. So this is basically all we need. We're done with this page. It will display the right things, but we'll come back later on to work on this function that will help us to set or update the service fee. So that is it for this particular section. In the next part of this, we are going to attempt withdrawing from a campaign. So I'll see you in the next part of this video. So we kind of missed an essential thing before I even move forward to doing what I'm supposed to do here. Let's create a specific campaign, because this doesn't have any campaign yet. So we need to verify that what we've done is actually working. So let's say I'm going to be doing a 41.56, no campaign. So the title is going to be post what donkey, and let's get the image. Okay, and then you can get some more information. Okay, so now let's create that, confirm, and wait for it to be approved. So it's approved, and when you come here, you have all the, see, and when I check my own account, you can see I have my unique campaign right there. So that is great. Now that we've resolved that, there is something here. This campaign belongs to me, and I should have a certain enablement that is supposed to show up here. We need to make sure that is functional. So let's come to the component, look for campaign donate. Okay, you see all this is not working out, so we need to make sure that it's obedient. So how we do that is we want to say, we have this public key here, so we want to say this public key dot to base. This is also want to say this campaign creator must be the same person that is currently signed in. So that is very important, and this we can use that. We need to make sure that the public key first exists. Public key. If there is public key, that's great. Okay. All right. At this point, let's save that and check it out. Okay, you can see these buttons are now appearing for me because I am the owner of this platform. So remember what I wanted to do is to do the payout. Okay, so let's come to a donation, a campaign, this campaign right here. I'm not the owner, you can see that is not showing up, and so I have to connect as the owner. I think this should be account 2. It's not account 2 either, it should be account 3, dev 3. So let's connect that. All right, payout is not yet enabled, so we need to enable that. We need to enable that particular modal. Is a modal, so that enables you to withdraw. Okay, so let's visit it. So you need to come here, come to that, not this account. I'm gonna come here. So this is basically it. Is it? No, not here. We don't need this. Close this for now. So let's look for campaign in this campaign page, this particular page here. So this is what we're talking about here. Okay, let me close out this with this. Let me close out this delete modal. This is the withdrawal modal that I'm discussing. This PDA, okay, it's having an issue with it. So let's look at why. So this place doesn't have that, which it's supposed to. Maybe I kind of removed it. So we have PDA right here, PDA, and this campaign is going to be just campaign. Okay, PDA is going to be a string, so we need to specify those very well, and you can see that the error is already gone here. So okay, so the scale is at 0 right now, but if I put it 100, you see it's showing up. We need to make that whole thing, Redux friendly. So this withdrawal modal is supposed to be coming from Redux now. So it's supposed to be coming from Redux. So let's say const use the structure of use selector and state, root state, interface. Make sure you grab that global state, and you want to get this withdrawal modal. Okay, and that is what you're using here instead. Okay, so you want to make sure that is up and running. So with that, let's look at that. Withdraw modal. Okay, so I need to come to global state. Make sure that the delete and withdraw modal, they are saying scale is 0. Okay, so you save that. When you come back here, you can see that the scale is 0, that disappeared. So that's great. Now in this campaign donate page, you're looking to, let's make sure we get some vital information. So we say const is auto global actions. Okay, now for this global action, I want to do set withdraw modal, and I also want to do const dispatch is equal to use dispatch. Okay, so now let's use those two information to update. So if I say click on this payout button, we'll say on click, I want to do dispatch set withdraw modal, and I want to set it to scale of 100. Save this. So when I click on this payout, you can see that it's showing. I also want to do the same here. When I click on this button, it should disappear. So I'll come to this withdraw modal, and this handle, where is that function? This here. So I will say here, sorry, this whole line, and we want the scale to be 0. Now I just need to make these things available, which is these two here. Need to make them available here as well. So we can do that here. Import global action, import dispatch from React Redux, save that, and let's click on this again. Okay, that is working out now. Okay, great. We have those two functional. Now we need to be able to cash out the amount of money that we intend on using. There's something that we needed to know. You see, this is total balance that is available for withdrawal, which is 4.1, just as we have here. So we want to make sure that we cannot withdraw above that, and I think we can say max here. Max is going to be say max. Okay, so this is max, so that we can, cash out. So we're doing that right there all together. So at this point, let's write the function that will be responsible for doing this. We can copy this create. Okay, the rules that we've used in this create function. So I'm going to copy all this. Okay, and I'll come to that withdraw modal, and I'm going to do this here. So want to make sure we import toast, React Toastify, and if there is no amount, please enter an amount. I don't really think that is even necessary because we already have a way of preventing such things from happening. So, but what I can do is to just put all of those things together, saying it should not work if there is no program, if there is no key, and if there is no amount. It should just return. You understand? So, other than that, let's look at that create. These things are normally the same, so you want to just copy and paste. So I'm going to copy this and this program, come here and paste those two information. Okay, make sure you import this and you import this and you import this. So now I'm importing this get provider from the wrong place, so I need to import it from this service block, this blockchain service. Okay, so there we go, we have it there. And now everything seems aligning, but we need to make sure that we have a function that we can withdraw from. I think we can just duplicate this function here called donate to, and we can call this withdraw from campaign. And to withdraw from campaign, you're definitely going to need 4 items as well. The items include basically exactly the same thing. We don't need to change anything there. So as usual, you want to grab this campaign, you want to grab the transaction, but this is going to be a little bit different. Let's visit this place, make sure we have it here. So now this is for to create a campaign, update a campaign, donate to campaign, but withdraw. So in withdrawing from a campaign, I need a program state, a PDA. Okay, so I'm going to copy that, make sure that is available here. I need a campaign PDA. I already have that here. I don't need to repeat that. I need a transaction PDA. It's almost here, but I just need to make a little bit of modification. First of all, the buffer for this is going to be withdraw, not donate. And the withdraw count here has to be campaign, not donors, but withdrawals. Those two information are very vital. You don't want to miss it. Then you want to copy this whole line, and and this whole line right here, paste it here, and you want to call this, let's call it withdraw amount, and you're passing in the withdraw amount here. So the CID is going to be this campaign.cid. Okay, so account partial, so this PDA is going to be this PDA that's coming here, and the creator public key is going to be this. We also need program state. So how you do that for this is going to be slightly different. We need to grab that, we need to use the program state. Remember, we created the program state here, right? So we need to use that program state to grab, the state of the program. So just grab it, and then from there we can access the platform address. Okay, so that is important. So with this, nobody just gonna try and fix in any kind of address in here. Even though they do, it will not tally with the one that we have on the smart contract itself. So it's a security mechanism that we've already pre-coded into the smart contract logic. So at this point, this is all you need, and withdrawal will actually happen in peace. So we'll copy that, we come here, make sure that we import it here, save this. So what do we need? We need a public key, we need that. Okay, I'm going to remove this. We need PDA here. Okay, remember we are getting PDA from here, so passing the PDA, and the amount. Okay, the amount, very important, so you need to pass the amount here. Amount, we don't need this, so we're going to remove that. Okay, and we don't need this here. So once you've successfully withdrawn, there's one more step you want to do similar to what you did here. See this step? Set the amount to be 0 and fetch the latest details from the campaign details, and fetch not all donations but all withdrawals. So we're going to do this now. Okay, so let's make sure we import this, and we say fetch all withdrawals. Okay, so once we do all this, then we should be able to withdraw in peace. All right, so let's refresh this and make sure everything is looking good. So let's withdraw. Like, I also want to make sure that I want to grab the key so that I can use it later. 2.1, or yeah, let's say 2.1. Let's say withdraw, confirm. So waiting for the withdrawal to be complete. Okay, withdrawal is complete. There is one more step that we missed here, which was to close this after the withdrawal is successful. But it may not be necessary, because you may want to withdraw again, but it's often good that one closes it. You can call on it again if you need that to be open. So whatever I did here was this function here, I'm going to do exactly this. Copy this, come back here, paste it here. Okay, so that we solve the problem and hide the component after I'm done. So but I'm going to copy this line, this key, and I'll come to the transaction history and search for this transaction. Now look what happened here. Okay, this is the creator. This creator have about 500 Solana tokens. Okay, and I sent about 1.9 to them. This is the percentage that they got, about 1.9. And remember, we withdraw 2.1, so they got about 1.9 out of it.
and then this amount went to the platform address. So this is the platform address right here. Great. All right, and this was the account that was debited from, which is, this is the platform's, the campaign address. You can see that this is only 2 that is remaining, two tokens, 2 Solana tokens remaining there. We withdraw this, and those are the major people that were part of this. And I don't know this account. Basically, there's one account, it doesn't have any history nor a description, so I don't really know what this account is, remember. Okay, so but other than that, everything is is all good. Okay, so let's come back here. See, number of withdrawals actually increased. I didn't actually show you that, and you can see the history increase there. I shouldn't have refreshed that first. So let's pay out again. Okay, let's say we want 1 token. Withdraw that. Confirm. Oops. What is the issue now? The issue is saying, okay, we can withdraw 1 Solana token. It has to be more than that. So let's say 1.5. Okay, so let's withdraw that. Now you can decide how much is the minimum withdrawal level when you're coding your smart contract, or the conditions are already set up in that place. I just want to show you how this is incrementing at real time, how this is closing, and how the donation count, withdrawal count increased, all of those information right there. This is good. So there's one more thing that I wanted to do so that I won't miss. For example, this is okay. It's showing me where that transaction happened, the account that performed that transaction online, which is great. If I come to this withdrawal list, okay, you can see the cluster name here. How do I come about this cluster name? The cluster name is based on the way it's customized. I want to make some changes to it. Basically, that is one of the things that I want to do. And there's a certain place that I made a little bit of a logic that accommodated this. I'm trying to look for that logic. There is a certain logic that I employed. Okay, here's the logic that for getting a cluster URL. So I want to use this logic, but I'm going to just modify it a little bit. So I can decide to write that whole logic in a helper function. So you come to util and say helper, this helper function, because I'm going to be using it multiple places. So we only have one function here, which is a function that enables us to truncate wallet addresses. You can see how these wallet addresses are truncated. It is because of that helper function that we created. So this helper function does truncate for us. So let's export another function. It's going to be called get cluster. Just get cluster, not cluster URL. So I'm going to pass in the cluster URL. We want to pass the cluster URL this time, for it to get me so it's going to be like an inverse of this. Okay, so there's a science behind what I'm trying to achieve here. So let me do this. I didn't plan this. This is just me doing this on the go. So if I pass this, I want it to return beta mainnet. Okay, so I want to do, if it is this one, I want it to pass me testnet. Okay, if it is this devnet, sorry, if it is devnet, I want it to pass me devnet. And lastly, if it is this, I want it to pass me custom, not localhost. So that is just the difference here. So I'm going to do this. Okay, so let's save that. Now we'll come to this withdrawal list. Okay, and we're going to make a little bit of modifications here. Let's come to this blockchain. You see the way we grab this. So I'm going to copy this line, come here and do this cluster. Okay, so once I get this cluster, the next thing I want to do now, I'm going to move this whole function from here, okay, to place it as a helper function. Okay, I'll place it as a helper function. Now, okay, so this now I'll pass it as get, cluster URL. I could just pass this as the same as the name of the cluster. Okay, so get cluster URL function above, and I'll pass in that cluster, but then I use that to get this cluster. This is just clusters. Okay, so now when in this place we need to get this ourselves. So let's make sure we we've not exported this export. So if I come here and say, okay, there you go. Now let's come here and say, const cluster name is going to be get cluster. Okay, and then I'll pass in this cluster here, and that should get me the name of the cluster for whatsoever one I place in here. I don't know if you understand the logic, but let's save it and check out the withdrawal first. So if I do this, it's taking me to the custom one. What if I change this to, let's say this is devnet. Okay, let's say this is devnet. Save that. What does that show me here? So the cluster is going to try and access the devnet. I don't know if you've seen this thing, but you can see it's trying to access the devnet, So I'm glad that worked out. So I'm going to just take it back here. So these things are working. Now I'm going to copy this line of code, and I want to do the same for donation list. I'll do this. Okay, make sure that I import that cluster. Great. So everything is all good here. Close this, and look at that. Currently this takes me to the costume, which works out just fine. So that is it for payout and listing out all these things, effectively. In the next part of this video, I want to show you how you can edit, a
You can edit an existing campaign and probably start deleting them. One last function, which is to update the service fee. So let's come to closing out from here and here. So let's come to the page responsible for updating a campaign. You have to come to this campaign, the edit, and then this page here. This is where you find what we're looking for. The very first thing you want to do is to see the way we're getting this campaign. If you come here, say edit, it's saying it cannot find this. That is because we are not retrieving it properly, so we need to retrieve it properly. First step you want to do, similar to what I did here, I'm going to get the campaign from the store. We are assuming that we're saving it in the store, but it's not yet in the store, so we're going to make sure we import all this, and I'm going to remove this because I only need the campaign. Okay, so that's the first thing. Even though we try and do that, it's still not going to show any campaign because the campaign has not been fetched yet. So we then need to fetch the campaign, and how we fetch it is something similar to what we did here. If you come to this page, see the way we fetched the campaign and its relevant information. That's how we want to do for this edit page. Okay, want to come here and make sure that we import React and we remove all this, but we also import campaign details. Okay, this is great, but this program is not yet available, so we need to fetch it just as we have program here. So I'm going to grab it and make it available. I need to import this, and I also want to import this use memo. So with that, this is now available. Okay, so once we can actually store this here, and we can actually do that. At the same time, we can also store it here. Say campaign data is equal to this. It doesn't matter this, it's still going to be available here, but there's some things we needed to set up here. See, all this need to be set, so I need to copy all that here, come here and say, okay, I think we can do this way. Let's try it. This form dot title, I'm going to set it to campaign data dot title. Okay, so I want to do the same for those 4 items: the description, the image URL, and definitely the goal. Now this goal is in this form here is supposed to be a string. The goal is a number here, well, here is a string or a number. Here it's not supposed to be that in this format, it has to be in this format. Okay, I only need a CID. Okay, you need the program. Okay, so I'm gonna leave those ones. So let's save it and look at it. So everything is responding, is great. So we have all the information being pulled from the blockchain and available in our form right here. So the next thing we want to do is to work on this function that enables us to update the campaign. We can basically just copy this whole thing here because they are very similar. So I'll come to this edit and replace it here. Now when I do that, I need to import some missing data. So
Now we also need to import. We need to make sure that the public key is available. And you know how the public key saga goes. It's very straightforward. So I want to do this. Grab the public key that way. And that is it. Okay. So at this point, I want this to be a program, a read-only program, because I'm going to have need for it later on. So this is a read-only program. That is what I use in fetching. That is good. So I also then need a read-write program, which is this one here. When you come to this create function, so I need a read-write program, which is this one here. I need to get the provider from the blockchain. This is great. Now in this place, all this information seems to be, accurate, but we need to create a function that will help us to communicate this to the blockchain. So that's the only thing remaining here, this here. So to do that, I want you to come to this, and now you're gonna just have to duplicate this function and call it update campaign. And in updating a campaign, there's one extra information that you're gonna need, which is the CID. Okay, so this CID is very important. I think the CID should be regarded as a string. This CID can be regarded as a string. In fact, we should just call it a PDA. Okay, this would make it a lot easier, and it should be a string instead of the CID. It should be the PDA, because this PDA will then be used to grab this specific campaign. Okay, in updating the campaign, we don't really need much. If I come here to this, I'm going to pull it to the right. Come here. In updating the campaign, you need a campaign PDA. Okay, so which is what we're getting here for free without having to write all this code. And this whole title, all this are already available. So let's come here. The CID, we're gonna have to, get it ourselves as well. We don't need this. Okay, so I'm gonna remove that. We don't need this program state either. We don't need this campaign PDA either. All we need is this. No, sorry. All we need is this. Okay, so let's come down and look at it one after the other. So this CID, how do we get the CID then? You get the CID using this format by first grabbing the campaign. That will save us all the stress that we could have sustained. So I'm going to do this here. So, and then I will say for this place, it's going to be campaign.cid. And okay, the title, description, and so on. And this goal should be this one instead. All right, so we have all that resolved. This PDA should be, this campaign PDA should be just this PDA here. Okay, and this creator should be this public key. And that is all you need to do for updating an existing campaign. It's that simple. There's no much hassle to it. It's all you need. So at this point, I'm going to save it and then come to this edit and import it here. So when you import it here, remember you need to add that PDA here. Okay, this PDA is the same as this CID, and make sure that you're passing it as a string. And then you have the title, description, image URL, and so on. So at the end of it, we don't want to, do anything to remove what we've already updated. We just want a simple
notification that we have submitted the campaign, and we can click the back button ourselves, except we have another thing to still update. So this back button, we can click it ourselves. So let's say storm damage, bed need your help. Okay, beds need your help. Okay, so let's update that and see. Updating. Okay, successful. Let's come back. You can see that storm damage, beds need your help. That is how you do it. Okay, and yeah, that is how you do it. I think we can also increase. Let's try that again. Let's increase the donation amount, the goal. Let's say 30 something, 35. Update that. Let's see. Let's cancel first because I want to put storm damage colon. Now let's update that. Confirm. Okay, fingers crossed. That is great. Now you can see the goal has increased and all these things. So editing is working just fine. There's one more step now, which in the next part of this video I'm going to show you, which is the ability to delete an existing campaign. So we're going to do that in the next part of this video. Okay, at this point, let's perform a deletion. And close this. Okay, I will need you to come to this component called delete modal. Now in this delete modal component, we definitely gonna need some props. So the first prop I'm gonna need is the campaign that I want to delete and the PDA of that same campaign. Okay, so I'm gonna need those two, and I'm gonna have to define what a campaign is. Campaign is a campaign, and a PDA is a string. So those two information, very important. Now this is supposed to be coming from the store itself, so I'm going to replace that. Use the wisdom we got from here. Okay, I'm going to copy this whole line, come here, replace it, make sure you import all this, and you're calling on the delete modal. Okay, so that way make sure that you're calling it directly from the store. And there's also one more step you want to do. You want to set this dispatch, you want to make it available so that you can manipulate it. Okay, get it from this store, get it from Redux, and set delete modal. These already are awesome. Now this handle close, you want to do dispatch set delete modal and scale down to 0 at this point. Okay, so I'm gonna remove this. Okay, I'm gonna remove that. So you see, you are about to permanently delete this campaign, so we need to put the sample campaign here. So the campaign is going to be this campaign.title. All right, and so that is almost all good. Let's save that, close this, come to the campaign donation component, which is where we can trigger, the way we trigger this payout, we can also trigger this delete function. So we say set delete. So we need to make sure we import it here first.
Where is that? So set modal will say set delete modal as well. So let's make sure we have that. Okay, let's save this. Now we come here, let's click on this. Oops, we've not yet enabled it. We need to come to that page. This is a page, and you can see here I disabled it, so I'm gonna enable it now, and you can see it appears. So click here, it appears. Are you sure you want to delete this? You're about to delete storm bed, permanently. I could break this thing into multiple lines to make it look much presentable. So if I come here and say BRO for line breaker, yep. So you're about to permanently delete storm damage bed, need your help. This action cannot be undone. Click delete. So now this is also working. So now let's perform that deletion. Now we need to write the function, the blockchain function that helps us to perform that operation. So it's not going to be too different from the update campaign. Just going to copy this and call this delete campaign. I'm going to remove all of this here. Okay, so I only need those 3 parameters, and I'm not going to need this. We can just simply go back to the delete function here. Look at it. So you can just go back to this, copy that line, come back here, and replace it here. Okay, now we just need to pass this campaign.cid, and the campaign PDA is this PDA. Okay, the creator is this public key, and that is basically it. Very straightforward, simple. You see, when you follow this sequence that I've just shown you, the order which I'm doing it, you won't have any difficulties, because the smart contract would already be tested, and the functions, how you use to test that smart contract, is the same procedure that you use to integrate it on the front end. The only difference is that you're using an injected wallet provider, which is like Phantom or so, Flare. So that's just the difference. So I'm going to copy this and come here. Now I'm going to use the same methodology, like this handle submit for this donation, and I'll come and say handle delete. Okay, I would not need anything here, and in handling delete, you just want to make sure that you have a public key. I'm going to remove this. Okay, so to make sure that you have a public key, you come back here. I'm going to get this program, that's for sure, and make sure I have all those things imported and provide that from the blockchain. Now I have to also get the wallet, record. So I'm going to get this. Okay, it's called a use wallet. Okay, so, and I want to import this Reduxify. So if there is no public key, then it should return this warning. Otherwise, we should call on the delete campaign function. Then I will not need this, of course. Those are all that I'm going to need. Then once that happens successfully, I am going to fetch that campaign again, and then close that modal. Boom, and that will be all that I need, okay,
to delete a campaign successfully. So let's save that and test it out. Refresh, delete campaign, click on delete, if confirm. Now look at this storm bed, storm damage. Before it used to appear, look, the status is ended now, campaign goal was not reached. Okay, so long as the status ended, that is an indication that this is no longer available to be used online. Okay, so we can even come back here and add an extra layer of provision. So we can see here that this button should appear if campaign.active, because if it's no longer active, there is no need for it appearing. You can see it's no longer there. You can edit or pay out, so those options are still available, but let's try and edit it. Let's see if it works. Confirm. By the way, so long as that is happening, you can always come to this home page. You can see that it's no longer appearing here, and if I come to my account, you can see that it's still appearing. This is cool. That is really cool. And when we view this, you can see that update has happened. So long as I've submitted that transaction, it will be up and running. So I can still edit, but those things are not going to show up again in the general view. Yeah, I can't withdraw anything again because this is too small. Let me see if I can still donate 558. You see, it doesn't even allow me to donate, so it's already ended. So there is nobody can make any donations to this. So this is cool, and that is how you delete a campaign. This is much robust. I have done something like this for Solidity, and I had those were my early days, and the ways that I actually did it was not very much streamlined, like I matured like this. I'm planning on revising that tutorial. Okay, I'm planning on revisiting it and maybe not reshoot the video, but I'm going to rework on that project itself so that it can carry a much more matured tone, so that when you have any issue, you can always consult it and it will make a lot much sense. Okay, because I've had quite a lot of people complaining to me on that particular crowdfunding application on the Solidity own end. So I'm going to revisit it by the grace of God to make sure that it is functional. So that will be it now. I'm going to do one more step, which is to make sure that this is not my account. So I'm going to move to the dev account, disconnect, connect. So this is what I'm trying to do. I want to change the service fee. So now for us to even see that, I'm going to close this. We need to come to this component called account details. I think I should have called it something way better than account details. So I'm going to say platform settings. Let's call it that. So I'm going to say, come here, call this platform settings. Okay. And I'm going to rename this to that as well, .tsx. Okay, so there's a page that is being used, which is in the account page. Come to account page here. So I want to also make sure that is called platform settings here. Okay. So in this component, this is where I want to make some manipulations. Okay, and also let's look at this campaign donate.
see this should be basically the same, but let's leave it this way, please. Here is a little bit different because I put the maximum to be 15. Okay, so the minimum is 1, maximum is 15. So that's the range. So I'm gonna keep it exactly how it is. Okay, so what do I need to do here? I need to do what I normally do here. So I'm gonna copy this, and I'll come here. Now let me do it this way. I need to copy this. Now close this. This is much closer to it. So I'm gonna come from here. I'm gonna copy all this here. Come here and paste them all. Okay, and just import the things that are necessary, and make sure this is asynchronous. Now I need to import this public key and the program because I want to interact with the blockchain. So I'm gonna grab this here. No, not like that. Put it below. Okay, now I need to get that public key. Grab it here. Okay. This is cool. What else do I need? Now I can set this percentage to be null after I'm done, and I don't need to fetch anything. Okay, the only thing I need to fetch is program state, once I'm done. So I'll say fetch program state. Okay, and I don't need this PDA. So now it is left for me now to create this function that we're going to call update platform. I guess we can just duplicate this. Okay, and we'll call it update platform. When updating the platform, we only need the public key, the program, and the percentage, which is a number. These are the records that we need, and of course we're going to need the public state. The program state, not the public state, program state. So we can get the program state from this withdraw function. So we're going to need that here. So what else do I need? That is basically all that I need. If you come to this test here and look at it, I needed that program state, and I needed to perform the transaction. So I'm going to copy that, then come here, replace this. Okay, make sure that this is the percent. Okay, and this public key. Okay, yeah, that is all that I need to do, and this thing will go through just fine. So let's save that and come here and replace it, import it from here, and make sure that this is percentage, and that is all that you need. You come here. Okay, let's increase this to 7%. Let's look at that. I'm going to increase it to 7%. Update. Keeping my fingers crossed. If it is successful, this will become the default value. You can see that current fee is now 7%. Like instantly, you can also give it 8% or 10%. Can update that to 10%, and this will just work out So each time that donations are withdrawals are done now, it's not going to become 10%. And at this point, whenever you're updating, you can actually send the platform users some notification telling them, oh, because of so and so reason, we are not charging 10% for every withdrawals. Okay, so just some heads up. So with that said, that is the complete status of this program. So let's disconnect, come here. So now I want to do something before I go. I want to hide this if there is no wallet connected. If there is no wallet connected, I want to hide those things because there's no need for them to be showing up when the wallet is not connected. So I'm going to close all this, come to the component header. In the header component, this is where I want to dynamically, hide. So I'm going to grab the public key and the program. So if I come to this campaign donate, I could get all those information. So I want to grab this. Okay. And I also want to grab this. Okay, those two information. Now at this point, I want to do that before I display this. I want to make sure that I have a program and I have a public key. That means I'm connected. Otherwise, it should not show up anything. So I'm going to do the same here for the mobile view of it. So this is the mobile view. So this mobile view, I'm going to put it here. So I cannot do. Okay, so I'm also doing this. Okay, so if there's a program and there is a public key, then it should display this account and link and this create link. So let's save that and check it out on the browser. You can see this thing is not appearing, but when I connect, you can see it appears. So that is quite important. So at this point, I want to go through this and see that there is no error anywhere, that everything is showing up where this is not. What if I enter this? So here is another thing, you want to make sure that you block off this if there is no, if the wallet is not even connected. Okay, so you don't want to, you can keep it like that just to try and remind people that they should connect. Okay, so I think it's better this way to just keep it that way. So I'm going to keep it that way. Okay, so I'm going to connect now and let me donate 17 Solana tokens to this account. Okay, and while that is happening, I also want to donate to this 5. Even though I'm the owner, I can still donate. Confirm, and you can see that even while I have not confirmed, this thing has already added here. So those are some certain cool stuff. I'm going to disconnect here and I'll go to account tree and connect, and let me also give like 16 Solana tokens here. Confirm, come here and give like 9 Solana token, donate, confirm. So you can see number of donors increasing and all of those things. That is pretty fantastic. If I come to account, you'll be able to see my account. So I just have to disconnect and make sure that everything is viewable, everything is showing, and that is amazing. So that is it for this build. This is a powerful build and you cannot deny this. So if you want to learn the Solana ecosystem, I think this project abundantly teaches you a lot about the Anchor development stack and all that. So what else is remaining? Which is basically to deploy this project on the internet. So that is what is remaining, and I think we can do that. So let's do that next. So since everything is working successfully, I want to create another branch. So I want to move all these things that I've just done into a new branch. So I'm going to call this branch, create a branch, call it completed. Okay, and then commit my message here, say completed the project, and then publish this. Okay, this is published, so I'm gonna close all this. And whenever you publish, you want to make sure you merge that project. Okay, so I'm gonna come here. Okay, so I want to come to this project, this found us project, and I want to merge it with this, make sure that I have the latest implementation strategy. So I'm going to come here, click on create pull request, just going to merge everything together, confirm. So that is merged. Okay, now that project is merged together, we can then proceed to Vercel. If you don't have Vercel account, please create one. All right, because you're going to need it for this. So I'm going to create a new project. Okay, and it's going to be this founders project. Okay, and environment variable is very important for this to work out. And before we even start doing this, we need to make some more changes here. So I'm going to check out into git checkout main. So I'm now in the main branch, and I need to synchronize. Okay, I need to make sure that I get the latest pull, sync, grab all those things from those updates that I made, just get it all together here so that we can all be on the same page. Now, the deployment process, it's really important that the deployment process you do have enough enough Solana token to sponsor that. So let's run that again. I think I was having a network issue, so let me do that again. Synchronize. Okay, it is synchronized very fast. Okay, so at this point, let's prepare this project for deployment to the main. Okay, so now come to this Anchor folder, come to this anchor.toml, and this is for local net development. I need to duplicate this and call this devnet. Okay, and the cluster, the default cluster, let's put it as devnet. Okay, so this is the default cluster. So let's make sure that we do Solana config get. So we are on localhost, so we need to port it to devnet. So we can say Solana config, set is a -- URL, and we can say devnet. So we are now on devnet, because if you run this one now, you can see that you're on DevNet, you need to check your balance, say Solana balance. You can see I have 14 Solana tokens, so I could say Solana airdrop 10 Solana tokens. So I'm requesting airdrop here. So probably this doesn't work out, so but I can verify here, make sure I'm on DevNet now, and let's search for this transaction. It finalized, so if it is finalized, my balance should increase. So let's do Solana balance now. It did not change, it didn't increase, probably because they feel like I have enough Solana tokens. So failed. There's no problem, let's test that out. Let's do this with what we have. And so let's say anchor build. Okay, all right, so building is done, and if we check target here, deployment, no, let's keep it simple. So at this point, let's deploy this. Say anchor deploy. I'm just going to go ahead and even the Solana blockchain, so that I will not be confusing anything to another. So I'll say anchor deploy. So it's deploying to this Solana DevNet. Let's hope that work out. So this is basically network issues. If my network doesn't help me out here, I may have to just let this go, because I've already spent quite a lot of time in this particular tutorial. I don't want to spend more time here, and each time that I'm doing this, it's basically just reducing my balance. So 4 Solana token is gone. Let's try that again. Finally, that worked out. So when you check this, you check the DevNet, you find out that this program is online now. Great. Source code not provided, but is online here. We're happy. So the next thing we want to do is to initialize this. And please take note here. This initialization requires, if I do cd dash and do code.env. Find out I don't have anything here, but if I come to this init function, so I am even seeing that I could. This is like very much redundant to what I had already done. Get cluster URL. You can see helper get cluster URL. So this is used to getting a specific cluster, so I could use this function here instead of, so do this. And the cluster I'm targeting this time, I need to make sure that is in the environment variable. So I'll call this cluster, and let's call this DevNet cluster. Okay, so now we have that DevNet cluster. I need to test this out. Let me do this for now. Let's say log out this cluster. Okay, so let's do npx esrun, and then go to script, anchor script init. Let's check that. So it's showing localhost. That means it doesn't have access to this. So what if I remove this? So let's run that again, because we want to make sure it's undefined. All right, so if it's undefined, that means it doesn't have access to it. That means we need to install a certain package that will enable us to do that. And the package that we're looking for is going to be called .env. Okay, so I'm going to do npm install .env. Okay, so I'll have .env installed there. So if I have .env, I have to then load up that .env. Let's just quickly look at .env package. It was recently updated, and let's see this usage. You can use it this way, or you can just simply use it like this. Okay, so I'm gonna use it this way, this other way. Okay, so now that we have that, let's run this again. Let's run this again and see. So you can see that it now have access to the devnet. And if I do that, local host. Okay, let's run that again. So it's showing up what we need. Now we can remove that and let's run this. Let's keep our fingers crossed. Okay, so that has been initialized on the blockchain. So if we come here, this now is on devnet. We're not dealing with local host stuff here. So we want to see what has happened. So this initialization instruction has succeeded. That is great. So that's good. What else is remaining? There's really nothing remaining now. What we need to do is to copy this. Okay, copy this, come to here, and before we need to go back all the way back because we need to update this Git repository. So I'm gonna say I also want to look at my test. Okay, let's update this Git repository. Preparing project for deployment to devnet. So let's commit that, synchronize that change. I'm in the main branch, so I don't need to merge anything. Then I could come here. See that has just been updated. I want to import this now and open my my environment variables and add this. Then click on this deploy and just sit back and observe the deployment process happen, installation of packages and all that. So let's see. I'm going to pause this and just wait it out until it's completed. So it seems like this is almost completed. Okay, like compilation is done. There's one step that I did not include here. You can see this thing is failing. It's saying that there are just a lot of things that are not in line, like you can see this module. So I have to correct some things here. Okay, and I could have tested all these things out without having to rely on Vercel to do that for me. I could just do next. I could just do something like yarn or npx run build. Okay, so that I can test out every single thing. No, npm build, npx build, no, npm run build, sorry. Okay, so this has to be checked out, and if there is any error, then this is where it flags out all these things and I didn't have to wait out to go to Vercel to go do this for me. So there's some things that are not right here. Okay, so like this basic idea is not tolerated, so I have to make some adjustment to this place. So I have to come here. These things here are not aligning, so I'm going to come back here. That is this basic export. So I'm going to come here and say it's not basic, it's fundus.json, and this here it's not /basic /fundus, and we're looking for fundus, and you want to pass that here. You're just making just adjustment. This as well has to be just ideal. Okay, pass this in here, pass that fundus. This program. So these are just some quick stuff, which I don't want to make too many adjustments that may when I start sending me to different places. So I just want to make sure that that issue that I was facing was resolved. Okay, this is successful. All right, now let's make sure that we synchronize this. Adjusted anchor build directory file locations. Synchronize that. Come on, shouldn't take much time. My network is often messing around, so let me confirm that it's working. So I guess it's back online. Let's try it again. Synchronize. Okay, synchronization is done successfully, and let's go back. And make sure that this is, you can see fundus has just been recently updated. So let's make sure that all this information are available. Copy this whole thing, come here and deploy. So I'm going to wait for this to complete its deployment. While that is happening, I can come here. And do npm run start. Okay, so come to this place. You can see that there is no campaign available, and I want to make sure that I'm switching to the devnet. Okay, account, and I have about 9 Solana tokens, so refresh that, make sure I connect my wallet. Okay, so let's do some things. So let's have these items available here. So say 20 Solana tokens of 20.5, and make sure that create now. Yeah, confirm. Tells you how much it's going to cost in total. You see, there is no confirm anyway thing anymore, but because this is a valid network that it knows and understands. So while that is happening, let me come back here. The building is taking place, so it's creating production ready thing. So come back here, this is also happening. It's taking more time because this is like in the real chain, like a close to a public chain. Okay, it's not like the local chain where everything is so fast. All right, so we're waiting for this to also complete while we're testing this thing out to make sure that everything is up and running. Okay, this has been created successfully. When I come here, this now is on the chain itself. So I'm going to create about, I'll create more of that, and you guys can go patronize that, send some money to it. Okay, I think I can use that for some test net reasons. Okay, so copy this image address and do this help the bed. Okay, let's say about 35.7 tokens, Solana tokens. And I'm just going to create that one as well. Let's look at this. Okay, this is up online. It's just amazing. It's online now. We can go check it out. If I come here, find out that this is actually online, and you can see all these things that I've been creating, they are added here. So I could just close out from that, and come to the one online. If I'm on the one online, I could just do exactly the same thing I'm trying to do here. So this is the one online here, and connect. Make sure I create another one, and this is just for test purposes. Okay, so let's do this. Okay, and it's about 41.2 Solana tokens. Just put this here, create that, confirm this. Okay, all right, so that is great. We can decide to even donate to ourselves once this is online. So let's donate to ourselves. Let's donate small token. I think we should use a different account to make this donation. Do we have any Solana token here? Nope. Do we have any Solana token here? Nope. So we can, let's see, if you want to get free Solana token airdrop, you need to come online. Hope not here. Here is that Solana. Let's see if we can do this from here. I don't need this anymore since it's online. Say Solana airdrop to this. No, Solana airdrop, and let's copy this address. And come on, what is wrong with you? Okay, I'm just gonna do this instead because I don't have time for this nonsense. I think I have some Solana tokens on this wallet. Okay, let's see that. Yeah, I do have some Solana token. Let's donate like one of that. Connect. So I'm gonna refresh this. So we have this now. I'm gonna donate 1.5 Solana tokens here. Confirm this. Okay, and you can see it has already been submitted, but it's not confirmed. But I'm just doing that. I could also donate one Solana token here as well. You can see it's, so those are some really cool stuff. You guys should make some donations, interact with the application. I'm going to drop the URL, at the description section, and also the what's it called, the Git repository. I'm going to make it all public. Okay, so I'm just glad that we kind of are done now. All right, so let's conclude. Hooray! So we crushed that. I really don't know how long that tutorial took, but when I'm editing, I'm going to find out the final length of that tutorial. I hope you were stoked and you enjoyed the entire process. And at this point, to be frank with you, if you are able to accomplish that, that means you'll be able to build just about any Solana project that you want. Okay, very cool. And there's one more thing that I would like to do on this Solana before I kind of conclude. I want to do a platform where we can bid. Oh, I'm giving you a hint, but I want to do an asset-based system where asset can be managed like an NFT-based stuff, where it can be transferred to each other. It's not like the token one that I did, but this one is like an NFT. But we're not just going to do NFT. We're going to do a real life project where it can be utilized for something good. In this channel, we kind of try our best to do real life project. You can see with the voting application, which is being used on real life, which can be used on real life, and you can see this crowdfunding application, which is also a real life, use case. And I would like to do something where people participate in trading and purchasing stuff, something that is real as well. So I want to bring in that NFT-based system into development. I'm not going to be using Solana program library. I want to use Anchor itself. I want to customize it to my own taste and to that level. So this is what I want to do next. And I'm sure a lot of you guys vibe with me, and a lot of you would like to see how NFT based system is done with Anchor and all of those things then all together. So that is what we are going to be doing next. Please, if you haven't subscribe to this channel, I really would recommend that you hit that like and subscribe button and smash that notification bell. Be part of this channel, okay? Don't be a visitor, don't be a stranger, be a member, okay? Smash that like and subscribe button, hit that notification bell. We really will need that to push these things up and running on the internet, and to increase the visibility of it so other people can go through it as well and appreciate the free and good work that are being done here at dApp Mentors. So my name is Darlington Gospel, and I'm your mentor here in dApp Mentors. Please, if you have any question, you can drop in the comment section. You can also join the Discord channel where you can drop more technical questions, and the community there, we can attend to you, including I myself, who is in that community. Okay, so if you haven't watched the previous ones, please go watch that previous videos. They kind of set the tone and the basic step for you to come into these ones. And for Solidity fan and Solidity community, I plan on modifying the other crowdfunding application. I'm not going to reshoot the video, but I'm going to update the application so that it can work in line with all the experience that I've gotten now, and it will be smoother for you. So if you have any issues on that project, by the time I have updated it, all you just need to do is to look it up on GitHub, and you see how the changes I'm going to do. In fact, I'm going to put it on a dedicated branch itself. I'm just going to put it on the main branch so that everyone can start operating with it. So that is all there is for this particular tutorial, and I'm glad and happy to have crushed it up with you here. So I'm just gonna go now, and I'll see you guys next time. Bye bye.